Alright people, I'm not here to waste your time. I can spend all day talking about why this Excel course is better than all the other ones that you can find. Trust me, it would be easy. But instead, let me give you 3 facts. Fact number 1, you get to learn from Travis Cuzick, who has been architecting and coding data solutions for over a decade and has worked for some of the biggest Fortune 500 companies in the world. That's right, he walks the walk. Fact number 2, as you can see from the length of this course, Travis isn't just going to teach you the basics. He's going to cover the topics to get you started on your path to becoming an Excel master. Topics like filtering and sorting data, formulas, functions, plus expert tips, tricks, and advice that you can't get from anyone else other than someone that has years of experience in the industry. Fact number 3, your learning won't have to stop here with no clear next steps. This crash course is actually part of Travis's complete Excel Bootcamp course on Zero to Mastery's Academy. So after you finish this crash course, you can dive deeper and keep learning by taking the rest of Travis's complete Excel Bootcamp course. And you'll learn advanced topics like data visualization, pivot tables, macros, VBA, plus the exact steps to get hired and start your career as a data professional. His bootcamp has taken people from complete beginners to professional data analysts, and he can do the same for you. Better yet, you'll get access to Travis's other courses on topics like business intelligence with Excel, Power BI, VBA programming, so you can become a top 10% data analyst. So once you finish this crash course and are excited to keep learning, check out the link in the top right hand corner and in the description down below. There might even be a small discount in there for you, but only for a limited time. Enough chit chat from me. Let me hand it over to Travis so you guys can start learning Excel. Enjoy.
Let's get our hands dirty and dive into opening the Excel application and creating a new Excel workbook. Let's take a moment to save ourselves a lot of time in the future by pinning the Excel application to our taskbar. That is to say, the list of icons at the bottom of your screen. Since we're going to be opening Excel hundreds of times throughout this course, it makes sense to shave as much time off this process as we possibly can. So to do this, right-click the Excel icon and then choose Pin to Taskbar. Great! Now we can just left-click the Excel icon that now appears in our taskbar to launch Microsoft Excel. Alright, now that we have Excel open, we are presented with a screen that gives us a few options for creating a new Excel workbook, which is where we can actually start doing useful work in Excel. The first option, which is the one we will be using, is to simply create a brand new blank workbook. This will be a completely empty slate for us to work with. The other options are various kinds of templates that Microsoft provides to assist with some of the more common uses of Excel. For example, there is a nutrition tracker spreadsheet template that you could use as a starting point if you wanted to count calories. Instead of needing to create your own nutrition tracker spreadsheet from scratch, you could start with the template and modify it with your own information as needed to save time. But we're here to learn how to build our own spreadsheets, so let's go ahead and click the Blank Spreadsheet option. Alright, now that we have Excel open, you can see that it is fundamentally a giant grid, organized by rows and columns. The rows are ordered numerically, starting with the number 1, while the columns are ordered alphabetically, starting with the letter A. At the intersection of each row and column is what's called a cell. Cells are the fundamental building blocks of Excel. They are where we enter and manipulate the data and calculations that make up the heart of most spreadsheets. Right now, by default, the cell at the intersection of the first row and the first column is selected. This is called cell A1 because it is in column A and row 1. And if we look at this little box above and to the left of the grid, we can actually see the address, as it is called, of the cell that is currently selected. And if we select a different cell, let's say at the intersection of column H and row 7, we'll see that the cell address changes to, you guessed it, H7. So at this point, you might be wondering, just how big is this grid? Right now, we can only see around 20 rows and 20 columns. Well, the answer, it turns out, is pretty daggone big. A single grid can have over 1 million rows and over 16,000 columns. Multiply those two numbers together, and you have an idea of how many cells are contained in this single grid. Don't believe me? Let's scroll around a little bit to get a better idea of the terrain we're trying to explore. So there are a number of ways to navigate the grid. If you just want to scroll up and down, which is probably the most common form of navigation, you can just use the little wheel in between the buttons on your mouse. Rolling that wheel forwards and backwards will scroll you up and down through the spreadsheet. You can also use the scroll bar on the right side of the Excel window to scroll up and down, and the scroll bar at the bottom right to scroll from side to side. To do this, just click the bar, hold down your mouse button, and drag to go back and forth. Now you might be noticing that we're not able to scroll much beyond the portion of the grid that is currently visible to us. This is because we haven't entered any actual data in the spreadsheet that Excel thinks is worth scrolling to. However, by clicking and holding the arrows at either end of the scroll bars, you can scroll back and forth across the grid as far as you'd like, regardless of whether we have any data in it or not. So let's try using this technique to scroll right and see more columns in our grid. So I'll just click and hold this arrow on the right side of the scroll bar at the bottom right, and you can see that we pretty rapidly scrolled quite a few columns to the right. Alternatively, if you don't want to scroll quite so fast, you can actually just single click these arrows, and you can move back and forth in that manner incrementally, a little bit fewer columns or rows at a time. Now you might have been wondering, considering our grid has over 16,000 columns, how this alphabetical sequencing might work once we run out of letters. Well, now that we've scrolled past column Z, you'll see that the sequencing starts over again with column AA and AB and so forth. And this goes all the way to AZ, at which point the pattern starts again with column BA. Okay, now we have a basic understanding of how the Excel grid is structured and how we can navigate it. But what about this big, crazy-looking menu directly above the grid? Well, it's actually not just one big, crazy-looking menu, it's several. If you look at the word Home on the menu, you'll see that it is underlined. This indicates that it is the active section of the menu. So what happens if we click on the neighboring tab, Insert, on the menu? Well, now we get a whole new set of options and commands on our menu. And as you might have guessed, each of the other tabs we see here reveal a whole new category of options to us. Now this may seem a little overwhelming, but it's important to keep a couple of things in mind. First is that Excel is a truly massive application. It is considered by some to be the single largest piece of software ever written. That means it has a ton of functionality, and all of that functionality needs to be organized in a way that won't drive users absolutely crazy. The layout we see here, which is called the ribbon, was Microsoft's best effort to do that. The second thing to keep in mind is that the vast majority of users will only use a tiny fraction of all that functionality. There are buttons and widgets and submenus under some of these categories that are essential to a small percentage of specialized users, say, for example, scientists and engineers, but would have little to no value for a typical user. In this course, we're going to focus on, roughly speaking, the 5% of Excel's functionality that you'll use 95% of the time. 100% of the functionality would probably take the rest of my lifetime to explain, and the rest of yours to listen to me explaining, and that doesn't sound like much fun for either of us. So the bottom line is, don't worry about memorizing where to find what command in the Excel ribbon. Instead, think of each tab as a category of commands, and then think about which of these categories the thing you're looking for or trying to do fits best under. Then just look under that tab first. Then once you're on the tab, look at the various subcategories that the commands on that tab are broken up into, which you will see at the very bottom of the menu. For example, on our Home tab, we have subcategories like Clipboard, Font, Alignment, and so on. Now, say I needed some help with a financial calculation in Excel. I might start by clicking the Formulas tab, and then poking around until I saw a subsection that appears to be aligned with my goal. So in this case, there is a Function Library subsection, and then a drop-down menu within that has more information on financial formulas. That's probably a good place to start. Now, navigating the ribbon is an inexact science, and even as an experienced Excel user, I often don't go right to a command without some clicking around. But once you get the general idea of how the ribbon is organized, it normally won't take you too long to find what you're looking for. Okay, so at this point, my goal for you is to have a general understanding of how the Excel interface is structured and how to navigate it. I highly encourage you to click and scroll around and just generally explore, which is a great way to get a better feel for the environment we'll be working in. Up next, we're going to go from exploring the Excel interface to actually entering our own data into a spreadsheet. We'll also look at various options for saving workbooks so we don't lose the data and calculations we have stored in them. I'll see you then. Welcome back. In this one, we're going to pick up right where we left off. So if you don't already have a blank Excel workbook open, go ahead and open one now. So we now have the lay of the land, so to speak, of Excel and its user interface. That means it's time to actually start entering data into an Excel workbook, and then learn how to save workbooks so we can access them in the future. Let's start, in the storied tradition of so many programming tutorials, with the classic Hello World example. So making sure that cell A1 is selected, go ahead and type Hello World and then hit Enter to commit your changes to that cell. So we'll just go ahead and type Hello World and then hit Enter. And our giant blank grid is blank no longer. We have now made our mark on Excel. So let's suspend disbelief for a moment and pretend that we just entered something really cool or important in the spreadsheet. In that case, we probably wouldn't want to risk losing the data we had entered when we close out of Excel. So how do we save this workbook so we can access it later, long after we have closed Excel or even shut down our computer? Well, saving workbooks is such an important task that there are actually many ways to do it in Excel. This is a theme we will encounter often with Excel, that there are often, if not always, multiple ways to accomplish a given task. I'll normally stick to recommending the method I feel is the most straightforward or easiest to remember, but in this case we'll walk through a couple of approaches just to give us an opportunity to further explore the user interface. So if you turn your attention to the little menu at the top left corner of our Excel window, you'll see a funny little icon that is recognizable if you're a person of a certain age, like yours truly, and which will seem kind of bizarre to anyone else. This little square is meant to represent a floppy disk, which for those of you not of a certain age, was a computer storage mechanism popular roughly in the time of the dinosaurs. This icon is part of another menu, distinct from the ribbon we already took a brief tour of, called the Quick Access Toolbar. This menu is meant to contain shortcuts or commands that are used very, very frequently by most users. Saving a file is, naturally, one of those types of commands. And as you might have guessed at this point, clicking this floppy disk icon will tell Excel that we want to save the current workbook. So let's click it and see what happens. As you can see, we are now presented with a dialog box prompting us to enter a name for the file and a location where we want to save it. Pretty self-explanatory. So let's enter a name. I'll go with Hello World, and then I'll browse to a folder on my computer where I can save it. So I'll just type Hello World, and then if I click this Choose a Location dialog box, my machine lists some folders I have recently interacted with. Now let's say I don't want to save the file in any of these folders. In that case, I'll simply scroll down to the bottom of the list and click More Locations. This takes me to the Save As screen, where we again have a number of options to choose from. Let's ignore the menu on the left side of the screen for now, and focus on the middle of the screen, which gives us all the commands relevant to saving a new file with a specified name and location. We ended up here because we didn't want to accept one of the suggested locations for our Hello World file, so the natural option is to click Browse. This brings up a dialog box that will allow us to browse our file system to find whatever folder we would like to save this file to. I've gone ahead and browsed to my Hello Excel Part 2 folder, which I had already created. Now before clicking the Save button, as tempting as that might be, I do want to point out the Save As Type drop-down list right below our file name. This Save As Type dropdown allows us to save an Excel file in a wide variety of formats, as you can see here. The bad news is that there are a ton of these formats, but the good news is we are going to be using the default format, Excel Workbook, 99.9% of the time. So for now, don't worry about all these other formats. We'll cover a few others as needed in future lessons. But enough on that for now. Let's go ahead and click Save to save our file. And if we wait just a moment for Excel to finish, we can now see that the name of the spreadsheet reflected at the very top of our Excel window is Hello World, which means our file has been successfully saved. Now that we have our file saved, let's put our work to the test by closing out of Excel and then seeing if we can reopen our file. As with almost everything in Excel, there are actually a few ways to close the application, but the easiest one, and the most intuitive, is to simply click the big X at the top right corner of the screen. And if we do that, the Excel window should disappear. And now we can reopen Excel using our icon that we added to our taskbar. And we are again presented with the Excel startup screen that we first saw when we launched the Excel application in the last video. This time, we're going to click the Open option on the menu on the left side of this screen, which takes us to another screen that will allow us to open an existing Excel file. Now, if you have sharp eyes, you might have noticed that there is a Browse option here, similar to the one that we saw when we were choosing a location to save our Excel file. And much like when we saved that file, we can use this Browse option to navigate to a location where the file we want to open is saved. Now, you might also notice that there is a list of recently accessed files on the right side of our screen here, which includes the file that we just saved. And while that would actually be the easiest way to access the file in this case, I do want to show you how to browse to a file that we didn't just access to open it. So let's click Browse once more. And again, I've navigated to my Hello Excel Part 2 folder where we find the file that we just saved. So now that we've found the file, all we have to do is click it to select it, and then hit the Open button on the dialog box. Awesome. Now we're right back where we started with our Hello World file open. Now let's say we want to modify the contents of our spreadsheet in some way. Maybe we want to express our enthusiasm for Excel and add an exclamation mark to our Hello World message in cell A1. Now we'll cover more techniques for editing data in cells later, but for now, let's just make sure cell A1 is selected and then type Hello World exclamation mark and finally hit Enter to commit the change. So I'll go ahead and do that. So if we want to save this amazing change we just made, do we need to go through that whole process of choosing a file name, then a location, all over again? Absolutely not. Instead, we can simply save the file in place with a single command. In fact, simply clicking the little floppy disk button in our Quick Access toolbar would do the trick. But if we hover over that button, we'll see something interesting. Excel doesn't just tell us what the command does, it also suggests, in parentheses, a keyboard shortcut we can use to execute the command more quickly. Now, if you're not familiar with keyboard shortcuts, they are simply combinations of keystrokes that you can type on your keyboard to perform certain common commands quickly. And while you can definitely go overboard by trying to memorize every keyboard shortcut Excel gives you, and there are a ton, remembering a few of the most useful ones is an absolutely invaluable time saver. So let's take Excel's suggestion in this case and hold down the Control key and the S key at the same time. Just as an aside, most of these keyboard shortcuts in Excel involve holding down 2 or more keys at the same time. So if I reference a keyboard shortcut as, say, Control A, that doesn't mean press Control and then press A. It means hold down both of those keys at the same time. So let's hold down Control and S at the same time. And now if you look at our file name at the very top of the Excel window, you'll see the word saved after the name. So now you know that our most recent changes to the file have in fact been saved. And going forward, saving changes to our file will be just that simple. You only have to select a name and a location the very first time you're saving a file. After that, you can save each additional set of changes as often as you want by hitting Control S. Now, speaking of that, I highly recommend hitting Control S early and often as you are working with Excel. Excel is an application that runs on your local machine, which means it is just as prone to crashing as your machine is. If your machine's memory is bogged down, either with another application or maybe something you're doing with Excel, it's quite possible that the Excel application could crash. In that case, Excel will only keep the changes you have made to your file up to the last time you clicked Save. So let's say you've been working in your file for an hour and you never clicked Save. Well then, when your machine crashes, all of your work will be lost. I would call that a bad day. Excel pros know, save early and save often. Now with that said, sometimes we don't want to keep the changes we've made. For example, let's select cell A1 again, and then hit the Delete key on your keyboard to delete our little Hello World message. Now click the red X at the top right corner of the Excel window to close out of Excel. And my apologies for referring to it as a red X when it's really only a red X when you hover over it. Let's just call it the X at the top right corner that turns red when you hover your cursor over it. So if I click this green/red X, Excel asks us if we want to save our changes to our file. This is because we have made a change to the file since the last time we hit save. Now we don't want to undo all of our hard work in typing Hello World, so let's click Don't Save. That will keep our file in the exact state it was as of the last time we hit save, so our friendly Hello World message will be preserved. So at this point, we know a little bit about how to save our work so we can re-access it in the future. But with apologies to our Hello World message, we haven't really learned how to do any work worth saving. That's what we'll begin to explore in the next video, where we will dive into a variety of data entry techniques that let us enter data into the Excel grid efficiently and effectively. I'll see you then. Welcome back. Now that we have our arms around the Excel user interface, let's learn how to put Excel to work by actually entering data into the grid. So if you don't already have Excel open, go ahead and open a blank workbook. Now for our example, Let's say you own a food truck, specifically a Hawaiian shave ice truck, and you want to track how different flavors sell relative to each other. Excel, with its nifty grid layout, is perfectly designed for this type of tracking and data entry. So let's say our first customer ordered 1 grape shave ice and 2 cherry shave ices. Well, if you think about it, we really have 2 different data points we're trying to track here: the flavors that were sold and the quantity of these flavors that were sold. In this case, we have 1 grape and 2 cherries. So what we'll do is type our flavors out in column A and the associated quantities in column B. First, let's select cell A1 and type cherry. Now, up to this point, we've always hit the Enter key after entering data into a cell to commit the change to that cell. But hitting Enter selects the next cell down. That is to say, the cell in the same column, which would be column A in our case, but the next row. But we want to enter quantities in column B, so we actually want Excel's focus to move from cell A1 to B1 when we commit the change that we're making to cell A1 here by typing in the word cherry. So how do we commit the change in cell A1 while moving to the right to cell B1? The answer is to hit the Tab key instead of the Enter key. This has the same effect as hitting Enter, except that the cell to the right of the current cell will be selected. So if we hit Tab, you'll see the focus moves to cell B1. Now we can enter our quantity for cherry, which is 2, and hit Enter. And look at that. Excel was actually smart enough to recognize that we are entering data into 2 columns, and it automatically selected the next row in the first column instead of the second column, anticipating that we would want to continue this pattern of entering data left to right. Pretty cool. That said, if for whatever reason you wanted to sidestep this default behavior and choose which cell to navigate to yourself, you can always use the arrow keys on your keyboard to do this. You can navigate one cell left, right, up, or down by just hitting the corresponding arrow key. But in this case, Excel was smart enough to put us right where we want to be. So let's get right back to entering data. So for our entry for the grape shave ice order, let's try a slightly different but equivalent method of entering data into the cell. Instead of simply typing with the cell selected, click in the formula bar, which is directly above the grid and reflects whatever value is in the currently selected cell. Then we can type our entry there. So I'll just type grape in the formula bar. And now we can hit Tab, which will navigate us over to column B. And finally, we can enter the quantity of 1 for grape and hit Enter. And that's pretty much it for the very basics of entering data into the grid. And as you can see, at least for simple scenarios like this, it's pretty straightforward. But what if we made a mistake when we entered that data and want to overwrite or change the information we entered into the spreadsheet? In this case, it's not enough to simply enter data. We need to be able to delete the existing data and replace it, or alternatively, edit the data. We'll tackle deleting first since it's a bit more straightforward. Let's say that instead of grape, the second order was actually passion fruit. Well, what we need to do is replace the word grape with the word passion fruit in cell A2. To do that, we can simply select cell A2 and then hit the delete key on the keyboard. This wipes out all the text we entered in that cell. Now we can simply type in the correct value, passion fruit, and hit Enter to commit the change to the cell. Pretty straightforward. But it's often the case that the mistake we made entering data was only a small one, and merely requires us to slightly modify the value we entered into a cell. In that case, we may not want to redo the work of typing everything we entered into the cell. Instead, we might want to just edit the value slightly and then commit that change. For example, what if our first flavor wasn't cherry, but wild cherry, which is actually one of my personal favorite shave ice flavors? If we want to avoid retyping the word cherry, then we shouldn't delete what we've already typed. It would be better to simply add some text to what's already in the cell. But how do we do that? There are two main ways to accomplish this. You can either select the cell and then click in the text in the formula bar at whatever position you want to begin editing. In our case, we want to begin editing before the first letter because we're going to append the word wild at the beginning of the word cherry, so we would just click right before the C. But for example, if we wanted to add a word to the end, you could again click in the formula bar, but at the end of the word. Now, alternatively, you can actually just double-click in the cell itself, which will place the cursor inside of that cell so you can edit the value in it. Now, I personally prefer editing in the formula bar since I find it a little easier to click directly to the position in the text where I want to begin my edit. So that's what we'll do here. Now, we actually want to begin our edit before the word cherry, as I mentioned. So with cell A1 selected, I'll click in the formula bar before the letter C, and then I'll type the word wild followed by a space. And then finally, I'll just hit enter to commit the change. Now, you can also modify portions of the text in a cell, as opposed to simply tacking on new text. For example, let's say I wanted to replace my wild cherry entry with the synonymous Bing cherry. To start, I can select cell A1 and then click in the formula bar to start editing. Now, I could either click before the word wild and then hit the delete key 4 times to remove it, or I can click after the last letter of wild and hit the backspace key 4 times to remove it. Then, with that word removed, I can simply type the word Bing and hit enter. So now we've learned how to enter, delete, and edit data in Excel. But before we go, I want to share a sentiment from one of my favorite old movies. And that is, you should always be able to get out of trouble faster than you got into it. Fortunately, Excel gives you a couple of easy ways to do this. The first method is to simply hit the escape key to escape whatever mess you've made in a cell that you're trying to edit. So let's say I want to edit Bing cherry back to wild cherry. So I click in cell A1 and delete the word Bing. But then I change my mind and decide I want to leave the cell as is. Well, as long as I hit the escape key before hitting enter to commit the change to that cell, Excel will let me off the hook, so to speak, and ignore any edits I was making to that cell. So you can see how the cursor is flashing in the formula bar. That lets us know that Excel recognizes us as actively editing this cell. As long as it thinks we're actively editing this cell, if we hit the escape key, it's just going to ignore any changes that we've made up to that point and revert the cell back to its previous state. So if I just hit escape, it's like nothing ever happened. It's like we never even attempted that edit. But what if I've already hit enter and committed the change to the cell? Well, that's where the undo command comes in handy. Undo will simply reverse the effects of the last change you made to the spreadsheet. So if your last change was entering data to a cell, undo will delete that data. On the other hand, if your last change was deleting data, Excel will reinsert that data. Now, given how error-prone manual data entry is, along with many of the other tasks you can perform in a spreadsheet, the undo command is absolutely essential. So how do we access it? Well, there are 2 main ways. First, there's this little curved arrow in the quick access toolbar that executes the undo command. And the fact that this command is in the quick access toolbar is indicative of just how useful and frequently used it is. But my rule of thumb for quick access toolbar commands is that anything that's used that often is probably worth memorizing a keyboard shortcut for, because it's just faster for most people to make a couple of quick keystrokes than it is to navigate to a button in the Excel interface. So the keyboard shortcut for undo in Excel is Control plus Z. Now this is definitely one that's worth committing to memory. So let's say we decide to stick with the wild cherry nomenclature over Bing cherry. This means we need to undo the last change we made to the spreadsheet, which was changing wild cherry to Bing cherry. Now you might be thinking that somehow that attempted edit we made just a moment ago that we escaped out of would count as something that would be undone, but it actually doesn't, because nothing was technically done as a result. We attempted a change, but we never committed the change. So because we never committed it, we never made it permanent in the cell, from Excel's perspective, there's really nothing to undo. So if we hit Control Z here, like magic, cell A1 reverts to its previous state. And if we wanted to continue hitting Control Z, we could keep undoing the various changes we've made all the way back to a blank spreadsheet. Now there are a small handful of changes you can make in Excel that undo cannot reverse, but the vast majority can be reversed by undo. So this is a command to make friends with early because you will use it often. All right, up next we're going to look at some ways to make our data entry less repetitive and more efficient. I'll see you then. Hey, welcome back. Now that we've learned the basics of entering data into Excel, let's take a look at some ways we can make this process less painful. But first, a quick confession. I hate typing, and I am absolutely terrible at it. I never took a formal typing class, to my eternal regret, which has been both a negative and a positive in my career as a developer. On one hand, my advanced hunt and peck technique is a little embarrassing, but this has also forced me to look for all sorts of efficient alternatives to typing. If there's a way to get around having to type out a word, I'm in. And it turns out that I must not be the only one, because Excel gives us lots of ways to avoid redundant typing when entering data into the grid. So here I have an expanded version of our little shave ice ledger that we worked on in the last video. Clearly business has been good because we've made a few more sales since then. We're going to use this data as a jumping off point to explore some new methods of data entry in Excel. But before we start entering data, I want you to take note of the way this data is structured. Specifically, that we now have headings above each column of data. So our data is organized in columns, each of which has a heading that indicates what sort of data is in that column. Then each row in our data pertains to a specific thing or entity, to use developer speak. In our case, the thing in question is a customer order, consisting of a shave ice flavor and a quantity. Then each column contains some particular piece of information about that thing. So if, say, row 2 pertains to a particular customer order, column A tells us about the flavor the customer ordered, while column B tells us the quantity. And if we wanted to capture more different pieces of information about each customer order, those pieces of info would be stored in their own separate columns. We would simply keep adding new column headings that describe what information is being captured, and then fill that information in for each order. Data organized in this fashion is called tabular data, and it is much, much easier to work with than data organized in a less rigorous way. Time and again throughout this course, we will use features of Excel that are designed to work with tabular data that wouldn't work, or at least work as well, with data structured in a more haphazard way. I want to introduce you to this way of organizing data now because it will make your life much easier if you get in the habit of making your data tabular whenever possible. But back to our exploration of data entry. we've built up a ledger of 10 customer orders representing a variety of flavors. Now, because we sell a limited number of flavors, we see the same flavors being repeated over and over again. We have multiple entries for snow cream, we have multiple entries for blackberry, etc. So the next time somebody orders snow cream shave ice, wouldn't it be nice if I didn't have to type all that text again, but instead could somehow duplicate the text I already typed previously? Well, you actually can with the copy command. So let's say a customer orders 1 snow cream shave ice. Now, I could type that out in cell A12, but a better way is to click in another cell in which I've already entered the text snow cream, copy that value, and then paste it, which is the preferred terminology for depositing whatever data you've copied, into our destination cell, which is cell A12. But how do we copy in Excel? Now, as always, there are several different approaches. If you prefer the mouse, you can always right-click and then choose Copy from the menu that pops up. But because this is such a frequently used command, I again prefer a keyboard shortcut. The one to use in this case is Control-C. So let's select cell A9 and hit Control-C to copy. Then, to deposit that copied value into cell A12, which is where we want to record the sale, I'll select cell A12 and then hit Control-V to paste the value into that cell. Now, depending on how fast you type and how long the string you're typing is, this may or may not have saved you much time. But when dealing with longer text strings, it's definitely a time saver, and it also helps to improve the accuracy of the data being entered. Mistakes are easy to make when manually entering data, and you could certainly imagine several variations of snow cream being typed into our ledger over time. This would make doing calculations and reporting on our data more difficult down the road. So avoiding typing is not just about being lazy, it's also about being accurate. Now, one thing to note about the copy and paste operation we just executed. We could actually continue pasting this value that we just copied into other cells in the spreadsheet as long as we want. So if I wanted to just kind of start clicking around and hitting Control-V again and again and again, we can continue pasting that value as many times as we want. This is because that data we copied remains on what is known as the clipboard, which is where data that is copied is stored in memory. And as long as we see these so-called marching ants around the cell we copied, the data we copied from that cell is still on the clipboard. And that data will stay on the clipboard until we copy something else, which would replace what is currently in the clipboard, or if we hit the escape key. Hitting escape will clear the clipboard. So after hitting escape, our marching ants go away, and we are no longer able to paste anything from the clipboard. So being able to copy and paste data to effectively reuse work we've already done is really cool. But before we go, I want to show you another really efficient method of data entry, one that is made available to us when we organize our data in the tabular fashion we see here, obviously with the exception of the random snow creams I pasted all over the grid. So let's say we have another order come in. This one for 3 passion fruit shave ices. So I could absolutely just copy passion fruit from cell A11, but there's actually an even faster way to enter this data in the cell. Let's try just typing the letter P in cell A13, where our entry will go. And look at that. Excel actually correctly guesses that we are going to type passion fruit. Because of the way our data is organized, Excel is able to make intelligent guesses like this. Specifically, Excel looks at the values above the current cell in the same column, and then attempts to guess what we are typing based on what's already been entered. So, of all the entries in column A above cell A13, If we only had one flavor that began with the letter P, Excel is able to correctly guess that we want to enter passion fruit when we type the letter P. So assuming this guess is correct and we're not trying to enter some other word, all we have to do to accept Excel's recommendation is just hit Enter or Tab if we want to go over to the column to the right. So I'll hit Tab, and just like that, we have effectively typed out passion fruit by typing a single letter. And then I'll go ahead and enter the quantity for passion fruit, and I'll clean up my entry for snow cream as well. Now on the other hand, if we type a B in cell A14, nothing happens. Now that's weird. Why is Excel not trying to read our minds this time? It turns out that's because we have two distinct prior entries in the column that began with the letter B. We have blackberry and also blueberry. So at this point, it's not obvious to Excel as to which one of these options we might be trying to type. And then even if we type BL, Excel still isn't able to guess because both blackberry and blueberry start with the letters B and L. But if we then add the letter U, suddenly Excel is able to guess blueberry. So even in a case where Excel wasn't able to correctly guess our intention from the first keystroke, it only took us typing BLU to enter the whole word blueberry. This feature, in which Excel guesses what you're going to type and auto-populates that, giving you the option to either accept or reject the recommendation, is called autocomplete, and it can be a huge time saver, especially if you do a lot of data entry. That's why tricks like these are worth mastering, and it's also why structuring your data in a way that helps Excel help us is a great habit to get into. All right, up next, we're going to take a look at another cool feature that can help us create series of data in Excel in a flash, with barely any of that annoying typing at all. It's one of the best magic tricks Excel has to offer, and I can't wait to walk you through it. I'll see you then. Hey, welcome back. This go-around, we're going to explore the Autofill feature in Excel and how it can help us generate series of data in a flash. So what do I mean by series? Basically, it's any logical sequence of data points. A series of numbers like 1, 2, 3, 4, 5, maybe a list of all the dates in the current month, or the days of the week. If you need to enter sequences like these into a spreadsheet, before you're tempted to start typing, make sure that Autofill can't do the work for you first. But before we dig into the mechanics of Autofill, we first need to learn to think like Excel, specifically to understand how it interprets and handles different types of data. This is important because how a series of values is autofilled by Excel will be influenced by what type of data those values are. So broadly speaking, there are three major types of data that are interpreted and handled in distinct ways by Excel. The first is numbers. Obviously, this could mean dollar amounts, quantities of something, or even percentages. Now note that if I type a number, say 7, in cell B1 and hit Enter, Excel automatically aligns the value in the cell to the right. This is indicative that Excel understands that this value is a number. The second major data type is dates and/or times. Now in the end, dates and times are really one and the same in Excel, as we'll explore in much more depth later. So if I type 1/1/2021 in cell B2 and hit Enter, you'll see that Excel again aligns the value to the right side of the cell, as distinct from, for example, the headings that I've typed out in column A, all of which are aligned to the left. And if you turn your attention to the number section of our current tab on the ribbon, you'll see that Excel has correctly guessed that our value here was a date. Now lastly, text data is pretty much anything that is not a number or a date. For example, if I type the phrase some text, you can see that Excel recognizes that as text because now it's aligning it to the left. The text data type is kind of a catch-all. Any collection of characters like what I just typed, things like people's names, shave ice flavors, etc., could all be categorized as text. You get the idea. So now that we know about the different types of data that Excel recognizes, let's take advantage of that knowledge by creating some sequences of those data types, with some help from the Autofill tool. As our first example, let's try to create a series of numbers from 1 to 10 in column D. First, type the number 1 in cell D1 and hit enter. Now is where the fun begins. Select cell D1, the cell we just typed the number 1 in, and then hover your cursor over the bottom right-hand corner of the cell until the thick white plus sign icon turns into this thinner black plus sign icon. Once this icon, which is commonly known as the fill handle, appears, click and hold down your mouse button, and then drag from cell D1 to D10. Okay, so this isn't exactly what we signed up for. I was promising you sequences of data, and all we appear to have done here is copied the number 1 10 times. And while that in and of itself could be a useful task, it's not what we're trying to accomplish here. However, if we click this little box that has appeared at the bottom right of the range of cells we just filled down, you'll see that Excel actually gives us multiple options for how we want the autofill mechanism to work. The copy option is selected by default, which is why the number 1 was simply copied in every cell we autofilled. However, if we select the fill series option, success! We have now generated a series of numbers from 1 to 10 with a couple of keystrokes and a couple of mouse clicks. And while this saved us just a little time on this small series of numbers, imagine if you needed to type out numbers 1 through 100 or 1 through 1,000. The longer the series, the more time autofill can save you. So Excel is smart enough to understand what a number is and how to logically build a sequence of numbers based on whatever value we chose to fill down. But it's also smart enough to recognize more complex types of series than the simple 1, 2, 3, etc. we just demonstrated. Let's say instead of generating a sequential series of numbers, we instead want to generate a series of odd numbers. Our little autofill menu here doesn't have an explicit option for this, but we can give Excel a hint about what we're trying to do that it's smart enough to pick up on. So let's say we type the number 1 in cell F1, and then the number 3 in cell F2. At this point, we have essentially created the beginning of a sequence of odd numbers. Then we can highlight both of these cells by clicking in one, holding down the mouse key, and then dragging to select the other. Similar to before, we'll hover our cursor until we see the fill handle. The only difference between this and what we did previously being is that instead of hovering our cursor over the bottom right-hand corner of a cell, we instead hover it over the bottom right-hand corner of the range of cells we've selected. So finally, with that fill handle activated, we can simply click and hold our mouse key and then drag down as many cells as we want. And as you can see, Excel was smart enough to recognize that we were trying to create a series of odd numbers and was happy to oblige us. Pretty cool, right? Now let's take a look at generating series of dates. I'll start by copying our date from cell B2 into cell H1 using the Control-C and Control-V keyboard shortcuts we learned in a previous video. Then, to create a series starting with this date, we can use the same technique that we used to generate a series of numbers a moment ago. If we just hover, click, and drag, Excel automatically generates a sequence of dates starting with January 1st, 2021. Unlike with the numbers, Autofill's default behavior with dates is to generate a sequence as opposed to just copying the same date down. But again, we can override that default using the Autofill menu if we just choose Copy Cells as opposed to the default of Fill Series. And Excel's autofill tricks actually extend beyond just numbers and dates. So if I just type Sunday in cell J1 and then hover, click, and drag, suddenly I have a list of all the days of the week. Similarly, if I type January in cell L1 and then again hover, click, and drag, sure enough, we get a list of all of the months of the year. So in these cases, Excel recognizes that the word Sunday or the word January has a special meaning, and it's able to leverage that knowledge to help us generate these series with ease. Now obviously this doesn't work with every type of data. If I just type my name in cell N1 and try to fill that down, nothing really interesting happens other than it gets copied a bunch of times. And if I click the autofill menu, we don't even see that fill series option available because there's no logical way for Excel to create a series starting with my name. Okay, so lastly, let's take a look at a practical example of using the autofill tool in which we can quickly populate a new column on our shave ice ledger from the last video. So if you want to follow along, open up the shave ice file, and then in cell C1 type order number. This is the header of a new column in our little ledger here, in which we'll assign a unique number or ID to each order. The first order should get a 1, the second order a 2, and so on. So we can just type a 1 in cell C2, hit enter, and then select C2 and hover until we see our little fill handle. Now at this point, we could just click and drag like we did previously, but if you're auto-filling data in a column that is adjacent to other data, as is the case here, where the next column over has our order quantities, Excel is again smart enough to guess what we're trying to do, so it actually gives us a shortcut to fill our number down to the end of our data set. So if we simply double-click our fill handle icon, the number 1 automatically populates down to the last row of the little table of data we've created. Now, of course, we can just click the autofill button and choose Fill Series to get our sequence of order numbers. This is just another example of how organizing our data in this tabular way helps Excel help us. Excel really likes structured data and rewards us for it with goodies like autofill. All right, now that we've got lots of tricks for creating lists of data up our sleeve, we can take a look at some ways to efficiently select and manipulate these ranges of values. We'll tackle that in the next video. I'll see you then. Welcome back. With all the tricks we've learned so far for efficient data entry, it hasn't taken much time at all to build up quite a sizable ledger of shave ice entries. And as you can see here, we're now up to 100 customer orders in our ledger. So now that there's more data in our ledger than we can view at a time on our screen, there are some additional considerations we need to keep in mind. Large data sets like this, and to be honest, this wouldn't really qualify as large in the real world, but it'll do for our purposes, can become quite cumbersome to navigate without some really clever techniques, unless you like scrolling and dragging over large portions of spreadsheet real estate. As an example, if you're maintaining a ledger or tracker like this one, it's very common to want to go to the bottom of the list quickly so you can make a new entry. Before that was easy, but now we have to scroll all the way down to the bottom of this list. And the problem is only going to get worse as we accumulate more and more data. But fortunately, there's a keyboard shortcut that will take us straight to the bottom of our data with just a couple of keystrokes. And that is Control plus down arrow. So as long as we've selected some cell anywhere in our data, if we just hold down Control down arrow, Excel will automatically select the cell in the same column, but in the last row of our data, as we see here, our 100th entry in our tracker. Likewise, we can use Control plus right arrow to navigate to the end of a particularly long row of data. So if I just wanted to go to the right of the current row we're in, row 101, I could just hit Control right arrow, and that moves me to the rightmost column of our data. But since datasets tend to be longer than they are wide, which is to say they tend to have more rows than columns, this shortcut is used quite a bit less frequently than Control down arrow. Now, in addition to using a keyboard shortcut to simply select a cell in the last row of our data, we can also use another one to quickly select all the cells in one of our columns. So why might we want to do this? Well, let's say we don't like the order of our columns as we have currently laid our spreadsheet out, and want to put our flavor and quantity columns after the order number column we created in the last video. That means we'll need to select all the data in those first two columns so we can copy and paste it after the order number column. So to do this, click in cell A1 and then hold down Control Shift down arrow. Keep in mind this is a 3-keystroke keyboard shortcut, so you'll want to hold down all 3 keys at the same time. So Control Shift down arrow, and you'll see that all of the data in that column has now been selected. Now the goal here is to move this data after our order number column, so we can Control C to copy it, and now all the cells from A1 to A101 are on the clipboard. It's worth noting, and we will be using this nomenclature going forward, that a collection of cells such as this is referred to as a range. So to paste this range of cells into column D, we'll first want to select the very first cell that we want our copied data to appear in. That would be cell D1, and then just hit Control V. Finally, we can again use our Control Shift down arrow shortcut to select all the data in column A, and then simply hit the delete key to remove it. So again, I'll select cell A1, Control Shift down arrow, and then hit the delete key. So we approached moving the data from column A into column D as a 2-step operation, and there's nothing wrong with this. However, when you want to move data from point A to point B, and you no longer actually want the data to be in point A, there's actually a faster approach than copying the data to a new location, then deleting it from its original location like we did here. This alternative approach involves the cut command, which we can access with the Control-X keyboard shortcut, or alternatively, the menu that appears when we right-click in a cell. As with copying, cutting data puts it on the clipboard so we can paste the data to a new location. But unlike copy, cut will remove the data from its original location after it's been pasted. So in this case, it looks like the cut operation is more along the lines of what we need. So let's actually Control Z a few times to revert our data back to its original state, and then see how we can perform the same operation in fewer steps with Control X. So after undoing our recent changes, we'll again use Control Shift down arrow to select all the data in column A. Then we'll hit Control X to cut the data, and finally select cell D1, then Control V to paste. And as you can see, the data disappeared from its original home in column A and moved over to its new home in column D. Now, we unfortunately need to perform this same operation on the data in column B now. This seems a little redundant, so maybe there's a way we could have avoided having to follow these identical sets of steps for 2 different columns of data. And it turns out there is. We actually could have selected both columns A and B at the same time, again using our handy keyboard shortcut. So let's undo our way back to the start once more using Control Z and see how this would have worked. So after undoing our changes, instead of just selecting cell A1, I'll instead click in cell A1 and then drag right to select cell B1 as well. Alternatively, I could again click in cell A1, then hold down the Shift key and arrow once right to select the cell to the right. And then, for example, if I wanted to keep selecting additional cells to the right, I could keep holding down Shift and just hitting the arrow key again and again. So with that said, using the method you like, let's go ahead and select cells A1 and B1. And then with both of these cells selected, we can employ our same Control-Shift-Down arrow shortcut to select all the data in both columns. Finally, I can simply Control-X to cut the data, select cell D1, and then Control-V to move the data to its new home. So now we have our columns in the right order, but we also have these unnecessary blank columns to the left of our tracker. We need to move our entire data set 2 columns over to the left to complete our realignment, so it would be really handy to have a quick way to select all of our data, not just the data in a single column. And this being Excel, of course there is one. So as long as our data doesn't have any gaps, that is to say empty rows or empty columns in the middle of the data, Excel will actually be smart enough to recognize the range of cells we've entered data in as a distinct entity, set apart from the rest of the grid. So if I just click anywhere in our ledger and use the keyboard shortcut Control-A, Excel automatically selects the entire range. Now it's worth pointing out that this technique does have its pitfalls. As I mentioned, our data needs to be gap-free for this technique to work properly. So if, for example, I select a row somewhere in the middle of our data set and just delete the data, and then I click somewhere above that newly empty row and then hit Control-A, you can see that Excel only selects the data above that gap. So other than clicking and dragging over the entire range, which is a time-intensive process that we want to avoid almost as fiercely as typing, what's an efficient way around this problem? Well, probably the most foolproof way of selecting a large range of cells, regardless of whether there are gaps in the data or not, is to click in the top left cell of the range, then navigate, scrolling if needed, to the bottom right corner of the range, without selecting any new cells just yet, then hold down the Shift key and click the cell at the bottom right corner of the range. This selects everything below and to the right of the top left cell and above and to the left of the bottom right cell. Basically, everything in between, regardless of whether there are gaps in the data or not. If I want to be 100% sure that I'm grabbing everything in a table of data, this is personally my favorite method because I know I'll never be surprised by having skipped over some portions of the data. So now we want to move this entire range 1 column over so that the data starts in column A. And we could certainly employ Control-X to cut the data and then paste it into cell A1. But I want to show you another method that can be more intuitive for some people, especially when it comes to moving ranges of cells around the grid. So with our range selected, hover over the boundary between the selected range and the rest of the spreadsheet. It doesn't matter which side of the range you do this on, as long as you don't do it in the bottom right corner where your cursor will turn into the fill handle. So when we hover over this boundary, the cursor turns into another different symbol. This time something that looks a bit like, in my humble opinion, a ninja throwing star. So once we see our cursor change to this icon, we can hold our mouse button and then simply drag the entire range of cells wherever we want. Now it'll be a little easier to do if we scroll all the way back to the top because we want to drag all the data to the top left corner of the grid. So let's again hover over that boundary until we see the throwing star, then click, hold, and drag over 2 columns, and now our data has been moved right where we want it. All right, Now that we know how to manipulate ranges of cells in the Excel grid, it's time to take our mastery of the grid to the next level by learning how to work with entire rows and columns. Not just where we've entered data, but the whole row or the whole column, all the way across or down. I'll see you then. Welcome back. In the last video, we explored selecting and working with what are called ranges in Excel. Basically, collections of cells on the grid. But sometimes, instead of working with a few cells at a time, it's more convenient to work with entire rows and columns. By operating on rows and columns, we're able to manipulate entire cross-sections of the spreadsheet at a time, as opposed to just a few cells. But before we get into some examples, let's begin at the beginning by simply selecting some rows and columns to visualize what we're talking about here. So here we have a somewhat jazzed up version of our shave ice truck spreadsheet that we've been working on throughout the course. One change you'll notice is that we are now allowing customers to add multiple flavors to their shave ice treats. Instead of just being able to order a cherry, for example, we're now allowing customers to add up to 7 flavors. We've also added a size column to track the size of each shave ice order. So with our example spreadsheet in front of us, let's click around and select a few rows and columns. We won't worry about doing anything constructive with them just yet. So to select, for example, column D, we simply click the letter D. That is to say, the column header itself. Likewise, to select an entire row, we just click the number to the left of the row. So to select row 5, I'll just click this number 5. And in both cases, Excel lets us know that we have selected the row or column by shading it slightly darker than the rest of the grid. And we can actually select multiple rows or columns at a time quite easily as well. For example, to select columns B through D, we can simply click the letter B to select column B, then hold down our mouse button and drag to the right until all 3 columns are selected. We can select multiple rows in this fashion as well by simply selecting one row and then dragging in either direction to select adjacent rows. Or, if you needed to select a whole bunch of rows but didn't feel like doing a lot of scrolling, you can select a single row, then scroll down to the end of whatever group of rows you want to select, and finally hold down the Shift key and then select the last row in the group that contains the rows you're trying to select. Okay, so now we know how to select rows and columns. But why would we even want to do this? Well, one action we can take on a row or column is to delete the data in it. So let's say we decided, just for example, that our flavor column in our order tracker is now redundant since we now have multiple columns capturing all the flavors in each person's order. So maybe we want to delete that data. To do this, we can simply select that column and then hit the delete key on the keyboard to clear the data. The only problem with this approach is that now we're left with this blank column. So now we would need to select all of our data to the right of this column, cut it, and then move it over to fill the blank space. That is, unless we can delete the entire column and not just the data within it. And sure enough, we can. Let's hit Ctrl-Z to undo our delete from earlier, and then select column B once more and right-click. If we look at the menu that pops up, one of the options is Delete. Now this actually doesn't do the same thing as when we hit the delete key on our keyboard earlier. The equivalent to that is actually the Clear Contents command. Choosing Delete here will actually remove the entire column and its contents, leaving no blank column in the middle of our data. So let's choose that. And as we can see, our flavor column has disappeared, and all of the other columns in our data have shifted over to the left to take its place. So we basically accomplished the same thing as deleting the data and then cutting the rest of our data to move it over. We can also delete rows in this fashion. Let's say we remembered that the first order in our tracker wasn't an actual customer order, but instead dummy data that we entered into our spreadsheet when we were first building it out. In that case, we can delete this row by simply clicking the row header, the number 2 in this case, right-clicking, and then choosing Delete. The row disappears from the grid entirely, and all the rows beneath it move up to fill the vacuum, so to speak. Now, as we saw before, we can also select multiple rows and columns. And anything you can select, you can also delete. So, say we have decided that 5 flavors are the most we can possibly fit into a single shave ice cup, and we want to delete our last 2 flavor columns. In this case, we can simply select the Flavor 6 column, hold down the mouse key, and drag to the right until the Flavor 7 column is selected as well. And then we can simply right-click and delete, and now both of the columns disappear from the grid. Now, as you might imagine, if we can delete entire rows and columns from our spreadsheet, we can also insert new ones. Something which comes in handy quite often as we're defining and modifying the structure of our data. Perhaps we learned that we failed to track one of our very first customer orders, say the 5th one, and want to add an entry for it in its correct chronological position after the first 4 entries. To do this, select the row that currently contains the 5th order, right-click, and choose Insert. This will insert a blank row above the currently selected row. Now that we have a blank row to work with, we could simply enter the details of the order we missed. We can likewise insert blank columns. As an example, let's say we want to add a column to our data that lets us track the style of the customer's shave ice order. You can either choose Island Style, which includes ice cream and a condensed milk topping, and this is my personal recommendation, or Mainland Style, which is just shave ice and flavoring. If we want to insert this column directly after our order number column, we need to select column B, which will be the address of our new column, and then right-click and choose Insert. Now a new blank column was inserted to the left of what was column B. This highlights a good way to remember how row and column insert operations work. The new inserted row or column will be located in the same slot as the row or column you had selected before the insert. If you're inserting a column, then the columns to the right of the new column will shift to the right to make room. In the case of rows, they'll shift down. So we can delete rows and columns, and we can insert rows and columns. But we can also delete a row from one location of our spreadsheet and insert it somewhere else, much like we learned to cut and paste ranges of cells in the last video. Let's say we want to change the location of our quantity column, moving it right before our 5 flavor columns. To do this, we can select the column, right-click, and choose Cut, or, alternately, the Control-X shortcut we talked about previously for cut. This will put the contents of the entire column on the clipboard. Next, we should select whatever column that we want the data we just cut to appear before. That is to say, to the left of. So in this case, we'll select the Flavor 1 column because we want this quantity column to appear immediately before that column. Then we can right-click and choose Paste. And as you can see, not only is the data now in the location we want, but the column has disappeared from its old slot. Keep in mind that we could have also used the Control-V keyboard shortcut to paste this data as well. Now you can also copy and then insert entire rows and columns, the only difference being the original copy won't disappear from the spreadsheet. But in my experience, this is useful quite a bit less often. Alright, now we have gotten a good handle on manipulating not just our data, but also the grid that contains it. But as we compile more and more data, readability and user-friendliness will become increasingly important. We'll take a look at some ways to make it easier to scan and navigate our data in the next video. I'll see you then. Welcome back. In this one, we're going to take a look at making our spreadsheets more aesthetically pleasing and, more importantly, easier to read and interpret by taking advantage of our ability to resize Excel's columns and rows. Thus far, we haven't encountered a lot of variation in the length or size of data we've been entering into individual cells, so the width of our rows and columns hasn't been much of a concern. But when, inevitably, we encounter larger values, whether they be numbers or text, that we need to enter into the grid, resizing the columns and rows of our spreadsheet to fit our data becomes crucial. Let's say, for example, we've added a new shave ice flavor called Purple Mangosteen. Yes, that's a real type of fruit. Check the interwebs if you don't believe me. If I try typing that value in our Flavor 1 column, so I'll just type Purple Mangosteen, you'll see that the value is wider than our column and the end of the name gets cut off. Now, while the value is still saved, as you can see if you look in the formula bar, this is a really bad experience for anybody who's attempting to read and interpret our spreadsheet. So how can we resize this column to fit the new value? Well, the old-fashioned way, so to speak, is to select the column we want to resize, and then hover the cursor over the boundary between the column's header and the header of the column to its right. You'll know you have the cursor in the right spot because it should change from a little down arrow, which you see when you're hovering just over the column header, to this little black cross icon we see here. Now, once we see this icon, we can click and hold our mouse button and then drag to the right to make the column wider, or drag to the left to make the column smaller. So we'll just drag the boundary out past where we think it needs to be and then let go of the mouse button. And it looks like we didn't drag it quite wide enough, so we'll go a little bit further. And there we have it. But now we know that we could potentially have to enter this extra long name in any of our 5 flavor columns. So wouldn't it be nice if we could resize all of these columns the exact same width simultaneously, as opposed to resizing them all individually? Excel actually makes this very easy. All we have to do is select all the columns we want to resize, which we can do with the techniques we learned in the previous video. So I'll just click the Flavor 1 column and then drag to the right to select all 5 of the flavor columns. And now again, I'll hover my mouse between the headers of the Flavor 1 and Flavor 2 columns until it turns into that little black cross icon, then hold down my mouse key and drag to resize the column appropriately. And then when I let go of the mouse button, all 5 of the selected columns are resized to the exact same width. Now obviously, this is a far superior alternative to resizing individually, since all 5 of the columns need to be able to accommodate the same type of data. Now, while it is done quite a bit less commonly in my experience, it's also possible to resize rows. So if, for whatever reason, we wanted to make, say, rows 1 through 5 of our spreadsheet taller, we can simply select the rows and then hover over the boundary between 2 of them to drag and resize. And then when we let go of the mouse key, all of our selected rows resize to match the height of the row that we had resized. So resizing columns, and to a lesser extent rows, is very helpful. But sometimes it may not be so obvious how wide we need to make our columns. For example, if our tracker here was thousands of rows long instead of just 100, we might not have noticed a large entry like our Purple Mangosteen getting cut off by columns that were too narrow to accommodate them. Insidious little formatting issues like this are why it's often helpful to let Excel decide what width the column needs to be to accommodate the data within it. The feature that does this is called Autofit, and if you use Excel much, I guarantee it will quickly become one of your go-tos. So to demonstrate Autofit, I'm actually going to Control-Z back to before we manually resized our flavor columns. Now we see that our purple mangosteen value is again being truncated by the column it's contained in. So to use Autofit to right-size our column once again, we can again select the entire column, which we actually already have done here, and then hover between the header of our selected column and the column to the right until we see the little black cross icon. But now instead of clicking and dragging to manually resize, we simply double-click. And poof, like magic, the column automatically resizes to snugly fit our data. And we can apply Autofit to multiple columns at a time as well. To demonstrate, let's fill our purple mangosteen value across to all 5 flavor columns in the first row of our ledger. So I'll just grab the fill handle of that cell and fill to the right. So now we need to resize all of these columns to fit the new value. All we have to do here is actually just select all the columns that we want to apply Autofit to, and then double-click between any of the column headers. It doesn't matter which one you choose, as long as it's not the boundary between the leftmost column we've selected, column F, and the column to the left of it, column E. Any of these other boundaries are fair game. So we'll go ahead and double-click, and after double-clicking, all of our selected columns automatically widen to the appropriate size. Awesome. And as convenient as this was, the more columns we need to apply this operation to, the more time Autofit can save us. Along those lines, we can actually Autofit all the columns in the entire grid in one fell swoop. If you want to be consistently sure that all of your columns are fit correctly to their data, this is a great habit to get into. Let's Control-Z to undo our Autofit of the flavor columns so I can demonstrate this shortcut. Our first step will be to click just above and to the left of the Excel grid, the corner of the grid, if you will. This selects all the cells in the entire sheet, which means all the columns are selected by default. So now, with all the columns selected, you can trigger Autofit like we have in every other example. Just hover your cursor between any 2 column headers and double-click. And just like that, all of our columns are automatically fit to their data. This includes a few columns that actually got narrower, like our size column, for example, because the largest values in those columns were still pretty small. Now, one last thing I'd like to point out before we go. Sometimes you may see a strange-looking value in a spreadsheet cell that looks like a bunch of little pound or number signs. If you see this, it most likely means there is a number or date value in a column that is too narrow to accommodate it. So just for example, let me type a number in cell J1 and then resize column J to be extremely narrow. And there is that string of pound signs I warned you about. But if I autofit the column, now we see the number again. Likewise, if I enter a date in, say, cell K1, like 1/1/2021, and then hit enter, and then again resize the column to be extremely narrow, we see the pound signs reappear. Now it's important to note that in Excel, the visual appearance of data is distinct from the actual values of the data. So even though we see a bunch of pound signs right here, if we select the cell and look up at the formula bar, you'll see that Excel still knows the correct value that's stored there. Resizing our columns and rows is not so much about entering and storing our data accurately as it is about making the data we've entered as human readable as possible. But I can tell you that's just as important, since it's humans who will be interpreting our data and making decisions with it. Now along those lines, up next we're going to look at some techniques that will help us scan and digest the data in large grids more easily. I'll see you then. Okay, welcome back. As we enter more rows and columns of data in our Excel spreadsheets, finding what we're looking for among all these cells can become increasingly difficult. One way we can help ourselves stay oriented as we're exploring our data is to organize our data in a tabular fashion, as we discussed previously, with column headers signifying individual attributes of whatever data it is that we're tracking. Likewise, the values in certain columns can sometimes help orient us as well, functioning effectively as row headers as opposed to column headers. But if we have too many rows or too many columns to view at one time on our screen, and then we scroll down or to the right, we suddenly lose those headers that help give meaning to the data we're looking at. Now, fortunately, Excel gives us a way to maintain visibility into these headers even as we're scrolling through extremely large data sets. This feature is called freezing panes, and it becomes invaluable as our data sets grow larger and larger. Let's take a look at how we can apply freezing panes to help us navigate our Hawaiian shave ice tracker. Now, as we just mentioned, if I scroll down a little through our shave ice data, suddenly our column headers are gone, and it becomes very difficult for me to know what I'm actually looking at when I see a row of values. Unless you're intimately familiar with the data, and maybe even if you are, what was once an intuitive ledger of information has suddenly become a jumble of values whose meaning is not obvious. Without our headers to guide us, we're essentially lost at sea without a compass, and the seas only get rougher and rougher as we have more rows and columns in our data. What we need to do is lock our column headers in place so that even as we scroll down, we can still reference them against the values on our screen. Fortunately, doing this is quite easy. To freeze a row so that everything from that row and above remains fixed in place even as we scroll down the grid, the first step is to select the row below the row or rows that you want to remain locked in place. So if we never want to lose sight of row 1 as we scroll down, we actually want to select row 2. Next, we'll select the View tab on the ribbon, which I actually already have selected here. Remember, navigating the ribbon is largely a matter of commonsensically, if that's a word, thinking about what it is that you're trying to accomplish versus the broad categories represented by the various tabs on the ribbon. And what we're doing pertains to the view that we see when we look at the spreadsheet, so I went to the View tab. So once we're on this tab, if you look in the Window subgroup, you'll see a Freeze Panes button. If you click that, you'll see 3 options, and we'll just choose the first one, Freeze Panes. Now let's see what happens when we scroll down through our spreadsheet. And look at that. No matter how far we scroll down, we can still see our headers, so we no longer need to be confused as to what values in our data actually mean as we're scrolling up and down through the grid. So the most common use of freezing by far is to simply freeze the top row like we did here. But sometimes we may want to lock more than one row in place. All rows above the row you had selected before choosing Freeze Panes will be locked. So if we had selected, say, row 3, then clicked Freeze Panes, both rows 1 and 2 would remain locked as we scroll throughout the spreadsheet. Just to see what this looks like, let's first unfreeze panes by clicking the Freeze Panes button again, and then choosing Unfreeze Panes from the pop-up window. Then, with row 3 selected as we have here, let's go back to the Freeze Panes menu and choose Freeze Panes again. And now if we scroll through our spreadsheet, we see that the top 2 rows are firmly locked in place. Now it's also common, although I would say somewhat less so, to want to freeze columns in place so that we can see the values in them even as we're scrolling across the grid horizontally. Let's say, for example, that we always want to be able to associate the data points in any of our columns with their respective order numbers. So if we always want to be able to see order number, no matter how far we scroll to the right, then we need to freeze the first column where our order number values are stored. This works almost exactly like freezing rows. We first select whatever column is immediately to the right of everything we want to remain locked in place. So if we want column A here to be locked, we will select column B. Then we'll go up to the Freeze Panes button again, where we'll first need to unfreeze panes because we already have our top 2 rows frozen. Now at this point you may be wondering what we can do if we want to freeze both rows and columns. You actually can, but we'll get to that in just a moment. So for now, we'll just choose Freeze Panes. And as we scroll right through our data, we'll see that the order number values in column A remain firmly locked into place. Now we don't have a ton of columns in our data as it currently stands, but you can see how this would become more valuable as we add more and more columns to our data. Now when freezing rows, the most common scenario by far is to simply freeze the top row of the spreadsheet where our column headers typically reside, like we did before. Likewise, the most common scenario when freezing columns is to freeze the first column, just like we did. For this reason, Excel actually gives us convenient shortcuts to do both of these things. So if we unfreeze panes to get rid of the freezing operation we just performed on column A, we can then go back to the Freeze Panes menu without worrying about what cell or row or column we've selected and simply choose Freeze Top Row. And then if we try to scroll down through our data, we see that the top row is frozen just like we were able to do previously. Likewise, we can freeze the first column in 2 clicks by simply clicking the Freeze Panes button again and then choosing Freeze First Column. And as you can see, our first column is now frozen, just like we accomplished with a few more steps a moment ago. So now, back to that whole issue of being able to freeze columns and rows simultaneously. Thus far, we've only been able to freeze our column headers in row 1 in place, or our first row of values in column A in place, but not both at the same time. Doesn't it make sense that we might possibly want to keep track of both as we're navigating our data? Indeed it does, and fortunately it's very simple to do. The only difference is, instead of selecting an entire row or an entire column before hitting the Freeze Panes button, we instead select a single cell. How it works is, all the rows above the cell and all the columns to the left of the cell will remain locked in place as we scroll across the grid. So if, for example, we want row 1 and column A to remain frozen, we would first select cell B2, since the row immediately above it is row 1 and the column immediately to its left is column A. So if we select cell B2 and then first unfreeze panes to undo the freezing operation we did a moment ago, and then choose Freeze Panes, you'll see that both column A is fixed in place and row 1. Both remain fixed and visible no matter how far down or across you scroll on the grid. And again, you could freeze as many rows and columns as you like by simply moving the cell you select before freezing panes, down or to the right. So if I unfreeze panes again, and then select cell C4 and freeze panes once more, now you'll see that the top 3 rows are frozen and the 2 leftmost columns are frozen. All right, at this point we can proclaim ourselves masters of the Excel grid. We know how to enter and manipulate data in it, create, delete, move, and resize its rows and columns, and navigate its vast ocean of cells like a seasoned explorer. But thus far, we've limited ourselves to a single grid, when in reality, Excel actually lets us create as many of these as we want in a single file. We'll begin exploring this new world of multiple grids in the next video. I'll see you then. Hey, welcome back. In this one, we're going to extend our journey through Excel from the exploration of a single grid to creating and working with multiple grids in the same Excel file. Before we look at some examples, however, it's important to understand just a bit of terminology. Now, I know this is the point where most people will be tempted to stop the video and run the other way. Please don't. This terminology will make some distinctions about the environment we're working in more clear. So the grid, as I have been calling it, that we've been working in thus far, is part of what's called a worksheet. A worksheet is a single grid in an Excel file, but we can actually create more of these. As many as we want to, in fact, only limited by our computer's memory and its ability to store whatever data we're entering into Excel. A worksheet is part of a workbook, which is a distinct Excel file that we can create, open, and close. Now, if you look at the name of our example file here at the top of our screen, that is the name of the workbook, not the worksheet. When you hear the word spreadsheet, this is essentially synonymous with a workbook. Now, you can find the name of the worksheet down here near the bottom left. It's named, blandly enough, Sheet 1. This is the default name that Excel gives the one tab that is open by default in an Excel workbook. Now, as long as we only have one worksheet in our workbook, the distinction between worksheet and workbook is trivial. But many, if not most, workbooks have more than one worksheet. To see what this looks like, let's go ahead and click the plus sign to the right of the name of our Sheet 1 tab. And you'll see that we now have a brand new grid, which has been named Sheet 2. And it's a brand new slate that we could use for an entirely different purpose than Sheet 1. And we can keep going in this fashion as long as we want. You can create as many tabs as you need to organize the data and functionality of your spreadsheet in a way that makes sense for your purpose. Now, with that said, while there are no hard and fast rules for how to divide your data between worksheets or even Excel files, my rule of thumb is that an overall Excel file or workbook, our shave ice file we have open here, for example, should generally pertain to one thing or purpose. In our case, that thing is tracking information pertaining to our Hawaiian shave ice truck. But since things in the real world can get pretty complicated, it often helps to break them down into manageable pieces when trying to track, describe, or model them. So if the point of our spreadsheet is to track and manipulate data pertaining to our shave ice truck, we could have multiple worksheets within the workbook that support this overall purpose in different ways. For example, while we have one tab here that tracks customer purchases, the tab we've been doing our work in, we could have another tab that tracks our product inventory. Things like how much ice do we have, how much do we have of each flavor of syrup, etc. And then perhaps we could create even another tab to track purchases we make from vendors, and so on and so forth. So let's say we want to start by creating a product inventory tab. We already have a second blank tab that we just created here, which we could use as a great starting point, but both of our tabs are named so generically, it's not going to be obvious which one we need to click to view or enter what data. So what we need to do is rename the tabs, which, as it turns out, is easy enough. To rename a tab, you can either right-click it and choose Rename, or you can simply double-click the tab name. Then type in the new name and hit Enter. So I'll just type Product Inventory and hit Enter. And again, to be clear on terminology and these distinctions, the tab is simply the button that you click to navigate to a worksheet. So if I click this tab called Sheet 1, that takes me back to the Sheet 1 worksheet. Likewise, if I click the Product Inventory tab, that takes me back to the newly created Product Inventory worksheet. And while we're busy doing this renaming, we can go ahead and rename our first worksheet Sales Tracker. Next, we can create a Vendor Purchases tab, which we could use to keep track of the money that we spend to keep our little business afloat. Now, depending on where we want this tab to be located relative to the other two, we need to strategically select one of our two tabs before clicking this plus sign. The new tab will be inserted immediately to the right of whatever tab I currently have selected. So if I want our new tab to be inserted after our first tab, but before our second, I would need to select the first tab and then hit the plus sign. Now, if on the other hand, I had had the second tab selected, our new tab would now be in the third position. So now let's give our new tab a name, and we'll call it Vendor Purchases. So far, so good. But now let's say I've changed my mind, and I want to move this tab into the third position. This is actually pretty straightforward. Just right-click the tab, choose Move or Copy, and then select from the list of worksheets presented in this pop-up menu whichever one we want this worksheet to be repositioned before, that is to say, to the left of. Or if, and as in our case, we simply want to move the sheet into the last position, we can choose Move to End, and then click OK. And now our Vendor Purchases tab is slotted in right where we want it. Now, one way to get a head start on the layout and structure of a new tab is to duplicate an existing tab with a similar structure to what you need. Let's say, for example, that we bought an additional shave ice truck that we're letting someone else operate, and we want to track the sales for that one independently. This seems like a good use case for a new tab, but since we're tracking similar data, we're probably going to use the same, or at least similar, structure as our existing Sales Tracker tab. This is where duplication can come in really handy. So to do this, right-click our Sales Tracker tab, and then again choose Move or Copy. As before, when we moved our Vendor Purchases tab, the dialog box that appears asks us which sheet we want to move our duplicated sheet before. And in this case, we would want our new sheet to be directly after Sales Tracker, which means it would be before the Product Inventory tab. However, if you also check the Create a Copy checkbox, instead of the current sheet being moved into that position, a copy of the sheet will be placed in that position, while the current sheet will remain in its original location. So now if we click OK, a new sheet appears with an auto-generated name based on the name of the sheet we copied, which incidentally is pretty close to what we would want to name it. So I'll just go ahead and tweak this and call it just Sales Tracker 2 with no parentheses needed. And there we have it. As you see, we have all of our column headers, all of our structure preserved from the Sales Tracker tab, and all we would need to do to repurpose this is just delete the data below the column headers, and otherwise we've got pretty much everything we need to start tracking sales from our new shave ice truck. Now, before we move on, we should consider what to do if we've created a tab that we later realize we don't need. Maybe we've decided that instead of tracking our sales from our second shave ice truck on a new tab, it would be simpler to just add a new column to our first tab that will track which shave ice truck a given sale occurred at. So in this case, we could delete our second Sales Tracker tab, the one that we just created. Now, doing this is extremely simple. You just right-click the tab and choose Delete. But there is an important thing to consider before you hit the proverbial big red button. You know how we've been using Control-Z, that is to say undo, to quickly unwind changes to our workbooks? Well, there are certain changes that Excel can't undo, no matter how hard you hit Control-Z. And deleting sheets is one of them. So if we go ahead and delete our sheet here, and you see here that Excel gives us an extra little warning asking us if we're really sure that we want to delete this sheet, which might indicate to you that it's a bigger deal than some changes you could make, and we'll go ahead and click delete. But if we hit Control-Z, nothing happens. Excel is unable to recapture the sheet we deleted. So the lesson is, Don't delete a sheet unless you really mean it. All right, now we have made clear, at least I hope, the distinction between worksheets and workbooks, and introduced some tactics for working with multiple worksheets. Now, armed with that knowledge, we're ready to tackle one of the most powerful ways to search and edit data, both within individual worksheets and across multiple ones, that Excel has to offer. That's find and replace, and we'll learn all about it in the next video. I'll see you then. Welcome back. We had barely just learned some techniques for navigating the Excel grid efficiently when we discovered that a single spreadsheet can actually contain many different grids. The Excel universe, it seems, just keeps getting bigger and bigger. And this can make it darn inconvenient when you want to search for things in a spreadsheet. It's one thing when we have a few rows of data on a single sheet, but when one sheet has hundreds or thousands of rows of data, and then we have multiple sheets in our workbook, something as simple as finding every cell where we entered the word blueberry can become extremely difficult. Fortunately, Excel once again comes to our rescue, in this case with a powerful feature called Find and Replace. Find and Replace, as the name implies, really encompasses two pieces of functionality: finding data in our spreadsheet and then potentially replacing it with something else. We'll start by finding values within our spreadsheet and worry about replacing a bit later. So let's say that we want to find all entries for snow cream in our spreadsheet. Obviously, individually inspecting each cell in our sales tracker would be prohibitively time-consuming, not to mention mind-numbingly boring, so we'll let Excel do the heavy lifting for us. To start, use the keyboard shortcut Ctrl+F to bring up the Find and Replace dialog box. Then, type the phrase we're searching for, snow cream, in the Find What text box. Finally, simply click the Find Next button, and Excel will automatically select the next cell that contains the value snow cream. And then if we keep clicking Next, Excel will keep navigating to subsequent snow cream values until we finally run out of values to search for. Note that Excel searches from left to right and top to bottom, relative to whatever cell you had selected when you hit Ctrl+F. So if I close out of the Find Replace dialog box, and then select a cell in a row below, or a column to the right, of a cell with the value snow cream, let's say cell I5 here, and then we do another search for snow cream, you'll see that Excel ignores the snow cream value in cell H5 and moves on to the next one, again relative to the cell we had selected. Now this doesn't mean Excel won't ultimately find the value in cell H5. Eventually, after it has navigated through the rest of our sheet, it would come back around to the very top of the worksheet and scan all the cells above and to the left of where we began the search. So this ability to find values in the vastness of the Excel grid is obviously very convenient. But when we have many instances of the same value, as we do here, navigating through them one at a time can be a bit of a chore. Fortunately, Excel gives us the option to find all, as opposed to simply finding the next value in the spreadsheet. So with our Find dialog box still open, if we click the Find All button, Excel now displays a list of all of the instances of the phrase we were searching for, along with their respective addresses within the worksheet. So now we can simply scroll through these matches and see exactly where the values are located on our worksheet. For quickly getting an idea of how many instances of a value are in your spreadsheet and where they're located, this is a super powerful tool. Looking at this list of matches, you might have noticed that Excel tells us which sheet each match is located on. This is because Excel optionally allows us to search for matches across all the worksheets in our workbook, in which case we need to know not just the cell address of the match, but also the worksheet the match was located on. To demonstrate this, let me quickly duplicate our first tab so that we now have snow cream values located in 2 sheets of our workbook. So we'll just go ahead and move or copy, create a copy, and move to end, just like we saw in the last video. Then we can once again hit Control F to display the Find and Replace dialog box. And since Excel is smart enough to remember the last thing I had searched for, I'll go ahead and hit this Options button here to see what we can do about searching across all worksheets instead of just the one we have selected. And they certainly weren't kidding around about the options part. We are presented with all sorts of ways to customize our searches. For now, let's focus on the Within Sheet option. So if we click this drop-down box that says Sheet, we see that we have the option of searching within the current sheet or the entire workbook, which is another way of saying all the worksheets within the workbook. Let's go with that option and then choose Find All. And now if we scroll down through our list of matches, you'll see that some come from our Sales Tracker worksheet and some come from our copy of our Sales Tracker worksheet. And now to reset our options back to their defaults, I'll go ahead and change Within back to Sheet, and then I'll click the Options button to hide this Options section of the dialog box. Then we can go ahead and close out of the dialog box. Now we can also reduce the scope of our searches from a single worksheet to a range within a worksheet. If we only have a single cell selected when we execute our search, by default, Excel will search all the cells in that particular worksheet. However, if we select more than one cell, that is to say a range, Excel will only search within that range of selected cells. So if I, for example, select the range E2 through I11, which contains a few instances of the phrase snow cream, and then we execute another find using Control F, and then we choose Find All. Now as we scroll through the results here, you'll see that they're all cells within that range. It's not picking up any matches outside the range that we selected. Now there are just a couple more options on the options screen that I would like to explore. So let's click the Options button again. Now one of these options is to match case, which you can see is unchecked by default. Matching case essentially means that a value in our spreadsheet is only considered a match against our search term if the capitalization is identical to what we typed in. With match case unchecked, capitalization is not considered when evaluating values in our spreadsheet for a potential match. So let's say I do a search for snow cream, but type snow cream in all caps. If I click Find All, I have all the same matches that I had before. But if I check the Match Case checkbox and do another Find All, now we get no results. Excel says we couldn't find what you were looking for. And it even helpfully suggests that we could click Options for more ways to search. Now another option you can employ if you want to be more precise and surgical with your searches is to match entire cell contents, which you can see is right below our Match Case checkbox, which I'll go ahead and uncheck for now. So wait, Excel hasn't been matching our search term against the entire cell contents already? It actually hasn't. In fact, if we simply search for the word snow instead of the phrase snow cream, you'll see that we get the exact same list of matches as before. Now, sometimes this behavior is really handy, and sometimes it's not. Especially when we are replacing the matches we find with some other text, returning partial matches like this can be kind of dangerous. And even when simply finding values like we're doing here, you may or may not be interested in a match if your search term is only contained within a larger piece of text in a spreadsheet cell. It really all depends on what you're trying to accomplish. Now, speaking of replacing values, all the things we've learned about finding are 100% applicable to finding and replacing. In fact, the replace functionality is built into the Find dialog box. So let's first click the Options button again to hide the Options section of the dialog box. We can then click the Replace tab on the Find and Replace dialog box, and we'll see that the options are pretty much identical to before, except that we're now asked to provide text that we want to replace our matches with. Now note that you can also navigate directly to this tab with the Control+H shortcut. So if we close out of the Find and Replace dialog box and then hit Control+H, we're taken directly to Find and Replace. Now let's say, for example, that we want to rename our snow cream flavor to Avalanche. So all we need to do is make sure we have snow cream typed in the Find What text box, and then Avalanche typed in the Replace With text box. Then we'll just hit the Replace button, and you'll see that in cell H5, Snow Cream has been replaced by Avalanche. And then if we keep clicking, we'll see that each subsequent instance of Snow Cream is replaced by the word Avalanche. Now for small find and replace operations, this one-at-a-time approach is perfectly fine. However, this wouldn't work very well over a large data set. As an alternative, we can use the Replace All command, which will replace all matches with our new value in one fell swoop. So if I click that, all instances of Snow Cream in our worksheet have now been replaced with Avalanche. So you can see how this technique could allow us to make wide-scale changes to our data with a bare minimum of typing. But this kind of power comes with its pitfalls, especially if we keep the default setting of returning and thus replacing partial matches. Let's say, for example, that we want to change the name of our apple flavor to apple pie. Now, the sharp-eyed student may note at this point that we did not have an apple flavor prior to this video, and may conclude that said flavor was contrived for the purposes of this example. Such a sharp-eyed student would not be incorrect. But I digress. So first we can dismiss the pop-up that lets us know that Excel successfully replaced 33 instances of Snow Cream with Avalanche. And then in the Find and Replace dialog box, we'll search for apple and then replace it with apple pie. And finally, click Replace All. So Excel tells us that it's all done and 88 instances were replaced. But after we click OK, we see something pretty odd. All of our pineapple entries have now changed into something called pineapple pie, which, while it actually sounds kind of tasty, is probably not a real shave ice flavor or even a real thing for that matter. Because we were searching for, and subsequently replacing, any instance of the word apple, we ended up replacing the text apple even when it was part of another word, such as pineapple. Sometimes this behavior may be what you want, but if it's not, you can obviously do a lot of damage on a pretty broad scale using Find and Replace. The way around unforeseen consequences like this is to be more surgical with your Find and Replace operation by choosing Match Entire Cell Contents in the Options section of the Find and Replace dialog box. So if we close out of our Find and Replace dialog box and then hit Control-Z to undo our last Find and Replace operation, and then do another similar Find and Replace, but this time we choose Match Entire Cell Contents, and finally click Replace All, you'll see far fewer replacements were made, and our pineapple entries have not been replaced by pineapple pie. Alright, so with Find and Replace under our belts, we now have every technique we need to enter, navigate, and edit the data in our Excel workbooks. The logical next step then is to learn about working with multiple workbooks, completely different Excel files with their own little universes of worksheets. That's up next. I'll see you then. Welcome back. We've now seen that an Excel workbook can be composed of many worksheets. So in the hierarchy of Excel, so to speak, is there anything higher than workbook? Actually, yes. It's the Excel application itself, which can, in turn, contain multiple workbooks simultaneously. Let's take a look at an example to make this distinction clearer. Now here we again have our shave ice truck tracker. If I were to click the X button at the top right corner of the screen, we would close out of Excel completely. So how again is a workbook different than the Excel application itself? But there's actually another way to close out of a workbook. If I go to the File menu on the ribbon, which tends to contain commands that pertain to entire workbooks, like opening, closing, and saving, and then choose Close, we'll see that the workbook disappears, but we still have an application window for Excel open. So in short, Excel is the application that hosts our workbooks. It is totally possible to have Excel open without having any workbooks open, although there's really not much point to this. So to that point, let's go ahead and reopen the file we just closed by going to File and then Open. And then we'll simply browse to where we have the file saved, select it, and click Open. Now that we have our original workbook back open, let's go ahead and create a new one so we can explore how to work with multiple workbooks. Now one way to do this would be to go back to the File menu and then choose New. But creating a new workbook is such a common task that this is another one of those cases where it's best to learn the keyboard shortcut. In this case, that's Control-N. So to get out of the File menu, I'll just click this arrow pointing to the left here. And then to create that new workbook, I'll just hit Control-N. And suddenly a new blank workbook appears. But how do we navigate now back to our original workbook? Well, since this problem pertains to our view of Excel, quite literally what we're seeing, we'll check under the View tab on the ribbon. And there we'll find a command called Switch Windows. If we click that, we'll actually see a list of all the open workbooks in the Excel application. And Excel lets us know which one we're currently looking at. This is called the active workbook because there's a check mark next to it. So if we want to navigate to the other workbook, we simply select that one in the pop-up menu, and now we're right back where we started. So now let's say we want to go ahead and close that new blank workbook we created. First, we can navigate back by going to View, Switch Windows, and then selecting that workbook. Then, instead of resorting to File Close, we can simply click this X at the top right corner of the window. But wait, isn't this going to close us out of Excel altogether, and then close our shave ice truck spreadsheet in the process? Actually not. If there are multiple workbooks open, clicking the X simply closes the active workbook, the one you're currently looking at, leaving any other workbooks open. Now sometimes, when creating a new workbook, we may not want to start from a blank slate. Much like when we duplicated a worksheet earlier, it can also be useful to duplicate a workbook. There are a couple of ways to do this. One is to save the current workbook as another name. This will make a copy of the current workbook with a new name that you specify. Then you can branch off in your new workbook with whatever changes you want without affecting the original. So if, for example, I'm starting a new food truck and want to use my shave ice spreadsheet as a starting point to track information about my new venture, I can simply click File, Save As, and then I'll be prompted to enter a new name for the file. I'll go with Food Truck Tracker, and then I'll browse to a location, and I'll just drop it into the same folder as my other example file, and then we'll hit Save. And we're good to go. Now we can go to File, Open, browse to our folder, select our original workbook, and open that. So now if we go to our View tab and go to Switch Windows, you'll see we have both of these spreadsheets open, and they have different file names and are completely different files. At this point, we could make whatever modifications we want to one file without affecting the other. So for now, I'll just select our new copy and close out of that so we're left with our original file. Now, sometimes you may not want to copy the entire structure of a workbook, but instead just a single tab. To do this, we can simply right-click whatever tab we want to make a copy of, choose Move or Copy, and then check the box that says Create a Copy. Then, before clicking OK, choose New Book in the To Book drop-down list. Then, after clicking OK, we now have a brand new workbook with a single tab that is identical to the second tab of our original spreadsheet. Now sometimes, instead of simply switching back and forth between our workbooks, it can be useful to view them side by side, especially in cases where similar information is being tracked in multiple workbooks and we want to reconcile them against each other. In the real world, this is a fairly common scenario. Fortunately, Excel has an extremely convenient way to do this built in. All we have to do is, again under the View tab, choose Arrange All. The pop-up menu that appears gives us several options for how to arrange the Excel workbooks on our screen, but the one I find most useful by far is the vertical orientation. If we choose that, now our two workbooks appear on our screen side by side. The content of the workbooks remains unchanged. Excel just reduces their width so they can both fit in our screen simultaneously. You can just pretend they went on a diet. We can scroll through, select different tabs of, and otherwise manipulate each workbook independently, just like we were viewing the workbook on the entire screen. And if at any point we no longer need this view, we can simply go to the little square icon at the top right corner of whichever one of the windows we want to maximize, and click that. And now it fills up our screen once more. The other workbook is still open too, and we can always switch back to it using Switch Windows. For now, I'll navigate back to our duplicated workbook and close out of it without saving, so that we're left with our original. Now similarly, you can also view two sections of the same workbook simultaneously, just like we just viewed two separate workbooks side by side. To do that, again under the View tab, choose New Window. This creates a kind of shadow workbook that mirrors our current workbook in every way, the benefit of which is allowing us to see different parts of our current workbook side by side. So if I go to View and Switch Windows, you'll see that we now have versions 1 and 2 of our example file. Now I can't overemphasize that these files are identical. So if I make a change on one, let's say I just delete the value in cell A1, order number, and then if I were to go to the version 1 of our example file, you'll see that that value has been deleted there as well. Instead of thinking of these as separate files per se, think of them as simply mirror images of each other. Now, one example of where this can come in handy is if you wanted to compare values between different tabs in the same workbook. So if I first select View and then Arrange All, just like we did before, and then make sure Vertical is selected, we can see our workbook views side by side. So let's click OK. And now I can navigate to different portions of our same workbook to view them side by side. In the view on the left side of our screen, I can choose the first sales tracker sheet, and then on the right side, I can have the second duplicated sales tracker worksheet selected. As you can imagine, this sort of thing comes in very handy for reconciling similar data sets against each other that just happen to live in the same workbook. Alright, at this point we've pretty much taken the grand tour of the massive application that is Excel. We have a lot more to learn about its functionality and how to apply it, but at this point you should have a solid grounding in Excel's fundamentals and the building blocks that make up the application. Take a breath and pat yourself on the back for learning so much already. I'll see you in the next video. Welcome back. Up to this point, we've mostly been concerned with the speed and efficiency with which we enter data into our spreadsheets. We haven't given much attention, however, to the visual appearance of that data and how to modify that appearance. Now, Excel is very useful as a data storage mechanism, but it's used just as often as a vehicle to present attractively formatted data and visualizations to audiences of all kinds. Therefore, it's crucial to learn the most important options Excel gives us for modifying the appearance of the data in our cells. A crucial concept to understand before diving into formatting is something we touched on earlier: the concept of data types, broad categories of data that Excel recognizes as distinct and which provide us distinct sets of options for both calculations and visual formatting. These three data types are text, numbers, and dates. Depending on what sort of data Excel thinks you've entered into a cell, you will have different options available to you, not only in terms of the calculations you can perform on the data, which we'll get into very soon, but also how you can change the visual appearance of that data. To get a feel for how all this works, let's start playing around with entering different values into a spreadsheet. First, I'll type a text string, the word Excel, just as an example, into cell A1 here, and then hit enter. Now if we navigate back up to that cell, and then look at the number section on our home tab of the ribbon here, you'll see that the cell is formatted as general, whatever that means. Next, let's type a number into another cell. I'll try the number 42 in cell B1. And now if I navigate back to that cell, we can see that it also is still formatted as general. But wait, 42 is a number. So why isn't Excel acknowledging that this is a different type of data than the text string we entered? Well, this is where it's important to understand the distinction between data values and data formats. Formatting pertains to the visual appearance of the data, but doesn't actually change the underlying values that we entered into the cell. So a number and a text string both being formatted as general does not mean that Excel doesn't recognize that one is a number and one is text. In fact, it does. And you can actually see this by looking at the alignment of the values in the two cells. By default, Excel aligns numbers to the right and text to the left, which is exactly what we see here. But what the heck does the general format actually mean? General is basically Excel's default format. If we navigate to other empty cells around the grid, you'll see they're all formatted as general. And it essentially represents Excel's best effort to format the data that we enter in a reasonable way. If you don't have a strong opinion about what your data should look like, sticking with the general format is usually fine. There are some values, however, that will be assigned a different, non-general format when we enter them into the cell. For example, if I type a properly formatted date into cell C1 here and hit enter, so I'll just try 1/1/2021, and then navigate back to the cell, you'll see that Excel is smart enough to recognize what we typed into the cell as a date, and it assigns an appropriate format accordingly. Now for each one of these broad data types, text, numbers, and dates, we will have a broad variety of formatting options to choose from, specific to that type of data. What we've seen here thus far, a general format for text and numbers with different alignments to indicate that they're recognized as different types of data, and a separate, distinct format for dates, simply represents Excel's defaults and barely scratches the surface of all the formatting options available to us. Up next, we'll kick off our deep dive into formatting data by exploring some of the options we have for formatting numbers in Excel. I'll see you then. Hey, welcome back. Now that we have the general idea of how formatting in Excel works, let's dive into some of the most common and useful formatting techniques for numerical data. We'll start in a blank spreadsheet just to get some of the basics down, and then we'll apply some of those techniques to our Resizing tracker to see how they work in real-world scenarios. So, for numbers and decimals, for which you don't need any visual flair beyond strictly the number itself, additional formatting beyond what the general format offers is often not needed. I can enter the number 1111 in cell A1, and then the decimal 1111.766 in cell B1, and Excel is able to display both numbers just fine, as long as we just care about displaying the number, nothing more, nothing less. It's often the case, however, that decimals in our spreadsheets are the result of calculations, which can end up producing messy strings of numbers after the decimal place. In these cases, while we don't want to lose insight into the exact value stored in the cell, we often want to format the number such that only a certain number of decimal places are displayed. Most commonly 2, but sometimes less or more. In our case, let's try formatting cell B1 such that only 2 numbers are displayed after the decimal. The easiest way to do this, after selecting the cell, is to click the right pointing arrow on the number section of the Home tab. This arrow reduces the number of digits after the decimal place of a number, but strictly in the sense of formatting, not in terms of the actual value stored in the cell. Each time we click this button, the number of digits that appear after the decimal place will reduce by 1. In this case, we just need to click it once to get down to 2 digits after the decimal. Note that by default, Excel rounded the last digit we're displaying based on the digit after that. Since the third digit was a 6, the true value was closer to 1111.77. Excel chooses to display that instead of 1111.76. But if we look in the formula bar, after selecting the cell, we see that our original value is what is actually stored, with all of the precision retained. Now, as you might have guessed, if we click the arrow pointing left, now we'll see more of our decimal places. And we can actually keep going past the number of digits in the original number. Excel will just keep tacking on zeros if we run out of digits to work with. Now, if we have a very specific number of digits we want to display after the decimal, and we don't want to click the arrow that many times, we can alternatively right-click the cell, choose Format Cells, which is selected by default. Here we're presented with a dialog box that gives us the option to enter whatever number of decimal places we like. So if I wanted to reduce the number of decimals we're showing down to 2, I could do that right here. The Format Cells dialog box gives us more options and greater precision than the shortcuts we see on the ribbon. Now, another useful function of this dialog box is the Use Thousands Separator checkbox. By checking this, numbers 1,000 or larger will be formatted with commas, which can make such large numbers significantly more human readable. So if I check that and click OK, you can see that our number now has a comma after the first digit. The larger numbers like this get, the more essential these comma separators become for the purpose of readability. This is an option you're probably going to end up using pretty often. So now that we've formatted a couple of numbers, let's head over to our Resizing tracker and see how formatting some of the data in it might make it more readable and useful. Now right away, you may notice that I've added a sale amount column to our tracker, which has the total dollar amount of each transaction we've recorded in our ledger. Right now, the amounts are formatted with 2 digits after the decimal place, which is fine. However, it would be nice if we could format these numbers in a way that distinguished them from ordinary decimals, by making it clear that they denote amounts of money. Excel actually has a built-in format for this specific case. As you might imagine, entering dollar amounts in spreadsheets is pretty darn common. So with cell J2 selected, if we just right-click, again choose Format Cells, and then select the currency category, Excel actually shows us a preview of what the number will look like with this format applied. Basically just like it did before, but with a dollar sign in front of it. So if we click OK, now we're making it clear to anyone looking at our spreadsheet that this 19.95 value represents a dollar figure. Now this is obviously a big improvement over what we had before, but now we need to carry this formatting down to the entire column of sales amounts. Now we could simply select only the cells that we've entered data into by using the Control-Shift-Down arrow keyboard shortcut, and then format only that range of cells. But I personally prefer to select the entire column before applying the format. This leaves room for future growth in that column, as we add more and more entries to our ledger. And in general, as we mentioned previously when talking about tabular data, it's a best practice to only enter one type of data per column. So if we have currency values in column J, we should probably only be entering currency values in column J, except obviously for our column header. So let's click the letter J to select column J, and then right-click, choose Format Cells again, then Currency. But before we click OK, note that the drop-down list next to Symbol says None. But what we want is a dollar sign. So we'll want to click this drop-down and choose the dollar sign, which is essentially the symbol of our currency of choice. Obviously, there are lots and lots and lots more varieties of dollar signs that Excel has built into the application, but for our purposes, we're going to go with the good old-fashioned dollar sign. We can also customize the number of decimal places displayed, so if we only wanted to show one digit after the decimal, we could change that here by simply clicking the up or down arrows or typing in a different number. But we'll leave it at 2 for now, and then click OK. And now our entire column is formatted as currency, so it's clear to anyone looking at this data that these numbers pertain to dollar amounts. So the third common number format is percentages. Now mathematically speaking, a percentage is really just a specially formatted decimal. The decimal number 0.25 and the percentage 25% are, in strictly mathematical terms, identical. Fortunately, Excel recognizes this. For an example, let's move over to the Flavor Performance tab, which is new to our tracker. And you'll see here that we have, for each of our shave ice flavors, the proportion of all sales generated by that flavor. Now, unfortunately, these proportions are represented by long decimal numbers, which, while accurate, are not especially pretty to look at, nor easy to read or reason about. So to quickly change that, we can simply select the entire column containing the decimals, and then hit the percentage button on the number section of the Home tab. Sweet! Now all those ugly decimals have been transformed into easily human-readable percentages. And if we want to see a little more precision with our percentages, say 2 digits after the decimal place, we can just use our left arrow button on the number section of the Home tab to add them. Regardless of our formatting choices, however, if you look in the formula bar after selecting one of the values, you can see that the precision of the original numbers has still been preserved. Again, formatting will not impact the accuracy of any calculations done on the values we're formatting. It simply changes what is displayed, not what is stored. Now it's worth noting that as far as Excel is concerned, these percentages are exactly equal to the values we entered into the cell in strictly mathematical terms. And we can use these percentages in calculations the exact same way that we might have used our decimal numbers previously. Now also, if you don't want to take the additional steps of having to reformat your numbers as percentages after you've entered them, you can actually enter them as percentages directly into the cell. So if I wanted to enter the value 50% in a cell, instead of needing to type 0.5 and then format that as a percent, instead of doing that, I can actually just type 50% directly in the cell. And if I navigate back to the cell, you'll see it's formatted as a percentage, just like in cell E1. Under the hood, so to speak, Excel understands that this value is not 50, but rather technically 0.5, which in mathematical terms is what 50% really is. Just know that when entering percentages this way, do not enter the decimal that the percentage is equivalent to. This throws some people off, including yours truly at first. So if you were to type 0.5% into a cell and hit enter, the value that is actually stored is 0.005, which in mathematical terms is a half of 1%. So the bottom line is, when entering percentages directly into a cell, type them as you would say them. Basically, don't overthink it. All right, up next we're going to explore the wide world of formatting dates and times, a rabbit hole that goes even deeper than formatting numbers. I'll see you then. Welcome back. In this one, we're going to learn all about formatting dates and times in Excel. But before we can run, we have to learn to walk. And that means learning how to enter dates into Excel so that Excel recognizes them as dates in the first place. It turns out that dates are a special data type in Excel, which enable us to do all sorts of nifty date-specific calculations, as we'll see in future sections. But if we don't enter dates into our spreadsheet cells in certain specific ways, Excel will interpret what we mean to be a date as a plain old piece of text, no different than a bunch of letters. The safest way to get Excel to recognize our dates as dates is the method we've already used. The month, followed by a /, then the day, another /, and the year. Fortunately, Excel is smart and flexible enough, however, to allow us some measure of flexibility within this pattern. So if I enter 3/3/2021, Excel recognizes that as a date. If I enter 03/03/2021, Excel also recognizes that as a date. And if I even enter 3/3/21, Excel again is smart enough to recognize that as a date. But now if I enter something like, say, March 3/21, Excel doesn't seem to know what to do with that. So there is a limit to its ability to read our minds when it comes to entering dates. Now, even with all of this flexibility in terms of how we can get away with entering dates with different patterns, I recommend keeping it simple and remembering just one way to enter dates to keep things less confusing. But we're here to go beyond Excel's default formatting, so let's explore some of the formatting options we have for dates. So if we right-click one of our cells that has a date, and then choose Format Cells, we'll see that the Date section of the Format Cells dialog box is already selected. And here we have a variety of different date formats to choose from. One popular alternative involves the day and month actually being spelled out, so if we choose that, we'll see we get this kind of nice, very human-readable date format that is also a bit wordy. This may be something that works for you in certain circumstances, when readability is at a premium versus brevity. Then we can look at another formatting option for our next date, and we'll see below the one that spells out the day of the week and the month is this other format that puts the year first, then the month, then the day, separated by hyphens instead of by slashes. So if we click OK here, you'll see it's just kind of another spin on how to format a date. So whichever one of these you choose, just remember that the format does not change the underlying date value. And because of this, while you're free to format your date with all of these patterns and more, I again recommend entering your dates only one way, since you can always reformat them to your liking later. So now that we've got dates covered, what about times? Let's say that I want to enter the time 4 p.m. into a cell. I'll just go ahead and create a new worksheet here, so we're starting with a clean slate. So if I just type 4 p.m. into a cell, hit enter, and then reselect, Excel still has our cell formatted as general, so it doesn't look like it's recognizing what we entered as a time. So now in the next cell over, let's try entering 4 p.m. again, but I'll put a space in between 4 and p.m. Wow, so two things happen here. One, Excel clearly understands that I'm trying to enter a time, since it took the liberty of adding the minutes portion of the time value that I didn't even type out. And second, we see that the cell is now formatted as something called custom. So what the heck does that mean? Custom formats are a series of specialized formatting patterns that Excel has up its sleeve to format various types of data. Excel includes several of these out of the box, so to speak, but also gives us the ability to create our own custom formats, as we'll see in a later video. But in this case, the custom format is effectively identical to a format that we can find under the time category. So if we right-click and go to Format Cells, we'll see that the custom category is selected by default, but if we go to the time category, we'll see that one of the formatting patterns here appears to be the same as what we entered: the hour, the minute, and then PM or AM. So if we click OK, we'll see that our format is unchanged. Now if we go back to that Format Cells dialog box to explore some of the other time formats available, you can see that another option is what's commonly referred to as military time, which does away with the concept of AM and PM and instead simply counts hours up from 0 to 23. Now if I reformat our 4 p.m. value in this fashion, you'll see that it changes to 1600, since 4 p.m. is technically the 16th hour of the day. Then going back to our Format Cells menu, we also see that several of the pre-built formats allow us to include seconds in our time value formats, just by adding another colon after the minutes value. Now just as with dates, formatting the value that we entered in any of these ways will not change the underlying value, but simply how it's displayed in the cell. With that said, these formats do offer useful hints as to different ways we might enter times into Excel, so that Excel will recognize them as such. For example, if we wanted to enter 11:11 p.m. and 11 seconds, I could either use the AM/PM format, in which case I would type 11:11:11, and then a space, and then PM, or I could type 23:11:11 to give us the exact same value in military time. The choice is yours, but as with dates, I would recommend that you decide on a single method of entering times that you can remember the best, and stick with that, knowing that you can always reformat the value as you want to later. Now, dates and times are all very well and good, but it's very often the case that we need to combine them into a single value. A time without an associated date is not often of much use, and a simple date value sometimes lacks the precision we need from our data, since it doesn't distinguish between times of day. Let's go back to our Shave Ice tracker for an example of how combining date and time values into a single value can be useful. So I'll just switch windows over to that workbook. And you can see in our ledger here that I've created a new column to capture the date and time of each sale. Now I haven't entered any values into it yet, since we weren't tracking this when all of our past sales were made, but let's say hypothetically that I do know exactly when our last two sales were made, both the day and the time. If we want to capture both in a single value, we'll have to do something slightly different than we have thus far. But not too different, fortunately. In fact, all we need to do is enter the date, as we've already learned to do, followed by a space, followed by the time in whichever format you prefer, AM/PM or military. So assuming our order number 99 here was placed on March 5th, 2021 at 11:11 a.m., we can just type in the two components as we've already learned. So over here in cell K100, I'll type 3/5/2021 and then a space, and then 11:11, and then a space, and then AM. And then if I hit enter, so far so good. And then if I reselect the cell, we see that Excel recognizes this as a custom format. So if I right-click the cell and go to Format Cells to bring up the Format Cells dialog box, we see that Excel recognizes what we entered as fitting one of its custom formatting patterns. This one here highlighted that has month, day, year, hour, and minute. But scrolling through these other custom formatting patterns, it doesn't look like any others have all of those components, the day and the time. So does that mean we're stuck with this exact format? Well, let's try entering another date/time in the record for order 100, but with a time that will be handled differently between military time and AM/PM. So I'll cancel out of this dialog box, and then down in cell K101, I'll type in 3/5/2021, and then 2/22 space PM. And what we see is that despite the fact that I entered the time value as an AM/PM format, Excel insists on formatting it in military style anyway. So what do we do if we're not satisfied with the way our time is formatted here? So as it turns out, there is no dedicated date-time format in Excel. And Excel only gives us this one custom format that combines date and time out of the box. But the good thing is, Excel recognizes multiple input formats as date/times, as we've just seen. But it will format them as date plus military time regardless of how we enter them. I alluded to us being able to create our own custom formats earlier, and that is what we would need to do here to see something other than military time. However, that's a whole different can of worms that goes beyond just formatting dates, but one that we will definitely open coming up soon. Alright, up next, we'll talk about formatting methods that apply to any type of data, words, numbers, or dates. I'll see you then. Hey, welcome back. Thus far, we've looked at formatting techniques that are specific to the type of data we're applying them to. But some types of formatting transcend data types and apply to anything we can type into a cell. So in this one, we'll explore a set of formatting techniques that most commonly apply to text data, words basically, but can also be used to enhance the appearance of dates and numbers. A good place to start is the column headers in our Shave Ice tracker, which could benefit from some visual pop to stand out from the rest of the data. First up, we'll take a look at the font of our data. Basically, the visual appearance of the individual characters that make up the values in our cells. Every character, whether it be a number, a symbol, or a letter, will have its own distinct look in each different font. Let's take a look at a couple different ones to show you what I mean. So if we look at the font section of the Home tab in our ribbon, we'll see the word Calibri. This happens to be the current default font in Excel. If we don't make any additional adjustments, all of our cells will be formatted with Calibri font. But if we click the down arrow next to Calibri, a drop-down list featuring a long list of other fonts is revealed. Now to see how different fonts can vary, let's scroll down to Arial, which is another common font. If we select that one by clicking it, and then look at cell A1, which we had selected, we see that the appearance of the individual letters has changed just a bit. but the difference is admittedly subtle. To make this distinction between fonts more obvious, let's now choose a different, somewhat more unusual font, Comic Sans, which is a personal fave of mine. Now, instead of having to scroll through the entire list to look for it, we can instead again click that down arrow and then just start typing Comic Sans. And after a few keystrokes, it pops up. So then we can hit Enter to lock it in. And now we see that cell A1 has been formatted in Comic Sans in all of its glory. Now, I've been told that designers and those more aesthetically inclined than myself tend to frown on Comic Sans. So if there are any design gurus out there, my sincerest apologies. I just couldn't resist slipping in a little Comic Sans given the opportunity. So to keep everything consistent, I'll go ahead and select all of row 1 by clicking the row header, and then choose Comic Sans to format all of our header cells with that font. Now, in all seriousness, deviating from the default font in Excel is probably something you should do only if there's a good reason for doing so. If you're someone with a deep knowledge of design principles, or if you're trying to stay consistent with design guidelines at your place of business, then by all means, change fonts to fit your needs. But if you're like me, the sort of person who likes Comic Sans, you might be better served just sticking to the default. So speaking of Comic Sans, while I like my new column headers, I sure wish I could make them bigger so I could see my beautiful font more clearly. This will involve adjusting the font size, which we can do very easily with this drop-down list next to the font type drop-down. So if we click this down arrow and just hover over these different sizes, we can preview what the font would look like if it's very small, all the way down to very, very, very large. I think I'll stick with a size 14 for now. And then I'll go ahead and auto-fit my column widths just to make sure we can see all of that beautiful Comic Sans. Now, there are also other formatting methods that apply equally across any font. One of these is bold, which makes text thicker and darker and is used to strongly emphasize something. So we can access this by clicking this B on the ribbon, or alternatively, by using the Control+B shortcut. Bolding text is a fairly common operation in Excel, so this is another one of those keyboard shortcuts that's probably worth memorizing. In fact, column headers are quite commonly bolded, so I think I'll select all of row 1 and then format it as bold. Note that I had to click B twice because I already had 2 cells bolded, so Excel's first instinct was to think that I wanted to unbold those cells. So I had to click once to unbold the 2 cells that were bolded, and then again to bold all the other cells. Now, another way to emphasize text a little bit less strongly is to italicize it. We can do this with the little slanted I shortcut on the ribbon. So just to show you that these techniques work equally well with numbers as they do with text, I'll apply this to our number 1 value here in cell A2. And as you can see, now the number 1 has that kind of rightward slant to it. Now, italics, at least in spreadsheets, are not as useful as bolding in my experience, and we don't really have a great use for them here, so I'll go ahead and hit Control-Z to undo my italicization of cell A2. And up next, I'll take a look at the underline command, which you can probably guess pertains to this U with a line under it. The underline format draws a small line under the text we apply it to. This is commonly used for titles and headings, so I think I'll go ahead and underline my column headers in addition to the bold formatting we already have in place. So I'll select row 1 again and then just hit this U. Now thus far, we've been making our formatting changes exclusively through these ribbon shortcuts. But we can access all of these commands and more via the Format Cells menu, just like when we were formatting numbers and dates. So if I right-click a cell in our data and choose Format Cells, and then make sure that this Font tab is selected, which it already was by default, we see all the options that we've already set, plus a lot more. For example, there's a section devoted to effects, which includes something called strike-through, which is an effect that's useful when indicating that a value should be disregarded. So if, for example, I wanted to maintain a record of my first order, but also provide a visual cue that it shouldn't be considered valid data alongside all my other entries, I could apply this strike-through effect to it. So let's go ahead and see what that would look like. I'll cancel out of this, and then select row 2, which has my first order. Then I can right-click, again format cells, and then check this strike-through box. And then if I click OK, we'll see that all the values in this row now have that little line through them. Now at this point, I'd be remiss if I didn't point out that in spite of our lovely Comic Sans font, our spreadsheet is a little, well, boring. Maybe that's because it's in black and white. Fortunately, Excel does not limit us to a black and white color palette. In fact, just about every color you can imagine can be brought to bear on the data we enter into our spreadsheets. To see this in action, with the first row selected, click the down arrow to the right of the letter A that's underlined in red on the font section, and a whole swatch, so to speak, of color options are suddenly available to us. And as we hover over each one, we get a preview of what our cells would look like with that particular color applied. Now we basically have two distinct sets of colors to choose from. At the top of the menu are the theme colors, which tie into Excel's default visual theme. This theme includes things like font styles, colors, and the like. These colors form a color palette, and as such are designed to be pleasing to the eye when used together. The first row here contains the primary theme colors, while the rows of colors immediately below simply contain darker or lighter versions of the primary ones. Then at the bottom of the menu, we have the standard colors, which are closer to your more familiar reds, greens, and blues. My recommendation would be, when you feel a need to apply a color other than black, which as we can see at the top of this menu is the default or automatic color, stick with the theme colors, as they were specifically designed by Microsoft to work with the overall visual look of the spreadsheet. And then choose lighter or darker versions as needed to provide the contrast you're looking for. Now speaking of contrast, we're not limited to applying colors to simply the text in the cells. We can also fill the actual cells with these colors to provide additional contrast with the data we enter into them. So for example, if I select just the cells that consist of my column headers, which I can do just by selecting cell A1 and then doing Control, Shift, right arrow, I can then click the down arrow next to this little bucket icon on the font section of the Home tab, and then with the same palette of colors I had to choose from when jazzing up our fonts, I can choose a fill color for these cells. So I think I'll go with a nice dark blue. Then we can go back to our font color menu and choose a nice light color that will contrast well with the blue. Now I'd be lying if I said that I know for sure this looks good. Again, full disclosure, I am quite far from a design guru, but hey, it's pleasing to my eye. Now while I can't tell you what color contrasts would impress an artist, I can give you some usability guidelines for spreadsheets. An applicable one here is to make sure there is sufficient contrast between your text and your background colors so that your text is easily readable. If your text and background are both too light or both too dark, it will be difficult for your readers to make out the text, which sort of defeats the purpose of having a spreadsheet in the first place. No matter how cool your spreadsheet looks, the most important thing is that it is readable and usable. But hey, enough preaching from me. Up next, we'll go beyond formatting the text in our cells to explore how that text is oriented within the cells that contain it. I'll see you then. Hey, welcome back. In this one, we're going to explore the relationship between the text in our spreadsheets and the cell boundaries that contain it. In short, how text is laid out or aligned within a cell. Now, this is much more of a visual thing than a conceptual thing, so it's probably best to just dive right into an example. So let's say we want to add a couple new columns to our Shave Ice tracker for the purpose of tracking customer satisfaction. The first column will have the text of any review or comment the customer might have left on social media, and the second column will contain any rating that the customer may have left, from 1 to 5 stars. To start, before we even get into text alignment, I'm going to show you a cool little formatting trick that can save you a lot of time. So we would naturally like for the headers of our new columns to match the formatting of our existing column headers. So does that mean we're going to have to replicate the process we went through before, in which we made custom selections for font size, color, and more? Not at all. Thanks to a nifty little tool called the Format Painter. So if we select any cell whose formatting we would like to apply or paint in some other cell, so I'll just choose K1 here, and then click this little paintbrush icon on the left side of the Home tab on the ribbon. That paintbrush is the Format Painter. So I'll go ahead and click that. And then finally click in the cell that we want to apply the formatting to, and I'll click cell L1. You'll see that the visual style is in fact copied. The fact that the font formatting has also been copied over isn't immediately evident, but as soon as we type in a name for our column, which I'll just call Customer Comment, you can see that the font formatting was retained as well. But if I scroll over a bit, and then click in the cell where our second column header is supposed to go, our trick doesn't work anymore. But that does not have to be the case. Now if we again select a cell whose format we want to copy, in this case that can be L1, and then double click the paintbrush icon, we can then copy that format to as many cells as we want. Then, to turn off the Format Painter, just click it again. And while I'm in here, I'll go ahead and call our second column header Customer Rating. And lastly, I'll just go ahead and get rid of these 2 additional column headers that I don't need. Okay, so now we can get down to the business of entering some data into our Customer Comment column. Now, as you know, customer reviews tend to be rather lengthy, whether they're positive or negative. People on the internet, it seems, like to use a lot of words. So to simulate this, I'm going to use something called lorem ipsum text, which is basically just a big heap of Latin words that people often use for sample or filler text. So if I scroll back down to the bottom of our ledger and go ahead and paste my lorem ipsum text to simulate our first customer comment, you'll see that the text is much wider than our cell is, so it ends up spilling out of the boundary of the cell. And if we scroll further to the right, you see that our text just keeps going and going and going. And honestly, this is probably much shorter than the average comment left on a review site. And it actually gets worse. Let's say we also got a review of 3 stars for this particular customer order, and we want to enter that value into cell M101. So if I just type the number 3 here, now we can't even see the comment text that's spilled out of the cell. Clearly, something needs to be done if we're ever going to actually read our customers' comments. Now we could try widening column L, but then we would just have a ludicrously wide column in our ledger that would require a ton of scrolling just to read the comments of. So the solution to this problem is something called wrapping text, which basically means formatting text in such a way that it can appear on multiple lines instead of the default scenario in which it only appears on one line, no matter how long it is. So we can wrap the text, once we select our cell here, by hitting this little Wrap Text button in the Alignment section of the Home tab. Whoa! So now we can read our text, but the row containing our comment has suddenly gotten very, very tall. So what happened here? Well, hitting the Wrap Text button basically makes our row as tall as it needs to be to display all the text we've entered into the cell given the width of the column. So the width of the column is kind of the constraint. But now our row is unreasonably high, and it could still be a little difficult to read the entire comment. Now we can try widening our column a bit, but this doesn't seem to help. Our row isn't getting any shorter. That's because wrapped text doesn't work on an ongoing basis. It auto-adjusts the height of a row when you hit the button, but it doesn't keep adjusting it as you change the width of the column. So what we need to do here is widen our column a bit, like we did, and then reapply text wrapping. So let's hit the wrap text button once to undo the wrap text operation, and then hit it again to rewrap the text, but this time based on the new, wider dimensions of the cell. And now, with a little more horizontal real estate to work with, wrap text ends up yielding a pretty readable block of text in our cell. Now, if we had made our column wider up front, before pasting in the comment text, we might not have had to take the extra step of unwrapping and then rewrapping the text. Alright, so while we're in here, I want to show you one more, somewhat tangentially related trick that can make your life easier. Now thus far we've only looked at copying and pasting entire cells or groups of cells or even entire columns and rows. But sometimes, especially when dealing with large blocks of text like we see here, you may want to copy and paste bits and pieces of the text string, but not the entire value. There can be important information buried in the avalanche of words that make up long-form text like this. So if we wanted, just as an example, to grab just a sentence out of this text, you just double-click the cell, as if you were going to edit it, and then just click before whatever piece of text you're trying to grab. So let's say I want to grab this sentence right here. Then you hold down the mouse key and drag until you've selected everything you want. And then finally, we can just use our Control-C and Control-V shortcuts to copy and paste the text into a different cell. But for the second time in this video, I digress. So now that we've got our text nicely wrapped, you'd think our work would be done. But as we look to the left in the same row, you'll see we have another potential problem. Our row is still quite tall to accommodate our comment text, but all of our other values are relatively short, and as such are practically hidden away, sitting on the floors, so to speak, of a bunch of very tall spreadsheet cells. It might help them to be more readable if we could format the cells in such a way that the values were centered vertically within the cells, rather than on the bottom. This is called alignment, and Excel gives us lots of handy shortcuts to align our text however we want to. These three buttons at the top of the alignment section on our ribbon, the ones with the little horizontal lines across them, help us align our data vertically. That is to say, either on the bottom of the cell, the middle, or the top. The default alignment is bottom, which is causing the readability issues we see here. But if we click the middle button with our rows selected, suddenly all of our values are floating in the middle of their respective cells, which seems in this situation to be an improvement. Now you could obviously also go with top alignment, but middle seems to work better for our purposes, so I'll revert back to that. And we're not quite done squashing formatting bugs yet. So if we scroll back right and look at our column header for our customer comment column, we see that it's stuck all the way over at the left side of the cell, which could make it a little bit confusing as to which column and thus data it pertains to. Much as tweaking the vertical alignment of the values in our row helped make them more readable, aligning values horizontally can have a big impact as well. In this case, similar to before, aligning to the middle probably makes the most sense, except in this case we mean middle in a horizontal sense. So instead of using the row of buttons on the alignment tab that we did previously, we'll go down to the next row, which allows us to align text horizontally. The default alignment is left, which is why, obviously, our header is all the way over there to the left. But if we click this middle button, and if we hover over it, we'll see that it says Center. Now our column header snaps to the middle, which again seems like a nice readability improvement. Now, as with vertical alignment, we also have the option to align left or right as usability and design concerns dictate. Now, similar to vertical alignment, we also have the option to align left or right as usability and design concerns dictate. Alright, so that's it for alignment. Now that we've got a handle on what happens inside spreadsheet cells, up next we'll turn our attention to the outside, or borders of cells, and how we can melt these borders by merging multiple cells into one. I'll see you then. Hey, welcome back. Now that we've learned all about formatting the interior of cells, let's take a look at some formatting options that apply to the boundary around the cell, not what's contained within it. First up, we'll look at a concept called merging, which is a process by which you can combine multiple cells into one giant cell. So why would we want to do this? Let's take a look at an example to find out. Here we have our breakout of sales by shave ice flavor that we worked on previously. One thing we're clearly missing here is some kind of heading. Now, there are only 2 columns, and it's fairly obvious what each one does, so this isn't necessarily a situation where each column needs its own header. An alternative approach we could take is to create one single header that spans both columns. So how can we go about that? Well, first, we'll need to insert a blank row above the first row of data. Now we have 2 blank cells above our 2 columns of data. If we want to turn these 2 cells into a single header that spans both of them, we'll need to somehow merge them together. To do this, select both cells, then click the Merge and Center button on the Alignment section of the Home tab. And as you can see, both cells have now been merged into a single cell. Now also take note of the fact that with this cell selected, Excel lists the address of the cell as A1. And if we navigate over and select the next cell to the right, its address is C1. Cell B1 has basically been merged into cell A1 and no longer exists as far as Excel is concerned. So now we can type some text for our header. I'll go with sales by flavor and hit enter. So not only does the text we typed span both cells, it appears to be aligned to the center of that cell. This occurs because we chose the Merge and Center command, but it's not necessary to center your text when merging. For example, if we click the down arrow next to Merge and Center in the Alignment section, we see an option to simply merge with no mention of centering. To see what this looks like, let's choose Unmerge to unmerge our cells, and then change the alignment of the 2 cells we have selected to be aligned to the left, which is the default in Excel. Note that the Merge and Center command not only merged our 2 cells, but it also changed the alignment of both to center. So now, with both cells selected, click that Merge and Center dropdown again, and then simply choose Merge Cells. And now our merged text is aligned to the left. Note that Excel took the text in the leftmost cell of the 2 we had selected and made it span both cells. This is the default behavior of merge. If you only have text in one cell, it will make that the value of the merged cell. But if you add text in multiple cells, merge will go with the value in the top leftmost cell in the range. So if I unmerge again, and then add a slightly different header to cell B1, let's just call it Flavor Performance, and then try to merge again, we'll see that Excel helpfully informs us of this behavior. And then if I click OK, you'll see that the value we typed in B1 disappears. Now another, less conventional but still fairly common way of constructing a merged header in Excel is to do so with a vertical orientation instead of a horizontal orientation. In our case, that would mean inserting a blank column where column A currently is, and then merging the cells in that column adjacent to our data into one giant cell. Let's see what that would look like. First, I'll go ahead and delete row 1 since we're going to add a new merged heading in column A. Next, I'll insert a blank column before column A to make room for our header. And now I can select cells A1 through A7 and then select Merge. Finally, I'll type in our same heading name as before, Sales by Flavor. Well, that doesn't look right at all. Our value is too wide to fit into the cell, and it's sitting all the way down there at the bottom of what is now an extremely tall cell. Now I could try aligning this vertically to the middle, and then widening the column to accommodate the text. And while this helps, some might think it's still less than ideal. One way to jazz up the effect of the header is to rotate the text so that it's oriented vertically. Let me show you what I mean. So if I click this little diagonal arrow up in the alignment section, we see a pop-up menu that gives us various options for orienting text. The most useful from my experience is Rotate Text Up. Let's try that one and see how it changes the look of our header. And now our header text has been rotated to read from top to bottom rather than left to right, which matches the tall but thin dimensions of our cell. Now we can actually narrow our column a little bit, and the layout of our little table is coming along quite nicely. But there's one other effect that could help clarify the distinction between different parts of our data, and that's borders. Now you may be thinking, our cells already have borders. That's how we can tell the difference between one cell and the next. Technically this is true, but Excel allows us to layer in additional borders that are more visually distinct, which can be a useful visual cue to indicate separation between cells or even different regions of our data. So to start, let's highlight our entire table, and then click the down arrow next to this little grid-looking icon in the font section. And then from all of these border options listed, let's choose All Borders. And as you can see, Excel has drawn in heavier, darker borders between all of the cells we selected. Now, borders of this nature can be useful, but in my opinion, this isn't serving much of a visual purpose in this case. It might be more helpful to draw a border around just the 3 distinct sections of our data: our header cell in column A, our flavors in column B, and our sales percentages in column C. So how can we draw borders around a group of cells without drawing borders around every single cell within that group? Well, before we can do that, let's highlight our table again, and then go back to the Borders drop-down, and then choose No Border to erase the borders we've already drawn. Now let's select the first area that we want to encompass with a border, our merged cell in column A. Then we can go back to our Borders menu and choose Outside Borders. Next, we can repeat this process on our values in column B, and then again for column C. And now you can see that we've drawn a nice little outline around each of the main sections of our data. I think at this point our borders have definitely improved the readability of our little table by making it clear that it's divided into 3 main parts. Now, we don't only have control over which cells get borders drawn around them, but also the thickness of the borders. If you want to create special emphasis around one particular cell or section, you can draw a thicker border around it. For example, I might want to draw a thicker border around our sales percentages, since that's kind of the metric that we're interested in here. So to do that, I can select the values we have in column C, and then go back to our Borders dropdown and choose Thick Outside Borders. So if we click away from this, you'll see that the effect is subtle, but also enough to indicate some additional level of significance for this area of our data. All right, that's it on merging cells and borders for now. Coming up, we're going to shift gears away from formatting and towards some more advanced methods for sifting through our data than we've encountered thus far. I'll see you then. Hey, welcome back. Now that we've learned to enter data into Excel, manipulate it, and format it, it's time to learn some methods for efficiently sifting through all the data we've entered to find specific things we're looking for. The first technique we'll look at is called filtering, and it's as intuitive and easy to use as it is powerful. Filtering lets us search through the rows of the data we've entered and selectively display or hide rows based on criteria that we specify. Any rows that don't meet the criteria we've set are effectively filtered out or hidden from view. This technique is handy in just about any case, but it's another one of those methods that becomes more and more useful, if not essential, as the amount of data in our spreadsheets grows. Like so many features in Excel, filtering rewards us for setting up our data in a tabular fashion. If our data doesn't have column headers and consistent types of data in each column, filtering just doesn't work very well. Fortunately, we had the good sense to set up the data in our shave ice tracker in a tabular fashion, so applying filters is a snap. Really, it is just about as easy as snapping your fingers. If we click anywhere inside of our data, then navigate to the Data tab of the ribbon, and finally click on this filter button that looks kind of like a funnel. Now we see all these little down arrows to the right of all of our column headers. Let's see what happens if we click the one next to our order number column. So now we get a new dialog box that pops up. The first few commands pertain to sorting, which is something we'll get to soon enough. But if we look at the lower half of the dialog box, we see a list of unique values in the order number column, with checkboxes next to each. All the checkboxes are currently checked, along with an additional checkbox at the very beginning that says Select All. If we uncheck one of the checkboxes, let's say the one pertaining to order number 2, and click OK, let's see what happens. And now we can see that our order number 2 has vanished from view. But never fear, it hasn't been deleted. If we want it back, all we have to do is click the Clear Filters button, which looks like a smaller version of the filters icon, but with a red X on it. So if we click that, our row number 2 reappears. But let's say instead of wanting to not see a particular row, we instead only wanted to see a small handful of specific rows. Now if we click the Filter button on our order number column again, and tried to uncheck all of the order numbers that we don't want to see, that would take a long time and just generally seems like a very inefficient way to whittle down to a small population. So how should we approach this? Well, if we uncheck the box next to Select All, we'll see that all of the other checkboxes have been unchecked as well. This means that none of the values in our data meet our filter criteria, which in this case is a good thing since we only want to select a few. So let's scroll down and select order numbers 42, maybe 44, maybe we'll go down and grab 55, and then hit OK. And now we can only see those 3 orders. So by unchecking all of the options and then scrolling through the list of unique items in the column and just cherry picking the ones that we're interested in, we were able to get down to those much faster than if we tried to individually uncheck everything we didn't want to see. Now, one really cool thing about filtered data is that we can copy and paste it elsewhere in our spreadsheet without copying any of the rows that we filtered out. So if I highlight our filtered data set here, which I can do using our Control-Shift right arrow, Control-Shift down arrow keyboard shortcut, and then hit Control-C to copy, and then hit our little plus sign down here to create a new worksheet, and then finally hit Control-V to paste, we see that we only have our 3 rows of data that we filtered for, and that none of the other rows that were filtered out have carried over. Now obviously our column widths didn't carry over, but if we click the top left corner of the grid and just double-click the boundary between any 2 columns, we can auto-fit the column widths, and now we've basically copied over only the rows of data from our sales tracker tab that we were interested in without having to manually scroll through that data and copy and paste the records over to a new tab one at a time. This technique can be extremely useful if you want to work with a filtered subset of your data without having to worry about handling a bunch of additional rows of data you're not interested in. Now, before we move on to more advanced filtering techniques, I want to clarify a couple of things. First is that the values listed in the filter dialog box represent the unique values in the column we're applying the filter to. So if I go back to our sales tracker tab, and then first hit escape to undo our copy operation, clear filters, and then click the filter drop down for a column with fewer unique values. Let's say, and let me just auto fit columns here just so we can see our columns more clearly. Let's say the size column. Now there are only 3 options available for us to check or uncheck because there are only 3 unique values in that column. So obviously if our data set has 100 rows in it, there are 100 values in the size column, but there are only 3 unique values that appear. So that's all we see when we click that filter dropdown. We saw so many values when we click the order number dropdown because all of these order number values are unique. They each only appear one time in the data. Another point worth noting is the process by which the filter button decides what data on our worksheet is in scope for filtering in the first place. Now, because we'd organized our data in this tabular fashion, and because our data doesn't have any gaps in it, the filter button was able to accurately guess the boundaries of our data. But there's no guarantee that it will guess those boundaries if our data has gaps, such as blank rows or columns. For this reason, I recommend manually selecting the entire range of data you want to apply filters to before hitting the filter button if you have any doubts at all about the continuity of your data. It's an extra step, but it ensures that the results you're seeing are truly accurate and comprehensive. So just to walk the walk, let me go ahead and clear filters altogether by hitting our filter button once more. Then I'll select the top left cell in our range, A1, and then scroll down to the bottom of our data, and then scroll right to the last column in our data. And then holding down the Shift key, I'll click that bottom right cell in our data, and now I am assured that I've selected every cell in the range that I'm interested in. Then, after selecting all the data, I can click the filter button once more, and now I know that our filters apply to every row that we care about, so when I filter our data, I can do that with confidence. Okay, now that we have the basic idea of filtering out of the way, it's time to look at some advanced filtering techniques. We'll tackle those in the next video. I'll see you then. Welcome back. As with so many things in Excel, advanced filtering techniques are roughly divided into 3 groups, based on the main types of data they apply to: numerical data, text data, and dates. We'll start with number filters, which we can apply to our sale amount column. So if we click the filter dropdown for our sale amount column, we see a long list of sales amounts, which makes sense because there are so many different combinations of flavors a person can order, so we end up with a lot of distinct values. Now, to be sure, it may be possible that we would be interested in filtering for one or a few of these specific amounts by checking or unchecking checkboxes like we did for the order number column in the last video. But that doesn't seem very likely to me. Instead, a much more common scenario might be that we want to see any sales above or below a certain threshold. So if you look just above our list of values, you'll see an option called Number Filters. Excel offers this because it has detected that the values in this particular column are numbers. So now that I've hovered over that, a whole new set of options pops up, specific to filtering numbers. The one closest to what we're trying to do seems to be greater than, so let's click that. And here Excel is doing a great job of spelling out how this filter will work. If you just read through the dialog box, it says, show rows where sale amount is greater than, and then it leaves it to us to fill in the blanks. So let's enter the number 40 and click OK. And now our data has been whittled down to just those 5 rows with sales amounts over 40. And we can easily modify this to view rows below a certain threshold, say for example, under $10. To do this, I can first clear the existing filter on sale amount by clicking the filter arrow and then choosing Clear Filter from Sale Amount. Now I'll click the filter arrow again, go back to Number Filters, and then, just to put a slightly different spin on this one, I'll choose less than or equal to, which works just like it sounds. Now the dialog box that pops up is very similar to the last one, so I'll just fill in the blanks once more with 10 to represent our threshold, and then click OK. And it worked just like before. But what if we wanted to apply multiple types of filters to the same column? Maybe we're interested in extreme values, also known as outliers, and would like to see any sales amounts greater than 40 or less than or equal to 10. Essentially a combination of the two filters we just applied. To do this, we'll need to apply a custom filter, but that's actually much easier than it sounds. So let's again clear filters on our sale amount column, and then go back to our number filter menu, and then we'll choose Custom Filter. And it turns out that the dialog box here is basically identical to what we saw before, just without options being pre-selected for us. So it's up to us to say whether we want the value to be greater than, less than, or so on. We'll go with greater than, and then enter 40. But now we need to add our additional criteria. Fortunately, we see another row right here below the other one we just entered our information into, so that looks like a promising place to start. In the drop-down, we'll scroll down until we find is less than or equal to, and then we'll enter 10 for our threshold. But notice that this little radio button next to the word and between our two rows is selected. That's actually not what we want. It's mathematically impossible for a sale amount to be both greater than 40 and less than or equal to 10, so we would never get any results. What we actually need is an OR condition, which will display a record if either of our conditions is true. So let's go with OR, and then click OK. And sure enough, we now only see sales amounts that are greater than 40 or less than or equal to 10. Pretty cool. So next up, let's take a look at some filtering techniques we can apply to text data. That is, basically anything that isn't a number or a date. Our advanced text filtering techniques generally revolve around the concept of pattern matching. That is to say, instead of searching for exact values, we search for values that fit a certain pattern. For example, values that begin with or end with a certain sequence of characters, but could otherwise vary outside of that requirement. For an example, let's click the filter arrow for our Flavor To column, and then hover over the Text Filters option, which again popped up because Excel recognizes the type of data in this column. And now we see a list of filter options specific to text data, just like we saw number-specific options previously. Now let's say we want to filter for any flavors in our Flavor To column that end with the word apple. So if we click the Ends With option, we again see a dialog box, similar to the one we worked with previously, that already has our search method filled out. Ends with, in this case. So now we can just type Apple in the text box and click OK. And now we can see that our data has been filtered to records that either have the value apple or pineapple in the Flavor To column, both of which end in apple. Another way to apply pattern matching is to filter for values that contain a certain piece of text, meaning it does not have to be in any particular position, not necessarily the beginning or the end, just somewhere in the text. This approach is naturally more inclusive than the ends with method we used previously, or its counterpart begins with. Any value that begins or ends with a given text string also contains it. To see how this works, let's search our Flavor To column for any values that contain a space. We'll follow the usual pattern of clearing the previous filter, then clicking the filter arrow again, and hovering over text filters, but this time we'll choose the Contains option. Then, in the same text box where we entered apple last time, we can simply hit the space bar once to effectively type in a space, and then click OK. And now we see all of our flavor names that consist of more than one word: passion fruit and snow cream. And just like number filters, we can combine multiple criteria using a custom filter. If we only want to add on to the filter we've already applied, we don't even have to clear filters from the column. Instead, we can navigate straight to Custom Filter after clicking the Filter dropdown, and we'll see that our existing filter is already in place. If we want to modify this such that we return any flavors that either end in the word apple or contain a space, we'll simply check the radio button next to or, then select ends with in the second dropdown, and finally type apple in the second text box and click OK. And now the records displayed reflect both of the criteria that we've applied. One more thing worth noting here before we move on to date filters. Our Flavor To column contains certain blank rows. This simply indicates that a customer only ordered one flavor, meaning there was no need to enter information for that particular order in our Flavor To column. It's quite common to want to apply filters to blank rows, so let's take a look at how to do that. So first we'll clear our existing filter, then we'll click the filter arrow again, and if we look carefully at the list of values, you'll see that one of the options is blanks. This is basically empty cells, and again something that's quite frequently the target of filtering operations, either to show all rows with a blank value in a particular column or to hide those rows. In our case, we'll show them by first unchecking the Select All checkbox to uncheck all the options, and then simply checking the checkbox next to blanks and clicking OK. And now we only see records that did not have a value entered in our Flavor To column. Okay, so lastly, let's have a go at filtering some dates. First, I'll clear the filters on our Flavor To column. But as we work on our date filters, I'd like for you to keep in mind that our filter on the Sale Amount column is still applied. Now, filters applied to different columns of our data are additive. That is to say, they build on each other, and they all have a say about whether a row will be filtered out or not. The more filters we add to our data on different columns, the fewer rows we'll see, because there will be more and more criteria that each row has to meet in order to be displayed. So as we're applying filters to date values, keep in mind that the rows we see don't just have to meet these new date criteria we're going to apply, but they also have to meet the criteria we've already applied to our sale amount column. So for the purposes of date filtering, we'll use our sale date time column. So let's click the filter arrow for that one. Now instead of a list of values like we saw for number and text data, we instead just see 2 years listed with plus signs next to each. Digging deeper, if we click one of those plus signs, we see months rolled up under the year, each of which has its own plus sign. And then going even deeper, if we click one of those plus signs, now we see a list of days that belong to that particular month. And we can keep going, depending on how specific we want to be, from day down to hour to minute and even second. Now, we're not going to get that granular here, but the point is that since Excel is smart enough to recognize the values in this column as dates with time components, it organizes the unique values in the column in this tree-like structure that lets us filter for broader or narrower slices of time as we see fit. So for example, if I just want to see data from 2020, I can uncheck the box next to 2021 and click OK. And now we're only seeing rows of data that meet our existing sale amount criteria and also had a sale date time in 2020. Now likewise, I can go back to my filter menu for the sale date time column, click the plus sign next to 2020, and then uncheck November, which means that now my only results will be from December of 2020. And you can keep going in this fashion, down as many levels through the hierarchy as you like, picking and choosing which years, months, days, and so on you want to see or do not. More often, however, we are likely to be interested in a specific range of dates, say before or after a certain date, or from the 15th of one month to the 15th of the next. Let's say we're particularly interested in all sales made after December 1st, 2020. To apply this filter, I'll first clear my existing filter, and then click my filter arrow for the sale date time column again, and then we'll hover over the Date Filters option in the filter dialog box. And then from this very long list of options we're presented, we'll choose After. And we again see our now familiar dialog box, which lets us specify custom filters. Now, After is pre-selected, so all we have to do is select our date of interest, which is December 1st. Because Excel is smart enough to recognize that we're dealing with date data, it actually isn't going to force us to type a date by hand. Instead, we get to use this nifty little calendar date picker that we can use to choose a date. So let's click that, and then I'll navigate to December 1st, 2020. But before we click OK, let's think about what After really means. We want any sales made on or after December 1st, but After sounds like it would give us anything after December 1st, not including that date. So let's click the drop-down box here and see if there are any other options that fit our need better. And here we see an After or equal to option, which sounds like exactly what we need. So let's choose that and click OK. And just glancing at the dates we have left, it seems like our filter worked fine. Now let's take a crack at the other scenario I mentioned, in which we might want to filter for sales that occur between two specific dates. Let's say between January 15th, 2021 and February 15th, 2021. So let's clear our last filter, then go back to our filter menu, hover over Date Filters again, and then choose Between from the list of options. And we see that this is once again pretty much the same dialog box we've been working with all along, but it's been pre-filled with some options that make sense for the particular thing we're trying to accomplish. In short, it's saying we should filter for all dates that are on or after the first one we specify, which in this case will be January 15th, 2021. And we see that the AND option is pre-selected for us here, all dates on or before the second date we specify, which in this case will be February 15th. At this point, I hope you're getting the hang of this dialog box and see that most of the advanced filtering options Excel gives us really just involve configuring the options in this particular menu. At this point, it looks like we've got all of our parameters filled in, so let's go ahead and click OK. And it looks like this filter worked as well. Now, there are obviously a whole host of other filtering options, which you can see if you just hover over the Date Filters option in the Filter dialog box. But most of these are relatively self-explanatory once you know how the filtering menu works. Not just for dates, but for text and number values as well. My hope is that at this point you understand the mechanics of this filtering menu well enough to figure out how to apply whatever filter you're looking for without needing to memorize every option Excel gives you. So now we've learned how to hide data we don't want to see to make it easier to spotlight what we're interested in. But sometimes, instead of simply showing or hiding data, it's helpful to rank our data points by some criteria so that the ones we're interested in bubble up to the top without the need for hiding any rows. This approach is called sorting, and we'll dive into that next. I'll see you then. Hey, welcome back. So now we know all about how to selectively hide rows of our data that we're not interested in using filtering. But sometimes filtering isn't enough. We can apply a filter to look at all sales above a threshold, for example, but the results returned are likely to be shuffled around so that the most expensive sale isn't any more likely to be at the top of our results than the least expensive one. Quite often, we're interested in seeing our data sorted in such a way that the most important data, and what important means is the criteria that we need to define, bubbles up to the top. Let's take a look at an example to show you what I mean. Back in our shave ice tracker, let's click the filter button on our sale amount column and first apply a quick filter to only look at sales over $35. So we should be old pros at this by this point. We can just hover over number filters, go to greater than, and then just punch in 35 and click OK. And as you can see, we get a lot of results, but the most expensive sales, our sales over $40, are randomly scattered in with the rest. What would be really nice is to see the most expensive sales clustered at the top. So we can actually achieve this view by clicking our filter button again, and then choosing largest to smallest. So this takes our filtered rows and sorts them by the value in our sales amount column, such that the most expensive sale is in the first row, the second most in the second row, and so on. Now obviously we have a few sales of the same amount, so these are all clustered together. Keep in mind that all of the other values in the same row as the sales amounts were moved along for the ride as well. If you sort by the values in one column, but that column is part of a larger range of cells that we've applied sorting or filtering to, the entire row that the value in the sort column is part of will be repositioned, along with that value. Now this sorting was only applied to rows that were still visible based on our filtering. So if we undo the filter, we see that our sort order has gone awry. But we can now go back to the filter button and then choose sort largest to smallest again. And now our entire data set is sorted in this fashion. The ability to sort by one column is incredibly useful, but just as we might want to filter by multiple columns in our data, we often want to sort by multiple columns as well. To access this functionality, we'll actually have to go into a different menu that's specific to sorting. We can access this on the Data tab via the Sort button, which is located right next to our Filter button. So if we hit this, we immediately see two things. One is that Excel already recognizes that we have sorting applied to our sale amount column. So we actually see a row on this dialog box that says Sort by Sale Amount on cell values in order from largest to smallest. The other thing we see is that sort has auto-selected the cells in our data range, which is because we have filters in place on that data. Also note that there is a My Data Has Headers option, which is grayed out because data with filters applied is understood by Excel to have headers by default. But now if we remove the filters from our data by clicking this filter button again, and then select the range of cells containing our data, which I'll do by selecting the top left cell in the range, and then scrolling to the bottom right corner of our range, and then holding down the Shift key and clicking that bottom right cell, and finally hit the Sort button again, you'll see that the My Data Has Headers checkbox is no longer grayed out, and it's checked by default. So let's uncheck this box, and then use the Sort dialog box to sort by our Flavor 1 column. So if I click this drop-down, I see that we don't have column headers listed here, just the actual columns themselves. So we'll actually need to figure out which column our Flavor 1 values are in. And it looks like it's column E, so we'll choose column E. And then otherwise we can stick to the defaults, sorting on cell values in order from A to Z. So let's click OK. Whoa, what happened? Our column headers disappeared. So where did they go? Well, if we scroll down through our data, we'll see that our column headers have somehow made it all the way down to row 42. So why the heck did this happen? Well, since we told Excel that our data doesn't have headers, it assumed that our flavor 1 column header was just another value, and sorted it alphabetically along with all the other values in that column. And you can actually see here how the phrase flavor 1 slots in alphabetically between cherry and mango. And this also illustrates how sorting by the values in one column, like column E here, will cause all the other values in that row to get moved alongside that value, which you can see since all of our column headers have moved down to row 42. Now, sorting our headers along with our data obviously isn't what we want, and I really just went through this exercise to illustrate to you that as long as the data you're sorting has headers, which if you're organizing your data in a tabular way, it should, that you should leave this My Data Has Headers checkbox checked. So let's hit Control-Z to back our way out of trouble. And now if we scroll up while looking at the values in our sale amount column, we'll see that our sort order from our previous sort was preserved. Let's take a crack at modifying this sort so that the smallest amounts show up on top instead of the largest. So it looks like our range is still selected, so we can go ahead and hit our sort button again. And then in the sort dialog box, we'll sort by sale amount, on cell values, and in order from smallest to largest, all of which are the defaults. Then click OK. And now we see that our smallest sale amounts have bubbled up to the top of our data. Now I mentioned previously that we need to use this sort button if we want to sort by multiple fields in our data. So let's say we want to sort by both our sale amount, as we've already done, and also our shave ice flavor. So how would we do that within our sort dialog box? Well, if we click the sort button again, we'll see that Excel remembers that we already have one sort in place. We already have a row that says sort by sale amount on cell values from smallest to largest. But if we look at the top left of this dialog box, we'll see an option to add level. So let's click that. And now another row of inputs pops up below the one we've already filled out. So first, we'll choose to sort then by flavor 1, on cell values, and from A to Z, basically alphabetically, such that flavors beginning with A would come first, and flavors beginning with Z would come last. Finally, I'll click OK. But now looking at our data, this doesn't seem to have had a huge effect on the values in our flavor 1 column. We see lots of examples right away of flavors that seem to be sorted out of alphabetical order. So what's going on here? Basically, when you apply multiple levels of sorting, the data is first sorted by the first column you apply sorting to. Then, your next sorting level only kicks in when there are multiple repeating values, that is to say, groups of equal values, in your first sort column. Now, within these groups of equal values, sorting can then occur on your second sorted column. So our first 5 rows here, all of which have the same sale amount, have subsequently been sorted by flavor 1 in alphabetical order, which you can see starting at blackberry, then mango, passion fruit, and pineapple. But if we move down to the 6th row, we'll see that the alphabetical sorting has reset, since we now have a value of apple in that row. And that's because in the sale amount column, we've moved on from that group of $6.96 sale amounts onto the next value. And it actually gets worse if we don't have groups of similar values in our first sort column, like we do here. If all of our sale amounts were different, our second sort level would be completely irrelevant, since there would be no groups of identical sale amounts to sort within. It really wouldn't be any different than if we just didn't sort by flavor 1 at all. So what's the lesson here? Basically, when you're applying sorts to multiple columns, sort by the column that has the fewest unique values first. If a column only has a few unique values, there will be large groups of similar values within that column that we can meaningfully sort within those groups by the values in our next column, which presumably has more unique values. So let's click our Sort button again, and then swap the order of our two sorted columns using the up arrow in the Sort dialog box. So I'll click our second sort, and then click this up arrow, and now we're sorting first by flavor 1, then by sale amount. Finally, I'll click OK. And now we see that the dynamic has been reversed. Our data is now sorted alphabetically by the values in the flavor 1 column, and then within each group of rows pertaining to a particular flavor, there's another layer of sorting applied, this one based on sale amount. And then the sale amount sorting resets every time we hit a new flavor. So what if we wanted to add another layer to our sort? Let's say the style column. Let's think for a moment about where that should fit in relative to the other two columns we've already sorted on. So if you look at the distinct values in the style column, you'll see that there are really only two, mainland and island. Compare this to our flavor 1 column, which has several unique values based on all the flavors we offer, and it becomes clear that we should sort first by style, then by flavor 1, and finally by sale amount. So let's click our Sort button again, and then add a new sort level, in which we'll sort by style from A to Z. Then finally we'll click that row, and then click the up arrow to move it first in the sort order. And now if I click OK, we'll see that all of our island style rows are grouped first, followed by all of our mainland style rows. And then the rows belonging to these groups are subsequently sorted in alphabetical order by the values in the flavor 1 column. And then finally, the rows in these subgroups are sorted from smallest to largest by sale amount. So thus far, we've sorted by a number, sale amount, and a couple of text values, flavor and style. But what about dates? Let's throw in a sort on sale date time, replacing our sort on sale amount. Now, if you think about the types of values in our sale date time column, they're really even more likely to be unique than our sale amounts. Even in our sale amount column, you see some groups of repeating values since we're selling the same types of items over and over again. But it's unlikely that we ever processed a shave ice order at the exact same time as another, so the values in our sale date time column should be almost entirely unique. With more unique values, you should be thinking that this sort needs to be applied last, after our other two. So going back to our Sort dialog box, let's select our sale amount sort and then delete that by clicking our Delete Level button here. Then we'll add a new sort level. We'll sort by sale date time, on cell values as usual, and from oldest to newest, which is a date-specific option that Excel is smart enough to give us because we're sorting on a column with date values. We would also have the option to sort from newest to oldest if we wanted. Now I'll click OK. And if we scroll back through our data again, we'll see that our first two levels of groupings remain unchanged. We still have our rows grouped by island, style, and then mainland, and then within those groups by our different flavors. But now these subgroups of style and flavor are sorted by sale date time from the oldest date to the newest date. Pretty cool. All right, we've pretty much covered the bases of entering, manipulating, and parsing raw data in Excel. And these are, in fact, all things Excel is very good at. But where Excel really shines and separates itself from just about any other application in the world is its ability to make complex calculations and formulas, and I don't just mean math, accessible to non-programmers. With the solid base we already have in Excel, it's time to take things to the next level by exploring formulas and functions. We'll start our journey down that road in the next video. I'll see you then. Welcome back. Now we're going to begin our exploration of the one thing that spreadsheets probably do better than any other type of software: formulas and functions. If you remember the word formula from your math classes, it probably brings to mind bad memories of algebra and trigonometry. And while those algebraic and trigonometric formulas can absolutely be performed in Excel, the word formula has a slightly broader meaning in the world of spreadsheets. In Excel, a formula is basically just an operation on one or more pieces of data that yields some new piece of data. This operation can be performed on numerical data and include things like trigonometric calculations, but it can also be an operation on dates and times or even text data. But since formula operations on numbers are probably most familiar and intuitive, we'll start there. So let's first see if we can get 2 plus 2 to equal 4 in Excel. To write this formula in cell A1, we first need to type in an equal sign. All formulas and functions begin with an equal sign, which signals to Excel that we are not just entering a static piece of data like a number or a date. Now take note at this point of the fact that we now see an equal sign in both our cell and the formula bar just above the grid. You can actually write or edit your formulas in either place, but I tend to prefer the formula bar, as it's a little more visually distinct and can actually be expanded to make room for longer formulas by clicking this little down arrow on its right side. Just know that clicking in the formula bar will allow you to enter either values or formulas in whatever cell you had selected before you clicked there, which in this case was cell A1. Okay. Moving on with our actual formula, we'll next type 2, and then a plus sign, and then another 2, and finally hit enter. And there we have it. 2 plus 2 still equals 4 in Excel. Now, there are, of course, a whole slew of other arithmetic operations we can perform in Excel, most of which we'll save for another video. But let's take a quick look at subtraction, which works just like addition. So if I want to subtract, for example, 7 from 11 in cell A2, I can just type equals, and then the number 11, then the minus sign, then the number 7, and finally hit enter. And once again, our answer is 4. Now these sorts of calculations are all fine and good, but you might be wondering at this point how what we've been doing is any different than just punching numbers into the calculator on your smartphone. And in fact, the answer is not a lot. What gives Excel formulas their power is their ability to separate the inputs to the formula, and in this case, that's the numbers 11 and 7, from the actual calculation we're performing on them. This way, we can see the inputs and the result of our operation on them side by side, and more importantly, vary those inputs and see the impact on our result. The key to this is to avoid entering actual values in your formulas, and instead reference cells elsewhere in your spreadsheet that contain those values. So let's go down to cell A4, and there I'll type the number 11, and then I'll tab over to cell B4, and I'll type the number 7. Then I'll tab over to C4, and in C4 we're going to enter a formula, but just a little bit different than what we've been doing thus far. I'll start with equals, as we always should, but then I'll type the address of cell A4, which is just A4. And you see right away that Excel knows that we're referencing that cell because the cell lights up. And then a minus sign, just like we did before. And then you can probably see where this is going. I'll type B4 and then hit enter. And as you see, we got the same result as before. So when you use a cell address in a formula in Excel, Excel uses whatever value is stored in that cell as though you had typed that actual value in your formula instead. So when Excel is interpreting our formula here in cell C4, it looks up the value we've stored in A4, then subtracts the value we stored in B4, and finally returns the result in the cell we typed our formula in. The value of this approach really starts to become clear when we want to change the inputs to the formula. So let's say instead we want to subtract 273 from 1,111. All we had to do was update the values in our input cells, and our formula automatically refreshed with an updated output. So now our inputs and our formula output are side by side, giving us visual insight into the effect of our inputs on our calculation. This is valuable even on a small, simple formula like this. But Excel formulas can get a lot longer and more complicated. We can have as many inputs as we want, for example, and formulas can actually reference the output of other formulas. For example, if I go down to cell A6, I can create a formula that adds all three of our values from row 4, one of which is a formula. So I'll just type equals A4 plus B4 plus C4. Now, as our formulas grow, it becomes more essential to separate our inputs from the calculation being performed in the formula itself. The whole point of formulas and functions in Excel is to be able to vary the inputs to our calculations so we can then see how our output changed. So now I've got a formula that's referencing another formula that's referencing two inputs. So if I change that first input, the value in cell A4, to maybe the number 300, now both of our formula cells update. So if you have actual numbers in your formulas and not references to other cells, this won't work. You can't vary those inputs unless you actually go into the formula and edit the formula itself. So entering data into your formulas, like we did up here in cell A1, where we actually typed the number 2 into our formula, is called hard coding, and it's a big no-no when dealing with formulas in Excel. You should avoid hard coding at all costs, except in cases where one of the formula inputs is something that just doesn't vary, like maybe the value of the number pi, for example. Okay, so enough preaching about that. Before we go, I want to show you an even easier way to reference cell values in your formulas. Up to this point, we've just been typing out the cell addresses, which can get a little cumbersome as our formulas grow longer and we need to reference more cells. But instead of typing out the cell addresses, once you've typed the equal sign in either the cell or the formula bar, you can actually just click in the cell you mean to reference. At that point, Excel will automatically enter the cell address for you. So as an example, I'll actually rewrite our last formula using this technique. So I'll just go ahead and delete my formula in cell A6 where I added A4, B4, and C4. And now I'll again type equals. But instead of typing out A4, I'll just click the cell. And then another plus sign, and then I'll click B4, and then another plus sign, click C4, and enter. Just like that. All right, there's far more to talk about with formulas than we could possibly fit into one video, so I'm going to leave off here. Up next, we'll dig a little deeper into how to perform some of the most common mathematical calculations in Excel using formulas. I'll see you then. Hey, welcome back. Now that we've explored the basics of creating formulas in Excel, let's dig a little deeper into performing mathematical computations with formulas. We briefly looked at addition and subtraction in the last video, but there's actually a whole range of other mathematical operations you can perform in Excel. Let's begin at the beginning by briefly recapping addition and subtraction. In our example workbook here, we have a couple of input cells, B1 and B2, and then a series of cells that we're going to fill in with the results of various types of calculations on our two inputs. Starting in cell B4, we'll add our two inputs by typing an equal sign, and then selecting cell B1, and then typing a plus sign, and then selecting cell B2, and finally hitting enter. Then we can subtract cell B2 from cell B1 in the same way. Equals B2 minus B1, and enter. Now is where things get a little more interesting. We haven't looked at performing multiplication in Excel yet, and if your instinct is to look for the traditional multiplication symbol, which looks like an X, you might be in for some confusion. In fact, the multiplication operator in Excel is the asterisk or star character. As far as Excel is concerned, an X is just a letter in the alphabet, nothing more, nothing less. So to multiply our two values together, I'll type equals B1, and then times, and as you can see, that's the asterisk or star, whatever you want to call it, and then B2, then enter. Up next is division, which again uses a different symbol than you might be familiar with. Excel uses a / for division. So to divide our first input by our second, I'll type equals B1 / B2, and then enter. Now lastly, we'll take a look at exponentiation, a crazy sounding word that really just means taking a number to a certain power. Squaring a number by multiplying it by itself is really just exponentiation, in which the number 2 is the exponent. So what strange character does Excel have in store for us for exponentiation? The answer is the up arrow icon, which you'll place directly after the base number and before the exponent. So if I wanted to square our second input, in other words, raise it to the second power, I would type equals, then click the input cell, then type the up arrow icon, finally type the number 2, and then enter. And there we have 49, which is the result of squaring 7. So all of these calculations are simple enough, as long as we perform them one at a time. But certain formulas you may need to replicate in Excel require you to combine multiple kinds of operations in a single formula. These more complex formulas may give you unexpected results if you don't have a good understanding of the order in which Excel executes formula operations. Let me show you what I mean. So let's say we want to add our two inputs and then multiply the result by 2. Seems simple enough, right? So maybe the most intuitive way to go about this, and I'll do this in cell B14, would be to say equals B1 plus B2 and then times 2. So let's hit enter. Now I'm no mathematician, but 21 plus 7 times 2 is not 35. This doesn't look right. So what happened? So unlike what our intuition might lead us to believe, Excel doesn't simply perform these calculations from left to right. Instead, it follows a defined order of operations that applies to all calculations in Excel. I'll go over what that exact order is in a moment, but for now, just know that multiplication has higher precedence than addition. This means that the first operation Excel performed was to multiply our second input here by the number 2. Then, the output of that calculation was added to our first input, leading to the result we see. The result isn't incorrect per se. Rather, Excel just misinterpreted our request. So how can we override this order of operations to force Excel to execute our calculations in the order that we want? That is to say, to add our two inputs first, then multiply them by the number 2. The answer is parentheses, which you will need to make friends with if you want to do any serious formula work in Excel. So by wrapping an operation in parentheses, you can effectively force Excel to perform that operation first, regardless of where it fits into the standard order of operations. In this case, we want to make sure our addition operation is performed first. So all I need to do is wrap our addition in parentheses. So what I'll do down here in cell B16 is type equals, and then an open parenthesis, and then our B1 plus B2 expression, and then I'll type a closing parenthesis. So now our addition operation is wrapped inside of parentheses, and then multiply that by 2. And now if I hit enter, it looks like we got the correct result. So at this point you may be asking, what exactly is this mysterious order of operations? Well, This handy little table here breaks down which operations Excel performs first, as well as the symbol associated with that operation in Excel. Now, as you can see, just like we discussed, any operation wrapped inside of parentheses takes precedence over any other operation, which gives us ultimate power to dictate the order in which operations are performed. Next up is exponentiation, followed by multiplication, then division, then addition, and finally subtraction. Now, do I really expect you to commit this table to memory? Heck no. This is not high school biology. While you should remember the symbols associated with these operations, asterisk for multiplication, / for division, etc., the exact order of operations is more of a nice to know. I say this because we have the ability to control the order of operations with parentheses, and because we should be using those parentheses anyway, since they make the intentions of our formula clear. Even if we don't technically need the parentheses, they can still serve a valuable role in making our formulas easier to read. Let's say in our earlier example, I really did want to multiply our second input by 2 before adding our first input. So going back to our formula in cell B14 here, let's say that the output of this formula actually is what I wanted. I really did want to multiply our second input, 7, by 2, and then add 21 to that. So without parentheses in this formula, that's what the formula does by default. But I can still make my intention here more clear by wrapping parentheses around the second operation. So if I put parentheses around this B2 times 2 operation within the formula and hit enter, the result of the formula remains the same. But just looking at the formula, it's clear to me or anybody else who might be looking at it that I intended for this operation, this B2 times 2, to come first. In a case like this, in which we apply parentheses to an operation that was going to come first anyway, they basically have no tangible effect on the output. But somebody reading our formula will know that we intended for that second operation to occur first, as opposed to thinking that we might have just forgotten parentheses around the first operation. In fact, if I saw a formula like this with no parentheses, my first assumption would probably be that the formula's author intended for the addition operation to be performed first and simply forgot to add parentheses. So at worst, parentheses add clarity to our formulas, and at best they enable us to override Excel's order of operations and dictate our own. The bottom line is, don't hesitate to use them liberally in your formulas. So I alluded to this briefly, but Excel formulas are not limited to merely math. Far from it. We can also use them to perform operations on dates, and even, surprisingly enough, text values like people's names. We'll take a look at formulas that operate on text data in the next video. I'll see you then. Hey, welcome back. So far, we've looked at applying Excel formulas in the most obvious possible way, to arithmetic calculations like addition, subtraction, and multiplication. But in Excel land, formulas need not be limited to numbers only. For example, we can also apply formula operations to text. Now with that said, our options for doing so, at least until we start digging into functions, which are a related but distinct entity from formulas, are a bit more limited than those for working with numbers. As you might imagine, there's no concept of things like division or multiplication when it comes to formula operations on text. However, we are able to perform a kind of addition between text values and our formulas. This addition, so to speak, of text values has a special name: concatenation. Instead of the plus sign that we use for adding numbers together, concatenation uses the ampersand operator. But what the heck does concatenating, text really mean? Let's take a look at an example. Here in our example worksheet, similar to the one for our last video, we have some input values that we'll combine and manipulate using formulas to produce certain outputs. For instance, in row 2, we have a first name, a last name, and then a blank cell in which we'll try to add or concatenate those values together. So adding text values really just means combining them end to end. If you add 1 plus 2 arithmetically, the answer is 3. But if 1 and 2 were both text strings, concatenating them would yield 12. Make sense? Alright, so in this example, we want to create a single text string consisting of our last name in cell B2, followed by our first name in cell A2. To do this, in cell C2, we'll type equals, then B2, then the ampersand, and finally A2, and then hit enter. Well, this kind of worked. Our first name and last name values have now been combined into a single text string, and the last name does precede the first. However, what we're missing is the comma that conventionally separates last and first names when they're listed in this order. So how can we go about adding in that comma? Well, just like addition, we're not limited to concatenating only 2 strings in a single formula. As such, we can try concatenating a comma between our last name and our first name. So if we go back into our formula, and then type a comma after our ampersand, and then another ampersand to glue that comma to our first name from cell A2, keep in mind here that just as with addition, you need an ampersand between any 2 text strings you're trying to concatenate together. And then it looks like we can go ahead and hit enter. And Excel does not like this one bit. So what went wrong? So the issue here, which this dialog box is not doing a particularly great job of explaining, is that Excel treats text values as distinct from numbers and requires us to enter raw text values, like a comma, as opposed to text data in cells that we reference, with double quotes around them to set them apart from other types of data. So if we want to include a comma in our text string, we'll need to surround that comma with double quotes. So if we go back into our formula by clicking OK, and then add some double quotes around our comma, and then hit enter, now our formula works. Next, we'll try rearranging our name in a more conventional way, in which first name is listed first, followed by a space, followed by the last name. The real question here is, how do we force a space in between our 2 names? Well, in Excel, a space is treated the same as any other character. So if we want to concatenate a space between our first name and last name, we just need to wrap that empty space in double quotes, just like we did with the comma in the last example. So let's try that. We'll type equals, first name, and then ampersand to concatenate, and then a double quote, and then I'll hit the space bar on my keyboard, and then another double quote, and then an ampersand, and then our last name, and then hit enter. And it works. Now, just to solidify these concepts, we'll apply the same techniques to a couple of slightly more involved examples. If we want to combine last, first, and middle names with a comma after the last name, we can do so by simply adding more inputs and ampersands to our previous formula. So if we want to do last, then first and middle, we can type equals, and then the last name, and then concatenate in a comma surrounded by double quotes, and then another ampersand to glue in the next piece, then the first name, then another ampersand, then more double quotes surrounding a space for our space between the first and middle names, then one more ampersand, and then finally the middle name. Now lastly, we can spell out the full name of proud Kentucky native Billy Ray Cyrus using the same techniques down here in cell D14. So we'll type equals, then the first name, then a space wrapped in double quotes, another ampersand, the middle name, another ampersand, and then another space wrapped in double quotes, yet another ampersand, and finally the last name. And there we are. Now, one more thing before we go. Earlier, I alluded to the idea that concatenating the numbers 1 and 2 would equal 12. You might have thought I was exaggerating to make a point, but not really. The trick is, you have to tell Excel to treat the numbers 1 and 2 as text strings. And as we've already seen, double quotes are the way that you signal to Excel that what you're enclosing within them is text. So in cell A18, which is merged, as you can see, if I type in equals 1 plus 2, but then wrap the 1 and 2 in double quotes, so I'll type equals 1, and then I'll use our text addition operator, our concatenation operator, the ampersand, and then 2, and hit enter, you'll see that 1 plus 2 can in fact equal 12. All right. While we've really only explored one fundamental text operation here, I can assure you that Excel provides many, many more ways to manipulate text. Most of these, however, require the use of formulas, which is a topic that we're going to jump into very soon. In the meantime, though, we're going to take a look at formula operations on dates, which have their own unique spin on addition and subtraction in Excel. I'll see you then. Hey, welcome back. So we've looked at how to perform operations on numbers and text with formulas in Excel, so now it's time to do the same with dates. But before we start playing around with date calculations, you first need to get inside of Excel's brain to understand how it processes dates behind the scenes. Trust me, this will help you make sense of quote-unquote date math in Excel later on. First up, let's do a little exercise. Here we have the date April 17th, 2021 in cell B1. Just for grins, let's try formatting that as a number and see what happens. So we'll just format as a number. Very strange. Not only does Excel let us format the date as a number, it also returns an extremely specific number of 44,303. So now let's reverse the dynamic. Next, we'll try formatting the number 1 here as a date. And here we get January 1st, 1900. So what the heck is going on here? Well, the whole key to understanding dates in Excel is the fact that as far as Excel is concerned, time began at midnight on January 1st, 1900. And behind the scenes, Excel looks at every date value in terms of how many days that date is past the beginning of time, so to speak. So April 17th, 2021 just so happens to be 44,303 days after midnight on January 1st, 1900. But why does Excel choose to look at dates this way? The answer is that looking at dates as numbers behind the scenes allows you to perform certain calculations on them as if they were numbers, namely addition and subtraction, which you can perform both between dates and between dates and numbers. Before we move on to examples of these types of calculations, I also want to show you how Excel looks at times. It turns out it's pretty much the same deal as with dates. So first let's try formatting 1.5 as a date time. So I'll go down to Format Cells, and I'll choose our one custom format that allows us to put a date together with a time, and click OK. And now we see we get the same date as before, but there's also a time component of 12 o'clock or 12 noon. So why do we have a time component, and why is it 12 noon? Well, the thing is, Excel just looks at times in terms of fractions of a 24-hour day. Since 12 noon is exactly halfway through the day, its numerical value is 0.5. So when we formatted 1.5 as a date time, Excel gives us the date, January 1st, 1900, plus the time component of 12 hours past midnight on that date, or 12 noon. Similarly, if we had chosen 0.25, our time component would be 6 a.m. Or if we had chosen 0.75, our time component would have been 6 p.m., or 75% of the way through the day. and so on. Now likewise, if I go down here and format April 17th, 2021 at 12 noon as a number with a decimal component, and click OK, we see that instead of 44,303, we get 44,303.5. Now it's important to understand that all dates in Excel are understood to have a time component, not just dates that we explicitly enter with a time component or decimal numbers that we subsequently format as dates. It's just that this time component is understood by default to be midnight, i.e. 0 minutes after the date. So if you format any plain old date value to include a time component, like our date value right down here in cell B13, so if I just format that as custom, and again our only date time format that's built in, you'll see a time component consisting of essentially a string of zeros. Basically, Excel understands the value we entered to represent midnight on that particular date unless we tell it otherwise by explicitly adding a time component. Hopefully at this point, Excel's perspectives on dates and times is clear. Okay, with that understanding in mind, it's time to look at some examples of date formulas. First, let's try to add a number to a date. So down here in cell C3, I'll add 400 to March 13th, 2020. So I'll just type equals A3 plus B3 and then enter. And we get April 17th, 2021, which, as you might have guessed, is exactly 400 days past March 13th, 2020. Just understand that behind the scenes, Excel is converting March 13th, 2020 to its equivalent number, then adding 400 to that number, then formatting the result as a date. And if, for example, I had added 400.25 instead, you can see that instead of our exact date and time being April 17th, 2021 at midnight, it's now April 17th, 2021 at 6 a.m., or 25% of the way through the day. Next, we can try reversing this calculation by subtracting 400 from April 17th. So I'll just do equals our date minus our number. And just like we'd expect, we get March 13th, 2020. As long as you understand how date math works in Excel, calculations like these actually become pretty predictable and routine. Now you can also perform calculations between two date values instead of a date and a number like we've been doing here, although some of these make more sense than others. For example, down in cell C13, we can try adding two dates together. So I'll try equals, and then our first date plus our second date. But what we get is a date ludicrously far into the future. Again, Excel is simply taking the number of days past midnight at January 1st, 1900 that each date represents, adding those numbers up, and then formatting the result as a date. So while adding dates like this is technically possible, it usually doesn't yield outputs that make a lot of sense. Now by contrast, subtracting one date from another can be an extremely useful application of formulas in Excel. If you want to quickly ascertain the number of calendar days between the two dates, you can simply subtract the older of the two dates from the newer, i.e. the smaller number from the larger number. So we can try this by subtracting March 13th, 2020 from April 17th, 2021. So I'll just say my newer or larger date minus my older or smaller date. And I get 400 just like we would expect. Now you could also subtract the newer date from the older date, but I'm sure you understand what's going on well enough at this point to know that you would, in effect, be subtracting a larger number from a smaller number, meaning our result would be a negative number. So just for grins, I'll try that. So 3/13/2020, and then 4/17/2021 as our second input, and now we get a result of negative 400, which doesn't make a lot of sense in terms of date and times, unless you're in the Marvel Cinematic Universe, I guess. Okay, so now we've looked at how to apply formulas to the three fundamental data types in Excel. And while these are in fact extremely useful techniques, we've really only applied these formulas to a small handful of inputs at a time. In the real world, we often want to apply calculations like these not just to a couple of inputs, but to long columns of data consisting of hundreds or even thousands of inputs that we would like to perform the same type of calculation on. Now, obviously, we can't feasibly be expected to write formulas individually against input in thousands of different cells. Fortunately, replicating formulas across different cells is actually a snap in Excel. We'll look at how to do that in the next video. I'll see you then. Hey, welcome back. So knowing how to manipulate data with formulas is great, but if we can only write these formulas one cell at a time, we're going to have a tough time keeping up with the demands of real-world data. So far, we've been working with a few input cells at a time, but a much more common scenario is that we'll have hundreds or thousands of rows of data in which certain values from each row form the inputs to our formulas. Unless you're a fast enough typist that you think it's a good idea to type out a formula for every row of a large data set, we'll need to come up with a better way of replicating our formulas. Fortunately, Excel actually allows us to copy and paste formulas in the same way that it allows us to copy and paste numbers, text, or dates. However, there are a few additional guidelines we'll need to keep in mind when copying formulas. Let's take a look at some examples so this can all sink in. Back in our familiar shave ice tracker, you'll see we added a column called Number of Flavors, and that we've removed the data from our sale amount column. With our Number of Flavors column, we now have all the inputs in front of us to calculate the sale amount ourselves. Doing so, as you might imagine, will involve a formula. First, let's take a crack at writing that formula for our first row of data. So the way our pricing system works is that each cup of shave ice costs $3 by default, and then we charge 99 cents for each additional flavor. Finally, we multiply the cost of an individual shave ice treat by the total quantity that we see in column D. So if we were to write that formula out using the techniques we learned in the last video, we'll do an equal sign and then an open parenthesis because we want to first calculate the number of flavors times the amount we're charging per flavor, and then we want to add that to our fixed price of $3 for each cup of shave ice, and then we'll wrap all of this in parentheses so we can multiply it by the quantity, the number of these that the customer ordered. So then if we hit enter, we get our sale amount. And actually, just to keep the proceedings a little bit clearer, I'm going to remove that strike-through effect that I had originally added to this row. So I'll just format, font, remove the strike-through. All right. So this formula works just fine. The problem is we have about 100 more rows of data that we need to perform this exact same calculation on, except the inputs are going to change from row to row. Now we could try typing this exact same formula out in our third row of data, but that honestly doesn't seem like a very good use of our time. Aside from which, typing errors being as common as they are, most likely at some point we'd end up mistyping a formula and incorrectly calculating a sale amount. So what's a better way? This is where copying and pasting comes in. So without further ado, let's select our cell K2 that contains our formula, hit Control-C to copy, and then select cell K3, and then Control-V to paste. So the number we see looks plausible, but let's inspect the actual formula in the cell to see what was copied. And we see that instead of copying the exact text of our previous formula, Excel actually changed the formula such that all of our references still line up to the current row. You see that instead of referencing cells D2 for the quantity of the order and J2 for the number of flavors, we're now referencing cells D3 and J3. Now this happens to be exactly what we wanted. So did Excel read our mind or what? Nope. This is actually just Excel's default behavior when we copy formulas. Unless we specify otherwise, something we'll get to in another video, formulas use what are called relative references. This means that when we reference a cell in a formula, the cell reference is understood by Excel to be relative to the cell that contains the formula in terms of position. So if I write a formula that references a cell immediately to the left of that formula, like our formula in cell K3 does, and then copy that formula to another cell, like say for example K5, the copy of the formula will now reference the cell immediately to its left, in this case cell J5, not to the left of the cell that we copied. Excel does this because the most common scenario when copying formulas is not that we want to keep referencing the cells that the original formula did, but rather that we want to reference inputs in other rows of our data that are aligned with our new copied formula. So copying formulas one at a time like this is certainly better than typing them out individually, but it could get somewhat painstaking if we have to repeat the process over too many rows. Fortunately, we can actually copy a single formula over a whole range of cells in one fell swoop. So if I copy our cell K2 with Control-C, and then select all of the cells in our data in column K by scrolling down, finding the last cell, and then holding down our Shift key, and then clicking, and then finally hit Control-V to paste, it looks like all of our formulas were copied down. If we go down to the very last cell of our data in that column using the Control down arrow shortcut, it looks like all the cell references in that formula line up with that particular cell. And then just arrowing up through a few other cells, it looks like our formula was copied down fine. So this worked great, but there's actually an even faster way to copy formulas as long as our data is set up in the tabular fashion that we see here, and we're trying to copy a formula down a column that is adjacent to other columns of data. This method uses our old friend Autofill, the same technique we used to create series of numbers and dates earlier in the course. To see this in action, let's first wipe out all the formulas in our column except for the very first one. So I'll just scroll back up to the cell right below our first formula, and then Control, Shift, down arrow to select the rest of the cells, and then just delete, and then Control up arrow to go back to the top of the column. Now we'll select our formula cell, K2, and then hover over the bottom right-hand corner of the cell until we see that fill handle, and then finally we'll just double-click the fill handle. Wow! So with 2 clicks of our mouse button, our formula has been replicated down an entire column of data. And this works just as well whether we have 100 rows of data or 10,000. A real time saver by any measure. Now, one thing worth noting about depending on formulas to calculate values in your data. They are only as good or reliable as the inputs they perform calculations on. So if, for example, we were to delete data from one of the columns that our formula references, so maybe somehow by accident I just deleted all of these values from our num flavors column, our formulas no longer produce the correct result. And I'll just Control-Z to back us out of trouble here. Now, in some cases, this may be what you want, but in others, you may simply want to store the number once it has been calculated and don't want to risk losing it if any of the inputs are compromised. So if you want to, as we say in the industry, lock your formulas down so that the results remain static, regardless of whether the inputs change or not, the solution is to turn your formulas into raw data, that is to say, values. To do this, we would simply copy the cells containing our formulas, and in this case, we could just copy all of column K. So we can select that column and hit Control-C. Now then, instead of just hitting Control-V to paste, we'll actually right-click so we can go to the Paste Special menu. So we'll click Paste Special, and this brings up a dialog box that gives us a lot of options for pasting data beyond just the defaults that Excel gives us. Now what we'll want to choose here is values. If we choose that and click OK, and then just click into our first cell that contained a formula, we'll see that the formula isn't there anymore. All that's left is the value. So this paste special as values command basically took the output of our formula and pasted it back into the cell as raw data, so that no matter whether our inputs change or not, the value will remain what it is. Now sometimes you'll want to use this technique and sometimes not. It really depends on whether you want to prioritize holding on to the data in its current state, in which case you may want to opt to paste the formulas as values, or whether you think the inputs may continue to change, in which case you may want to see how the value returned by the formulas changes in turn. Alright, one more note before we go. We've been doing a lot of copying and pasting here, but we haven't talked about the cut operation, which as you recall we access with the Control+X keyboard shortcut. So how does the cut command come into play when it comes to formulas? Well, the difference between cutting a formula and copying it is that cutting does not assume we want to keep our cell references relative. Instead, it uses absolute references, simply replicating the exact formula into whatever cell we move it to. In that sense, cutting actually comes closer to actually copying the formula than the copy command. So as an example, we'll cut one of our formulas, but first we need to use Control-Z again to undo our paste special values command. And now we'll go down to the end of our data with the Control down arrow shortcut. And what I'll do is cut our formula from cell K101 to cell K102 and see what happens. So I'll use the Control-X command, and then I'll select K102 and hit Control-V. So now we see that not only was the formula removed entirely from cell K101, which is part of what the cut command does, but also that the formula in K102 is still pointing to input cells from row 101. Now if we had copied the formula on the other hand, our copy of the formula would now be pointing to cells in the formula's current row, row 102. Now in my experience, cutting formulas is generally less useful than copying, since the most common use case for cutting or copying formulas is to apply them across multiple rows of data like we did here. But they're both good techniques to have in your toolbox. So as we've seen, Excel uses relative references by default when we copy formulas. But as I briefly alluded to, we can actually control this behavior and force Excel to use either relative references, absolute references, or even a combination of the two, as our requirements dictate. This ability can be indispensable in a variety of use cases. We'll explore a couple of these in the next video. I'll see you then. Hey, welcome back. We saw in the last video that when we copy formulas, Excel updates any cell references in those formulas to change relative to the destination cell we're copying to, by default. A majority of the time, this will be what we want, which is why Excel does this by default in the first place. But in some cases, we may want our formula copy to retain all, or at least some, of the original cell reference. Fortunately, Excel gives us a fairly straightforward mechanism for overriding its default behavior when it comes to copying formulas. To get a better handle on this, let's look at an example in which we'll need the cell references in our copied formulas, or at least part of the references, to remain absolute, that is to say, identical to the formula from the cell we're copying. So here in our example spreadsheet, we have an outline of a basic investment calculator, which accepts an input of an initial principal amount in cell B1, and then calculates the appreciation of that principal by year in column E, based on the rate of return in cell E1. Our job will be to write formulas to calculate how our money grows based on this rate of return in the blank cells in column E. So let's get started. So in the very first cell, I'll multiply the rate of return by the initial principal. So I'll type equals, and then our rate of return times our initial principal. And then just to make sure this calculation is performed first before anything else, I'll wrap it in parentheses. And then to this amount, which is basically the amount our investment appreciated in a year, we'll add our initial principal amount. And then hit enter. So far, so good. Next, in cell E3, I'll want to reference the amount in cell E2, the output of the formula we just wrote, just like I referenced the initial principal amount in our first formula. As of year 2, our new initial principal, so to speak, is the end of year value for year 1, which is reflected here in cell E2. So just like before, I'll multiply our new initial principal, which is in cell E2, by the rate of return in cell E1. And then I'll wrap that calculation in parentheses. And then finally, I'll add in our new initial principal from cell E2. And then hit enter. And it looks like our formula is working so far. So now let's try copying the formula all the way down through year 15 so we can see how quickly our investment grows. So I'll hover over the bottom right-hand corner of cell E3 until our trusty fill handle appears, and then double-click to copy the formula all the way down. Whoa! It looks like something went horribly, horribly wrong. Let's dig through what we see in our formulas to diagnose the problem so we can try to clean this mess up. So starting in cell E4, our year 3 investment amount, it looks like we're correctly referencing our principal amount from year 2. As you can see, we're adding E3 and we're multiplying our value from cell E3 by our rate of return. But instead of multiplying our principal by the rate of return in cell E1, we're actually multiplying it by the year 1 principal amount in cell E2. So we're basically multiplying about $100,000 by $100,000. No wonder our numbers are so enormous. What we actually need is for our formula to keep pointing to the value in cell E1 even as we copy the formula down. So how can we do this? Well, first let's escape to get out of our formula and then hit Control-Z to back our way out of trouble. And now we can look into how to fix our formula. So it turns out that we can actually signal to Excel that we want part of a cell reference to remain absolute. That is to say, it won't change if we copy the formula around, by putting a $ in front of that particular part of the cell reference. So if we put a $ in front of the 1 in our reference to cell E1, which I'll do right now, and then hit enter to lock the formula in. So if I hit Control-C to copy our formula now, and then Control-V to paste it one cell down, we see that the row part of our cell reference hasn't changed. It's still referencing row 1 when we reference cell E1. Meanwhile, the row component of our other two cell references has changed. However, since we didn't put a $ in front of the E, just the number 1, if we copy the formula into a different column, so I'll hit Control-C and copy over to the next column over, you'll see that the column piece of the cell reference changed, since that wasn't locked down. So now let's go ahead and lock down the column piece of our cell reference as well. So up here in cell E3, I'll just put a $ in front of the E so that now our reference to cell E1 is fully locked down. And now I can fill down our new and improved formula through year 15 by hovering over the bottom right corner of the cell until I see the fill handle, and then clicking, holding down my mouse button, and just dragging down, and it looks like it worked. Awesome. So now let's say we want to convert our little investment calculator to a full-blown investment matrix by adding more different rates of return across the top row. So up here in row 1, I'll add more rates of return starting from our 1% and ranging all the way up to 10%. So I'll just type 2% here and then highlight these two cells, and then using Excel's fill series function, I'll just fill across until I get 10%. And then I'll click cell E1 and double click the format painter so I can paint that format all the way across. And then click the format painter one more time to turn it off. And now I can try copying my formulas from column E all the way across through column N. So to do this, I'll just highlight cells E2 through E16. Then again, hover over the bottom right-hand corner of that range until I see our good old fill handle. And then click and hold down my mouse button and then just drag across until I'm at column N, and then let go. Yikes! Once again, something seems to have gone very awry. So what did I do wrong this time? Well, if you recall, we actually have two different formulas in each of our columns. One in the first row of the matrix, which references the initial principal amount in cell B1, and then the other one that we copied down through the rest of the years, which references the previous year as it is copied down. Let's start by looking at our formulas in the first row to see what issues we can find. So right away, we can see one major problem. Our first row needs to reference the principal amount in cell B1, regardless of where we copy the formula. But because we didn't lock down that reference to cell B1 before we copied the formula, Excel, cheerfully trying to give us a hand by using relative cell references, keeps moving the cell referenced by the formula to the right as we copy the formula to the right. So our first step, obviously, is to lock down that reference to cell B1 in the formulas in the first row of our matrix. So let's put dollar signs before the B and the 1 in our formula in cell E2. So I'll put those dollar signs in there. And then hit enter. And then I'll try filling that formula across the first row of our matrix. And now finally I'll highlight these columns and then double click between two of the column headers to autofit. And that appears to have worked. At least kind of. So if we look at our investment appreciation at the higher rates of return, they don't seem to be very different than those at a lower rate of return. I'm no financial advisor, but I would expect a 10% rate of return over 15 years to make me a lot more money than a 1% rate of return. Clearly, something is still amiss. So let's take a look at the formulas we copied in the other rows of our matrix below the first row. Now we see the issue. As we arrow across the formulas in the different columns, we see that our formulas are all still referencing the rate of return in cell E1, 1%. So the only difference between what we're seeing in column E and what we're seeing in column N is that we start with a slightly higher principal amount in column N. This happened because we locked down our reference to cell E1 entirely, making it completely absolute. So when we copied that formula around, that reference could never change. What we actually need is for the row piece of the cell address to remain fixed, while the column reference changes as we copy the formulas across. So now we can capture the rate of return for the given column that we're copying the formula to. So how do we do that? The answer is simply to remove the dollar sign from in front of the E in our cell reference. This will allow the column piece of our cell reference to remain relative, while the row reference remains absolute, since we'll still have a dollar sign in front of that one. But before we actually make this change, I want to show you a little shortcut that can make life easier when you're playing around with mixed cell references like this. So it turns out that mixing relative and absolute cell references is so common that Excel actually created a keyboard shortcut to let us cycle through the various permutations of absolute and relative references pertaining to the two parts of a cell address, the column and the row. So if we go into our formula in the second row of our matrix in cell E3, and then highlight the reference that we want to change, the reference to cell E1, and finally hit the F4 key, you'll see that the reference changes, such that the column is now relative while the row reference is still absolute. Now this is actually what we want, but just to demonstrate how this works, I'll hit F4 again, and now the situation is reversed. We have an absolute column reference and a relative row reference. And then if I hit F4 one more time, Now both pieces of our cell reference are relative. And then if I hit it again, we're back to a fully absolute reference. Using this shortcut, you can quickly cycle through all the reference types available to you until you see the one you want. Not a huge deal, but if you end up typing mixed cell references like this quite a lot, the time you'll save with this little shortcut can add up. Alright, I'll hit F4 one more time to get us back to the combination of relative column reference and absolute row reference that we want. And then I can hit enter to lock down our formula. And now I'll just fill down our new and improved formula through the rest of column E with our fill handle. And then again, using the same method as before, I'll fill our formulas across to the other columns of our data. Now that's more like it. Our 10% rate of return gets us from a $100,000 initial investment to just over $400,000 after 15 years. Now I just need to find somebody to give me $100,000 and then maybe something I can invest it in at a rate of return of 10%, and I'll be ready to retire to Fiji. All right. If this all made sense to you, congratulations are in order. You now have a solid foundation in writing formulas in Excel. And more than that, with what you've learned so far, you now have all the tools you need to be dangerous in Excel. But we still have so much more to learn. While we've learned how to create our own custom calculations with formulas, perhaps the biggest power Excel gives us is its own library of built-in formulas, which can do all sorts of cool and complex operations that we could only dream of cobbling together ourselves. These built-in formulas, which are called functions, are the heart of Microsoft Excel, and we'll start our journey down the function rabbit hole in the next video. I'll see you then. Hey, welcome back. As a very brief aside, I want to make you aware of something you can do in an Excel spreadsheet that I generally recommend against, just because you'll probably encounter cases where other people have done this thing. And that is hiding rows and columns. So it turns out that if you no longer want to see, just for example, a column in your data set, but you don't want to get rid of it permanently, you can hide it so that it's not visible to anyone viewing the spreadsheet, but is still there so that if you want to see it again in the future, you can just unhide it. For example, let's say I'm no longer interested in our sale amount column here in column K, but I'm not sure that I'll never want to see it again, so instead of deleting it, I want to hide it. To do that, all I would have to do is just select the entire column by clicking the column header, and then right-click and choose Hide. And the column disappears. The only real evidence that the column is there at all is that this sequence of column headers has a gap in it. We go from column J to column L. Now this may seem like a potentially convenient thing to do, but there's a real problem here. And that is that just hiding a column or row doesn't protect the data in that column. So if, for example, another user of the spreadsheet were to come along and say want to just delete all the data in columns J and L here, and they select columns J and L, and then hit the delete key. Now what do you think happened to the data in our hidden column? Was it protected or not? Well, let's find out. So to unhide the column, we just select the two columns that surround our hidden column, right-click and choose Unhide. And there's our hidden column, and all of the data is now gone. I mean for all of this to underscore my broader point that hiding data in rows and columns probably isn't a great idea, generally speaking. If you have data that you don't want to see, but you also don't want that data to potentially be deleted, I would recommend putting that data on an entirely different worksheet and then hiding the worksheet. Or if it's data you're just not interested in anymore, go ahead and delete it. So if I don't recommend hiding rows and columns, why am I even explaining this technique at all? I do this because while it's not necessarily a great idea most of the time, it's also a very common practice. So the next time you see a gap in the sequence of column headers or rows in your spreadsheet, you'll know to be careful not to delete the data around it so as to avoid the scenario we saw here. All right. With all that said, we'll get back to our regularly scheduled Excel work. I'll see you next time. Welcome back. So our ultimate goal for the course project is to create a fully featured budget in Excel that will also allow us to analyze our spending habits. But for now, we'll start simple. All I want you to do is create a template similar to the one you see here with inputs for monthly income and expenses, and then a third cell containing our cash balance in which you'll use a formula to subtract expenses from income, leaving our remaining cash balance. Now, you don't have to format your solution exactly like I did mine, but I would still recommend clear headings for each input and to offset the formatting of the calculation in some way just to clearly distinguish it as an output of our extremely simple model as opposed to an input. For my formatting choices, I either tried a bunch of options until I found one I liked, as was the case with my choice of font, Century Gothic, or relied on Microsoft's built-in cell styles and theme colors. For example, I used the built-in header styles for the labels of each cell and used built-in theme colors for the fonts. These kinds of tools are great for design-challenged people like me, but if you're aesthetically inclined, please feel free to make this design your own. Alright, with that said, now I want you to pause the video and take however much time you need to put this together. Then once you're ready, unpause the video and I'll walk you through my solution. See you on the other side. Okay, so hopefully that went well. So for my solution, I'll first go to a new workbook, and then I'll go down to cell B3 and type in my first heading, which will be total monthly income. And then my second heading down in B5 will be total monthly expenses. And then my third heading will be cash balance. Now my value for total monthly income will be $7,606. And then my value for total monthly expenses will be $5,668. And at this point, I'll go ahead and auto-fit column B just so we can see our entire labels for our input values. Next, I'll apply some formatting to our labels. So I'll select all three of the cells that have our labels, and then go over to Cell Styles in the Styles section of the Home tab, and I'll choose the Heading 1 style. Now obviously this increases the size of the font, so I'll need to auto-fit the width of column B again. And then to offset our cash balance heading from the other two, because cash balance will represent the output of our model here, I'll change the font color of the cash balance cell to orange. And I'll use the variation of orange that is one of the theme colors for Excel. So now it's time to actually write the formula that will calculate our cash balance. So here in cell C7, I'll type equals C3 minus C5, and then enter. And so now we see we have a cash balance of $1,938. Next, I'll go ahead and format these three numbers all as currency. And I'll also change the font to Century Gothic with a size of 14. Now I'll make column A just a little bit narrower, just so we have a little bit of a buffer between our budget and kind of the boundary of the Excel grid. So now that we've got our inputs, outputs, and calculations down, we can go ahead and create a hopefully aesthetically pleasing header row. So to do that, I'll widen out row 1 just a bit. And then with that entire row selected, I'll choose a cell style of accent 1. And then in cell A1, I'll type budget and expense summary. Then I'll change the font size of that cell to 20. And I'll merge cells A1 through E1. And then left align. And maybe I'll make that row just a little bit shorter. Now finally, it's worth noting that Excel tools, like the one we're building here, can often be made cleaner looking and more visually appealing if we remove grid lines from the spreadsheet. That is, those visual boundaries of all the cells in the spreadsheet. So to do that, we'll go to our View tab of the ribbon and then simply uncheck grid lines. And now our spreadsheet looks a little bit less like a spreadsheet and more like a professional budget and expense report. And as one last housekeeping item, I'll go ahead and bold the amount of our cash balance, again, just to offset that as an output of our spreadsheet as opposed to an input that we have to type in. Now, if your solution doesn't look exactly like what you see here, hopefully it looks better, no big deal. The main idea is that you get the general idea of how to apply these formatting techniques, from merging cells to using Excel's built-in styles to number formatting and font formatting and so forth. And obviously also using formulas for basic calculations. Okay, so up next we'll get back to learning new things in Excel. But never fear, this is not the last you'll see of our little budget spreadsheet. In fact, we've just barely gotten started. Welcome back. So there are exercises throughout this course that will help you practice the skills you're learning as you learn them. But in addition to practicing your skills with each new feature in isolation, I also want to give you the opportunity to combine those skills in a single overarching project that will enhance progressively throughout the rest of the course. So what we'll be building is a budget and expense tracker spreadsheet that lets you compare your income and expenses, plan your spending habits accordingly, determine what percentage of your income you'd like to save, analyze your spending habits, and more. This project will incorporate formulas and functions to calculate our monthly budget, charts and conditional formatting to give us intuitive visual insight into our budget and expense data, Excel's modeling tools to calculate what we need to save every month to achieve a particular savings goal by a particular date, pivot tables to let us dig deeper into our spending habits, macros to automate the process of cleaning up messy data, and more. Now, this may all seem like a lot of work, but we're going to build it out one step at a time, layering in features as we learn about them throughout the course. I think you're going to have a lot of fun building this out, and on top of that, at the end of the process, you'll have built something you can actually use in real life. But you'll also have the foundation of Excel skills you need to customize your budget and expense tracker, or any other spreadsheet you come across really, in any way you see fit. So enough talking from me. In the next video, we'll dive into the first phase of this project. I'll see you then. Welcome back. In this video, we're going to take our first step past the basics of Excel and into the nearly endless landscape of Excel functions, which are basically pre-built formulas in which Excel does the calculations and heavy lifting behind the scenes. Now, we've already seen that we can do plenty with formulas, so what do we really need functions for? Pretty much everything we haven't already tried to do, which is a lot. Functions are where Excel really starts to flex its muscle as one of the most powerful applications ever built. Excel has literally hundreds of functions, nearly all of which can be customized based on user input. These functions can perform operations on our data ranging from trigonometry and advanced statistics to financial calculations, complex date math or text manipulation, and so on and so on. Trust me, the list goes on longer than the introduction of a Star Wars movie. The key thing to remember with functions is that we don't need to understand the exact particulars of how the function gets to its result. We simply supply the function with inputs, these are called arguments, and behind the scenes, Excel takes the information we provided the function and uses it as input to whatever calculation the function performs. We don't need to know exactly how to calculate, just for example, the standard deviation of a range of numbers in order to apply that function in Excel. We simply feed the standard deviation function a bunch of data and Excel spits out the result. And with hundreds of built-in functions available, we can perform just about any operation on data you could possibly imagine in Excel. But as usual, we're going to start with the basics. It doesn't get much more basic than simply adding numbers, so we'll first take a look at Excel's sum function. Here we have a series of input numbers in row 2 of our example spreadsheet, and then a couple of cells in which we'll attempt to add these numbers, first with a formula, and then with Excel's sum function. First, let's have a go with the tried and true method, simply adding the inputs together with plus signs. So right here in cell E2, I'll type equals, and then A1 plus B1 plus C1 plus D1, and then hit enter, and that works well enough. But we still had to think about the particulars of how addition between all the numbers worked. We had to put plus signs in between each number, effectively telling Excel how to do what we're asking it to do. With functions, instead of telling Excel how to do its job, the general idea is more to tell it what we want, and Excel figures out exactly how to get there. To see this in action, in cell F2, let's type an equal sign. Now keep in mind, a function is just a type of formula, and then the letter S. Now that's interesting. Excel auto-populates a list of names with this funny little symbol before them, all of which begin with the letter S. Remember how I told you that Excel has a really large amount of built-in functions? Well, this list should give you some perspective on that. When you start typing a formula with the equal sign, and then type a letter that one of Excel's built-in functions begins with, Excel helpfully populates a list of all the functions that begin with that letter. Hence the funny little function symbol before each name here. As you can see, there is quite a long list that begins with just the letter S. Even better, if I continue typing out the name of our function by hitting the letter U, now our list is narrowed to just those functions that begin with SU. And 3 function names down, I see the name of our function, sum. Now at this point, of course, I could just finish typing out the name of our function since it's fairly short, but I want to show you how this feature of Excel, which is called autocomplete, can help us, especially in cases where the function name is quite long or we may not know exactly how to spell it. So using the arrow keys on the keyboard, I can navigate down the list until the function I'm looking for, sum in this case, is highlighted. Then, if I want to select that function such that it populates in the formula bar, I can just hit the tab key. And now we see that the function name is already populated in our cell with an open parenthesis already entered. And there's something else as well. Below the actual text of the formula, Excel is listing out the arguments or inputs that we can supply to the function. We see that there is a number 1 input we can pass in, and then a number 2 input as well, which is enclosed in brackets. These brackets indicate that this particular input is optional, which means that in this case, we need to supply the function with at least 1 input, but we can optionally supply more. So without further ado, let's take a crack at adding our inputs with the sum function. I'll supply the first argument to the function by clicking cell A2. Then, to separate that argument from the next, and keep in mind arguments passed to functions are always separated by commas, I'll type a comma. Then I'll click B2 for our second argument, then another comma. And if you look at the suggested arguments that Excel is now listing below the cell we're typing our formula in, you'll see that the number of optional arguments has expanded. Basically, as long as we continue to supply more inputs, more of these optional arguments will become available to us. Basically, we can keep adding as many different numbers as we want. So now I'll continue the pattern until we have all 4 of our inputs in the function. So again, C2, then a comma, then D2, and then finally we'll type a closing parenthesis, and we'll see this over and over as we work with functions, but all functions in Excel must have parentheses after them whether or not we actually supply arguments to them. You'll get used to that format as we go, but just keep that in mind that even as we encounter certain functions which we'll see in upcoming videos which don't take any arguments at all, you still have to have those opening and closing parentheses after the name of the function. So now I'll hit enter, and we see that we got the same results as before. Now while this did work, you might be wondering what the real advantage was versus simply performing our addition operation with a simple formula using plus signs like we did before. We effectively just swapped our plus signs for commas and didn't really save any typing relative to our previous approach. It's true that the sum function is somewhat cumbersome as long as we're supplying inputs individually like we've seen so far. But where sum really shines is when we apply it across a range of cells, as opposed to individual cells like we see here. So let me go ahead and delete our function, and then we'll access it again through the autocomplete list. So I'll just again type equals S, U, and then arrow down a couple times, and then hit tab to select that function. And now, instead of selecting our inputs individually, we'll click cell A2 to select it, and then holding down the mouse button, I'll drag across through cell D2 to select the range of cells from A2 to D2. And now if you look at what we've passed into our sum function, instead of a single cell reference or a series of cell references separated by commas, there is this strange pattern in which the first and last cells of our selected range are separated by a colon. It turns out that certain functions in Excel accept not just individual cells as arguments, but also ranges of cells. And the way to signify a range to an Excel formula is to have the top left cell in that range, then a colon, then the bottom right cell in that range. In this case, our range is contained entirely within one row, so there is really no top or bottom per se, just a left and right. Hence why A2 is considered the first cell in our range, while D2 is the last. Now, instead of actually typing a closing parenthesis, I'm just going to hit enter. You may be thinking that I'm asking for an angry error message, but bear with me. Wait, it looks like it worked. So it turns out that Excel is smart enough to automatically populate the closing parenthesis for us. As long as we're typing a formula and we've supplied everything it needs other than the closing parenthesis, we can just hit enter when we're done constructing the formula, and Excel will take care of the rest. Now, as handy as this syntax for applying the sum function to a range of cells was relative to just entering a handful of individual cells as inputs, imagine if we needed to sum a range consisting of 100 cells or 1,000 cells. You definitely wouldn't want to try to add those cells individually with plus signs or pass them individually as arguments to a sum function separated by commas. So the more cells are in the range that you're trying to sum, the handier this particular syntax is. All right, I hope that you've seen enough already to recognize that we've just barely scratched the surface of the potential that Excel's functions can offer us. Summing a range of numbers is probably the most basic thing we'll try to accomplish with a function. But this doesn't mean that the other functions we'll work with are harder to use. It just means that the logic going on behind the scenes is more complicated. That's really the beauty of functions. They make calculations and operations that would be difficult or even impossible for us to crunch out ourselves relatively straightforward to implement as long as we know what we're trying to do. Now that we have sum under our belts, we'll take a look at a few other basic arithmetic functions in the next video. I'll see you then. Welcome back. Now that we've learned how to add numbers with the sum function, let's take a look at some other functions Excel gives us for crunching numbers. So I've created another tab on our Shave Ice tracker that will let us track some summary statistics on our Shave Ice sales performance. As you can see, we'll be playing a game of fill in the blanks, so to speak, by computing these various metrics with a little help from Excel functions. First up is total sales in terms of dollar amounts. This one should be easy peasy, since calculating total sales is really just a matter of adding or summing the individual sales amounts. And we already know how to sum, right? So let's go ahead and employ our sum function in cell B1. Now keep in mind that we're trying to sum all the numerical values in column J of the Sales Tracker tab. Now we could simply select all the cells in column J that have sales amounts in them, which would amount to the range from cell J2 all the way down to cell J101. But the problem with that approach is that as we add new entries to our tracker, we would have to continue to change our formula reference to keep up with the new data. Now that doesn't sound very fun or sustainable. A better approach then is to apply the function across the entire column, column J. So how would that look? Well, let's find out by first typing in our sum function in cell B1. So I'll just type equals S U, arrow down to select our function, tab to lock it in the formula bar, and then we'll navigate over to our sales tracker worksheet. Now before we go on, take note of how Excel has automatically inserted the name of the sales tracker worksheet, wrapped in single quotes and followed by an exclamation mark, inside of our function. Since we're referencing a cell on a different worksheet than the one that our formula lives on, Excel needs to precede any cell references in the formula with the worksheet name. Otherwise, by default, Excel would assume that we're referring to column J on the same worksheet as our formula, which obviously isn't what we want. But since Excel has taken care of that piece for us, let's go ahead and select column J the same way we would in any other circumstance, by simply clicking the column header. And now, looking at the reference generated in the formula, we see that it's similar to when we referenced a range of cells, but instead of a first cell and a last cell separated by a colon, we instead just have the column letter, a colon, and then the column letter again. This is actually how Excel understands a reference to an entire column. And if we wanted to reference multiple columns at a time, say columns J through M, we would just type J, colon, and then M. So for example, instead of selecting column J, if I wanted to just click column J and then hold down my mouse button and then scroll to the right, suddenly our reference changes to J, colon, M. Likewise, if we wanted to select all of row 2, we would simply click that row header, and now we see that our reference changes to 2, colon, 2. But back to our problem at hand, let's go back and select all of column J again, and then hit enter to see what we get. And it looks like our formula worked. But at this point, the eagle-eyed among you might be wondering, since our sum function operated over the entire column, how the heck did it handle adding the name of our column header in row 1 to all the numerical values? So if we go back to our sales tracker tab, you'll see that our cell J1 here doesn't have a number, it has a text value, sale amount. Now, as you might imagine, if we tried to add the words sale amount to the number 1995 using a plus sign, our formula would error out. Well, this is actually a great example of the value of built-in functions versus the formulas that we kind of crunch out by hand. Excel's sum function is smart enough to simply ignore any non-numeric values in the input range, meaning we have the luxury of applying it to entire columns that may include column headers or other types of non-numeric data. Okay, up next, let's try to compute the average sales amount. Hopefully Excel has a built-in function to help us here too. So let's go back to our summary metrics worksheet, and you'll see we already have a slot ready for our average sales function. Now, full disclosure, if we simply typed in an equal sign in this cell and then the letters AV, Excel would helpfully suggest the average function right away. But the function names we're looking for won't always be so intuitive, so I want to show you a more systematic way of finding a function to accomplish a task, when you're not sure what that function is called or if it even exists. So on the Excel ribbon, select the Formulas tab. Whenever we're dealing with formulas or functions, this is going to be the tab that has all the tools you need. Next, on the left side of this tab, let's take a look at the different options available to us in the Function Library section. So Excel has a series of drop-down menus that list out functions in various categories. You can see if we click the down arrow under Financial, a long list of financial functions, and then another list of functions under the logical category, and text, and date and time, and so on and so forth. These lists can be useful, but the categories aren't always the most intuitive. For example, you might think that the average function, assuming there is one, would fit under the Math and Trig category. But if we look there, we go right past all the function names that begin with the letter A and don't see any average function. A better way to look for functions, in my experience, is the Insert Function dialog box, which we can access by clicking this FX symbol all the way over to the left side of the Formulas tab. Now this brings up a dialog box that lets us simply issue a Google-style search for whatever it is that we're trying to accomplish. Now you can also list out functions by category using the Select a Function drop-down list, but this is pretty much just a variation of the drop-down lists we already looked at on the Formula tab. So let's type average in the Search for a Function text box, and then click Go. So up here in our Search for a Function text box, I'll hit Control-A to select all the text, and then Delete to delete it, and then I'll just type average, and then click Go. And now we see a list of recommended functions pop up. And if we arrow down through the list, we'll see that a description of the function, along with a list of the arguments it takes, appears below the function list. Our very first option here, the average function, actually looks like just the ticket. So at this point, we're probably ready to go ahead and insert the function, but first I'd like to show you one more trick that will help you as you're exploring the vast library of functions in Excel. So with the average function selected in the function list, we can click on the Help on this function link in the bottom left corner of the dialog box. And this brings up Microsoft's documentation on this particular function, which will have all sorts of useful information that can help us understand when and how to apply the function. You see that they give a description, they describe the syntax, and they have a variety of remarks that just give you more context about the function and how you'd use it. So the great thing about the Insert Function dialog box and the documentation that it links out to is that they are both amazing tools for teaching us how to fish, so to speak. If I tried to break down every single function in the Excel library in this course, there would be flying cars by the time you finished it. Excel has such a vast library of functions that it's absolutely essential for you to know how to research functions on your own and learn about their usage through the documentation. This is a crucial step towards making the leap from Excel beginner to Excel power user. If you get comfortable with these tools, over time, you'll acquire a greater and greater knowledge and understanding of the Excel function library, and eventually get to the point where maybe you don't rely on these tools quite as much. But in the meantime, I highly recommend that you make heavy use of them as you're getting up to speed. Alright, with all that said, with the average function selected here, let's go ahead and click OK to insert the function into our selected cell. And now we're presented with another dialog box in which we can actually enter the arguments for the function directly without having to mess with the formula bar. Again, this is something that you might not use a lot once you become really comfortable with formulas and functions, but for beginners this is an absolutely invaluable tool. So for our first argument, we're not going to enter a single number or cell reference, but rather a range of cells, much like we did previously with the sum function. But how would I go about selecting a range with this dialog box? So all we actually have to do is click this little arrow icon to the right of the input box. And now Excel will allow me to click around the spreadsheet and select whatever range I want. So I'll navigate back over to the Sales Tracker tab, and then again, simply click the header for column J to select the entire column. And our dialog box is actually in the way of our column headers, so I can just click the title bar of the dialog box, hold my mouse button, and then drag it out of the way. So after doing that, I'll select the header of column J to select that entire column. And then finally, to go back to the Insert Function dialog box, I'll just click this down arrow to the right of the input box one more time. And now it looks like we have our argument entered properly, so we can go ahead and click OK. And we see that our average function has been inserted into cell B3 and is returning what looks like a very reasonable result. Awesome. Now let's follow a similar process to extract the biggest and smallest sales. So let's select cell B5, and then once again hit the Insert Function button on the ribbon. And now what I'm looking for is a function to return the largest number in a series of numbers. So let's type, for example, maximum in the search for a function text box and then click go. And right away we see that there's a function called max, and if we look at the description, it says returns the largest value in a set of values, ignores logical values in text, which sounds like what we want. So let's go ahead and click OK. And now we again need to select our range, which will again be column J on the Sales Tracker tab. So I'll just click our up arrow again, and then navigate to the Sales Tracker tab, select column J, then click the down arrow to go back to our function dialog box, and finally hit OK. And there we have our largest individual sale value. Now likewise, we can compute the smallest individual sale by first selecting cell B7, and then again clicking our Insert Function button. And now we'll search for minimum and click Go. And the first function that comes up doesn't look like what we want. It's called base and says it converts a number into a text representation with the given radix. This is probably a great example of just the sheer variety and breadth that exists in Excel functions. But for now, this doesn't look like the one we want. So let's arrow down once. And now we see a function called min, which says it returns the smallest number in a set of values. Again, just what we want. So I'll click OK to insert that function. And then again, click our up arrow so I can select an input range. And then I'll navigate to the Sales Tracker tab. And again, select column J. Click our down arrow to go back to the Insert Function dialog box. And then click OK. And there we have the value of our smallest individual sale. Awesome. We've now successfully computed a series of summary statistics on our Shavi sales data. But there's one more thing I want to point out before we go. The great thing about the formulas we've written here is that since they're pointing to entire columns, as we add more data to our Shavi's tracker, the formula outputs will update automatically. So if, for example, I were to add a ludicrously large sales amount below our existing entries in column J on the Sales Tracker tab, so if I go over here and let's just say somebody ordered, 1,000 Shavices and we ended up with a very large order amount. If we hit enter and then go back to our summary metrics tab, we'll see that our biggest sale is now 10,000. We'll see that our total sales have gone up substantially. Our average sales have gone up substantially, just as we might expect. All right, as you can see, we still have a few more metrics to calculate on our summary metrics tab. These metrics will involve a couple of wrinkles that we haven't encountered yet with our average, min, or max functions, so we'll give them their own video. That's up next. I'll see you then. Hey, welcome back. Thus far, the functions we've looked at only really make sense when applied to numbers. You can't add or take an average of a list of names, for example. But now we're going to take a look at counting functions, which can, but do not necessarily, apply to both numeric and non-numeric data types alike. This makes sense if you think about it. While it isn't meaningful to average a list of shave ice flavors, it might in fact be useful to take a count of how many we've listed. First up, we'll take a simple count of all of our sales, based on the values in column J of our Sales Tracker tab, the same column of data we worked with in the last video. So with our cell B9 selected, we'll click the Insert Function button, and then search for Count, and then click Go. And now we see a list of seemingly count-related functions pop up. But based on the description, the plain old count function looks like the one we need. It says it counts the number of cells in a range that contain numbers, and column J on the Sales Tracker worksheet contains the sales amounts of customer orders, which are numbers. So let's insert the count function by clicking OK. And then for our range, we'll go ahead and select on the Sales Tracker worksheet, column J, where our sales amounts live. And then I'll go back to our Insert Function dialog box and click OK. And our function returns 100, which if we look back to our Sales Tracker worksheet and scroll down to the bottom of our data, it looks like we have 101 rows, which means we actually have only 100 sales, considering the first row is taken up with column headers. So 100 is exactly the number we would expect. So it turns out that the count function, like the other arithmetic functions we studied in the last video, ignores non-numeric inputs. As such, this column header here in cell J1 was ignored, meaning that we got an accurate count of our customer orders based on just the numeric values in this column. But what if we wanted to count non-numeric values as well? Let's say, for example, that we wanted to compute the count of customers who purchased at least one shave ice flavor, and then maybe at least 2 shave ice flavors, and then at least 3, and so on. If we look at our 5 columns that track the different flavors that customers opted to add to their shave ice, we see that the cells are either blank, if the customer didn't add that additional flavor, or they contain the text of the additional flavors. Clearly, we need to be able to count our text values here to get the numbers we're looking for. So let's go back to our Summary Metrics tab, where I have a section that's devoted to counting the number of customers who opted for each number of flavors, the number who opted for at least 1, at least 2, at least 3, and so on. So starting in the very first column in cell A14, we'll go ahead and click our Insert Function button again, and we'll again search for count functions. And now if I arrow down past the count function we selected last time, we see the Count A function. And based on the description, it looks like this one might be the ticket, since the description says that Count A counts the number of cells in a range that are not empty, which we could conclude means both numeric and non-numeric values. So we'll go ahead and insert this one. And then for our input range, we'll navigate to column E on the Sales Tracker worksheet, where our first column of flavor selections is stored. And finally, we'll navigate back to the Insert Function dialog box and click Enter. Now, every customer should have had at least one flavor, so our function here should have returned the same number as our count of overall customer sales. However, it looks like our flavor 1 count is actually greater by 1. So how did this discrepancy happen? The answer is that since the Count A function doesn't discriminate between numeric and non-numeric values, it actually counted the column header as just another input. So basically, our Count A function looked at all the values in column A and counted any cell that wasn't blank, and then included the value of our column header, the actual text flavor 1. So to achieve an accurate result, we'll need to subtract 1 from the output of our Count A function. So going back to our formula, I'll click in the formula bar to edit it, and then just tack on a -1, and then hit Enter. And now our 2 counts match. So getting to our remaining flavor counts might be a lot easier than you think, if we leverage the power of relative cell references. Because the column reference in our first formula here is relative, I can simply fill this formula across the 5 columns in our little matrix, and for each column we copy our formula over, the new copied formula's column reference moves 1 column to the right in turn. The bottom line is, it just works. Don't you love it when that happens? Alright, we've managed to compute some useful summary metrics on our Shavice data with just a few strokes of the keyboard. But we're not done using functions to play with numbers just yet. Up next, we'll look at some functions that will help us deal with decimals in our numeric values in precise and specific ways. I'll see you then. Hey, welcome back. So I know I promised that we were going to dig into ways of manipulating decimal numbers that have digits after the decimal place in this video, but I felt compelled to introduce one more cool little feature that pertains to some of the calculations we've studied thus far, like sum, average, and count. But don't worry, this is not going to be a long diversion. This may end up being the shortest video in the entire course. So here we have some sample input data in our example workbook, and I want to show you a way that you can quickly calculate some of the more basic summary statistics on numbers like these without using any formulas or functions. So let me just highlight cells A2 through A6, and then if you'll look down at the bottom right-hand corner of Excel in what's called the status bar, you'll see that Excel is actually populating these basic summary statistics for the numbers I've selected for us, without us having had to write any formulas or functions. We see the average, the count, and the sum listed. And then if I were to highlight more cells, let's say I go all the way out to column C, all of our totals update. And you can probably see where this is going. If I highlight all the way out to include all the data entered into our example workbook, the summary calculations update. Now it's important to note that you can't use these values we're seeing in the status bar, these calculated averages and counts and sums, as inputs to any formulas or functions, nor can these values be stored in the spreadsheet unless you were to just type them into a cell. This feature is really most valuable to do quick and dirty calculations where you don't need to store the result or use it as input in some other calculation, but you just need to know the sum, the count, or the average quickly and then move on with your day. For that purpose, this feature can be really useful and a big time saver as well. All right, I promised this would be short, and hopefully that was short enough. So without further ado, we're going to get on with looking at how to manipulate numbers with decimals in Excel. Welcome back. We've seen how we can use Excel functions to perform calculations on quantitative data, but there are also functions we can use to alter how that data is actually stored in Excel. In particular, the precision with which decimal data is stored. So what do I mean by precision? Basically, the number of digits after the decimal place. Sometimes numbers are only meaningful up to a certain decimal place. For example, we can't charge somebody 99.5 cents for a candy bar. We need to either round that value up to $1 or down to 99 cents. So in general, you probably don't want prices with more than 2 digits after the decimal place. Likewise, we may not want a number to have a decimal component at all. In this case, we could either round the decimal component of the number up or down to the nearest whole number, or simply clip off the decimal component altogether. Let's take a look at a few examples of how these operations work in Excel. So here we have the number 1.2346. If I told you that we wanted to only see 2 digits after the decimal place for this value, your first instinct might be to simply use the formatting tools we've already looked at to format the number such that only 2 digits appear after the decimal place. And while that would make it look like our number has changed, behind the scenes, it's actually the exact same value. So if I select our input cell, and then use the decrease decimal tool up here in the ribbon to reduce the number of decimal places we see down to 2, but then look in the formula bar, we see that the actual value being stored is still 1.2346. So if we want to actually change the value that's being stored, we'll need a different approach. This is where Excel's round function comes in. Round reduces the number of digits after the decimal place to a number that we specify, changing the actual value itself as opposed to just the formatting. So let's take a crack at rounding our input value here to 2 digits in cell C2. Now first, I'll actually just go ahead and reformat our input value back to its original number of decimal places, just so we can better visualize the input we're working with. So now in cell C2, I'll type equals R, O, U, and the round function is helpfully suggested by Excel, so then I'll hit Tab to lock that in. Now the first argument to round is simply the input cell, so that's cell A1, which I'll select, and then we'll type our comma, and the second argument is the number of digits we want to see after the decimal place. So for our first example here, I'll type 2, and now if we hit enter, you'll see that our result is 1.23. The remaining decimal places have been clipped off. And if we were to copy the cell using Control-C, and then right-click, paste special as values to lock in the value returned by our formula, you'll see in the formula bar that the true value of the cell is in fact 1.23. This was not just a formatting trick. Now something a little more interesting happens if we try to round our input number to 3 digits. So if we enter that formula into cell D3, so again I'll type equals ROU, hit Tab to select the formula, and then enter our input cell, and then the number 3 for our preferred number of digits, we see that the output is now 1.235. Now that's weird. Unlike last time, our round function didn't simply clip off any digits past our prescribed limit after the decimal place. If it had done that, our function would have returned 1.234. Instead, the round function actually changed the 4 in the third place after the decimal to a 5. So why did this happen? An important thing to understand about how rounding works is how it attempts to preserve the accuracy of the original number as best it can in whatever digits remain in the number. If we round 1.2346 to 3 digits after the decimal place, Excel wants the shortened number that remains to best reflect the original value. So when getting rid of the 6 in the 4th decimal place, the question becomes, which is closer to the original value of 1.2346, 1.234, or 1.235? Well, since the number 6 is closer to carrying over to the next decimal place than it is to 0, the answer is 1.235. Now by contrast, when we rounded our input to 2 digits, the last digit we clipped off, in the third position after the decimal place, was the number 4. Hence why the function rounded down instead. Now you may be wondering, how does rounding handle the number 5, which seems to be right at the halfway mark? The answer is that the number 5 rounds up. So if I were to change our input value to 1.2345, you'll see that our formula output rounded to 3 digits stays the same, because that 5 is still rounded up. Basically, if the last digit being removed by the round function, that is to say the first digit after whatever digits that we're keeping, is 5 or greater, then the digit before that is rounded up. Otherwise, it stays the same. So we've looked at how to alter the number of digits after the decimal place. But what if we want to remove the decimal component of the number altogether? Sometimes mathematical operations yield decimals that don't make any sense in real life. You might perform some calculation on the inventory of cars at a car dealership that yields some number with a decimal component. but in the real world, there's no such thing as a third of a car, at least not one that you'd try to sell. Fortunately, removing or truncating the decimal component of a number is even easier than rounding. You can simply use Excel's trunc function to do this, and that's TRUNC, as you'll see. So in cell E2, if we type equals TRU, you'll see that one of our options that remain is the trunc function. So we'll arrow down to grab that guy, and then hit Tab to lock it into our cell. And then the only argument we need is just our input number, so we'll select that, and then hit Enter. And we see that we're left with the whole number 1. Now, one thing worth noting about trunc versus round. You can actually perform this exact same operation with the round function by simply specifying the number 0 for the digits after the decimal. So I could type round, and then our input, and then the number 0, and we get the same result. The difference comes when the decimal that's being removed is greater than or equal to 5. In that case, the round function will actually round our result up to the next digit, whereas truncate simply removes the decimal altogether regardless of whether it's greater than or less than 5. So for example, if I changed our input value to 1.5, our round function returns 2. But if I change it back to trunc, it's still 1. In short, round cares about what comes after the decimal place and tries to make our modified number as close to the original value as possible while also clipping off however many decimal places we specify. Trunc, on the other hand, simply wipes out anything after the decimal place, leaving whatever whole number remains. All right. With that, we've covered the most basic and foundational formulas for manipulating and calculating numerical data in Excel. However, Excel has way more tricks up its sleeve when it comes to crunching numbers than what we've seen so far. It also has more than you'd ever want me to cover in this course, or 5 courses for that matter, but there are a few statistical functions that are widely applicable in the business world, which can add value for almost any Excel user. We'll start our exploration of those in the next video. I'll see you then. Welcome back. By now, you should be comfortable with performing all the fundamental flavors of summary statistics in Excel: sums, counts, and averages. But there are some other statistical measures that in today's increasingly data-obsessed world are darn near essential for any business professional to have in their toolbox. One of these is median, which serves a similar yet distinct purpose versus average. Now, full disclosure here. If you're already comfortable with the concept of median and how its use differs from taking a simple average, all you really need to know is that the median function in Excel works just like the average function, except that it returns the median of a data set instead of the average. So if you have a solid understanding of median, feel free to skip this video, or maybe take an opportunity to apply the median function to some sample data just to refresh your memory. But if you're not super familiar with this concept, or have a dim recollection from a math or stats class you took years ago, stick around and we'll explore how the median function is just as useful, and in many cases more useful, than the average function. So median, like average, is what's known as a measure of central tendency. This means that it attempts in some way to describe the middle of our data, so to speak, the typical data point, as opposed to extremes at the high and low end of the spectrum. But average and median each have their own unique ways of going about this. The word average is deeply embedded in our lexicon and widely understood to represent a typical example in a larger population. But the definition of what typical means is key. Average works by adding all of our data points and then dividing that total by the number of data points we're averaging. And this can yield a result that is fairly representative of the quote-unquote typical item within our data. But not always. Extremely large or small values in our data, relative to the rest of the values, can distort or skew the average of a data set. Median attempts to resolve this by looking at our data as an ordered list of values, sorted from smallest to largest, and then simply plucking out the value that happens to fall into the middle of the pack. As such, median is able to ignore exceptionally large or small values at either extreme, since it's only concerned with the actual values that happen to physically live in the middle of our data. But all that is a lot of theory, without seeing any examples. So let's take a look at how average and median work differently on identical data sets. Now here we have two lists of employee salaries. One with an odd number of salaries, 11, and one with an even number, 10. You'll see the significance of this soon enough. First, let's take the average of the first list of salaries using the average function we're now so familiar with. So in cell B14 here, I'll just type equals average, and then I'll just drag down through my range of cells to select them and hit enter. But next, let's try to take the median of this same list. So using our tried and true technique, I'll type equals MED, and Excel's autocomplete is kind enough to suggest the median function. So I'll go ahead and hit tab to select it, and then I'll enter the argument for this function the exact same way I did for average, just by dragging down across my list of salaries to select them, and then I can just hit enter. And we see that the median function returned a result that was somewhat close to, but still different from, the average. So let's explore exactly how median got to this result. If you look carefully at the list of employee salaries, you'll see that they're sorted in ascending order, from smallest to largest. There are 11 salaries listed in total, meaning that the sixth salary is at the exact midpoint between the first salary and the last. And if we arrow down through our values to the sixth salary, we see that it is the same number that our median function returned. So again, median simply sorts our data behind the scenes and then returns whatever value falls into the middle of the sorted values. Now please note that it's not necessary to actually sort your data for the median function to work. I just sorted it here to make it clear as to how the function works. So we see that average and median take different approaches to get a similar result. But if the results are so similar, why am I going to the trouble of showing you a completely different way of doing things? The answer is that these functions won't always return similar results. That all depends on our data. The salaries we see here are relatively similar. There's not a lot of spread, so to speak, in the data, nor are there outliers, values significantly larger or smaller than a typical one. But let's say we add an outlier. Let's say we make our 11th salary here, just for grins, maybe a cool $1 million. And now we see where average and median really diverge. Our average value jumped significantly in response to just one of our salaries increasing. Meanwhile, the median stayed exactly the same. This illustrates how median is more resistant to extreme values in our data, distorting our view of what a typical data point looks like. Now that's not to say that there aren't scenarios where taking the simple average of data sets isn't also valuable. You may actually want to have visibility into how those large and small values affect your overall population average. But from my experience, in the very common case where you're looking for a single number to capture a typical item within your data, median is the best bet. Now before we move on from median, we still have one little riddle left to solve. How does it handle data sets with an even number of items instead of an odd number? Finding the median of our first list of salaries was straightforward, since there was a data point, our sixth value, such that there were an equal number of other data points that were larger and smaller. But in a data set with an even number of values, like our second list of salaries, there is no one value that slots in the exact middle of our data. So how does median handle those scenarios? Basically, by doing its best to approximate a central value, even though one doesn't technically exist. It does this by taking the average of the two values closest to the middle of the data. In this case, given that our data set has 10 values, that would be the fifth value and the sixth value. So if we just average those numbers off here to the right, so if I type equals, average, and then I just average our fifth value and our sixth value, we get around $60,000. And if we then fill our average and median functions from our first set of salaries across to look at our second set, we see that the median we get is the exact same. All right, up next we're going to look at one more statistical function in Excel that is increasingly becoming a prerequisite for fluency in the language of business. I'll see you then. Hey, welcome back. Before we move on from the math stuff, I have one more statistical function to throw at you that just about anyone working in either the business or scientific communities can benefit from understanding: standard deviation. Now, just as with median, if you feel like you've got a good handle on standard deviation, feel free to skim this video. The one part of interest to you will be the difference between Excel's two variations of the standard deviation function, one that applies to an entire population and one that applies to a sample population. So what exactly is standard deviation? Now, unlike most tutorials, I'm not going to throw up a slide here with the obligatory mathematical formula for standard deviation that you'll turn around and forget 5 minutes later. And that's because you don't need to remember the formula. Excel remembers it for you. This is a great illustration of the power of functions in Excel. As long as you have a conceptual understanding of what it is that you're trying to accomplish, Excel can handle the heavy lifting of memorizing what formula input goes where behind the scenes. But the conceptual understanding, the intuition, on the other hand, is in fact very important. So conceptually, standard deviation is essentially a measure of the variability or noise in our data. In other words, how spread out it is. This spread, so to speak, is judged relative to the average, otherwise known as the mean of our data. So if the individual data points in our data set are very close to the overall average of the data set, the standard deviation will be small. But if those data points tend to be very far away from the average, our standard deviation will be larger. Two data sets can have the same average, and even median for that matter, but wildly different standard deviations. For example, if we take the list of numbers ranging from 6 to 10, we see that the average and median are both 8. The standard deviation, meanwhile, is 1.41. But if we subtract 5 from the smallest value, and then add 5 to the largest value, the average and median both stay the same, but the standard deviation increases because now two of our values are further away from the quote-unquote middle of our data. When it came to average and median, the subtraction of 5 from the first value was offset by the addition of 5 to the last value. But as far as standard deviation was concerned, both of these changes mattered because they both involved data points moving further away from the average of the overall data set. To cement this concept further, let's look at some more examples of employee salaries. So in our first list, we have a somewhat equitable range of salaries. So let's try calculating the average, median, and standard deviation on these. First, we'll go ahead and punch in our average and median functions, which is pretty trivial for us by now. So I'll just type equals average, highlight my input range, and then I'll do the same for my median function. And now we can begin our search for the standard deviation function. So I'll type equals ST, and now we see a couple of options. There is an stdev.p function, but there's also an stdev.s function. Now these both seem like they would relate to standard deviation, and if I arrow down over the functions, it looks like they both do. But how do we know which one of these options to choose? Well, I want to make it easy for you. If you're a hardcore stats person and have an easy fluency with concepts like population mean versus sample mean, then you can just make a strategic decision as to which variation to go with. The stdev.p function calculates standard deviation for an entire population, while the stdev.s function calculates it for a sample population. Now, if you're not a hardcore stats person, but rather a business professional trying to get a better read on your data, you're most likely going to want to stick to the stdev.p function, since most of the time, the data you're applying it to will represent an entire population rather than a statistical sample. Since this is a more business-focused course, we're going to stick with that variation of the standard deviation function from here on out. So let's select that one by hitting Tab, and then select our range once more, and hit Enter. And we get around $27,000. So far, so good. We'll get into how to interpret this number in common sense terms in just a bit. Now, our second list of salaries has a lot more variation, or spread, than the first. You can see that the first 5 values are somewhat low relative to the overall trend, while the second 5 are quite high. But spoiler alert, the overall sum of these salaries is exactly the same as our first list. The values are just distributed differently. So what do you think that means for our standard deviation versus our average? Well, let's find out. Since we've already written our functions against the first column of salaries, we can just fill them across to the next column using the fill handle. So I'll just highlight our formulas, hover over the bottom right corner of the range until I see my fill handle, and then drag to the right. And now we see that our median is similar, and our average is identical to our first data set. But our standard deviation has gone up significantly, reflecting the greater average spread of our data. So at this point you might be wondering, while we now understand why the standard deviation may be bigger or smaller based on the variability within our data, how do we actually interpret the number returned by the standard deviation function? What does this number I see here, this $48,219, actually mean? Roughly speaking, you can think of this number as the average deviation from the overall population average. That is to say, the average amount by which an individual salary in our data set varies from the overall average of the salaries. Now, this isn't an exact mathematical definition. You'll have to refer to somebody else's slide with the standard deviation formula for that. But it's close enough to what standard deviation does to interpret the number effectively. All right. Up next, we're going to return to our familiar and comfortable arithmetic functions, sum, count, and average, but with a whole new spin that we haven't seen before: the ability to apply these calculations conditionally, based on criteria we specify. This opens up a whole new world of possibilities when it comes to calculating metrics, and can elevate your skill set from mere number crunching to something more closely approaching actual business intelligence development. I hope you're as excited as I am to get started. Welcome back. So remember our fledgling little budget spreadsheet we touched on at the end of the last section? Well, now that we've learned how to crunch numbers with Excel functions, it's time to apply some of that knowledge to build out our budget's functionality just a bit more. So here I'm using the solution file from the last iteration of the project as my starter file here. But you should feel free to use your solution from the last iteration as the jumping off point if you feel good about it. But if you'd rather use the starter file, that's perfectly okay. And that will remain true throughout the rest of the project. So what I want you to do in this one is first create two lists in our spreadsheet. One for all of our sources of monthly income, and one for our different categories of monthly expenses. And then use an Excel function to sum our estimates for these income sources and expenses to dynamically populate the two main inputs to our budget. Of course, income and expenses. Now, I already have lists of example expenses and income sources in a separate spreadsheet called Income and Expenses, so all you need to do there is copy those lists into their own worksheets in our Master Budget Workbook. Then I want you to use an appropriate Excel function to populate our total income and total expenses input cells with the data from those lists. Now note that while we could technically fit all this information, both our budget that we see here and also our lists of incomes and expenses on this same worksheet, I'm a huge believer in keeping the purpose of each worksheet in a spreadsheet tightly focused to a single purpose, and moreover to limit the clutter on each worksheet such that you can usually see everything you need to see without having to scroll around. This results in spreadsheets with more tabs, but I think the lift you get in terms of usability and readability is worth the trade-off. So without further ado, pause the video here and try to build this out on your own. Then when you're ready, just unpause the video to see my solution. I'll be waiting patiently. Okay, so I hope that went well. Now for the first step of my solution, just a quick housekeeping item. I'm going to rename our main sheet here to Summary since we're going to be adding new worksheets. And now I'm going to create two new worksheets, one called Monthly Income and another called Monthly Expenses. And now I'll switch over to my other spreadsheet that has lists of example income sources and expenses. So first I'll copy the list of income sources and paste that into our monthly income worksheet. And then I'll auto-fit column widths just to clean this up just a bit. And then back to our other worksheet, I'll copy our list of expenses and then drop that into the expenses worksheet. And again, auto-fit column widths. So now that we have this data in our spreadsheet, the next step will be to dynamically populate the cells in our budget containing our monthly income and our monthly expenses using a built-in function that points to the data on our monthly income and monthly expenses worksheets. So that will obviously be the sum function. So here in cell C3, I'll type equals sum. And now I'll go to my monthly income worksheet. And instead of just highlighting the three cells that have data, I'm actually going to select all of column B. That way, if at some point we decide to add more income sources, our function will capture those as well. So I'll close that parenthesis and hit enter. And now our monthly income input is populating dynamically. So next I'll do the same for expenses. And I notice here that my column B is not quite wide enough to accommodate all of my input labels, so let me double click between B and C to widen that out. And at this point it looks like we have everything working, but just to verify, let me modify one of our expenses and make it, well, more expensive to see if our model captures that change. So instead of our miscellaneous expenses being $100, let's say they're $10,000. And now we'll go back to our summary worksheet. And suddenly we see that our expenses are significantly more than our income, and our cash balance is now negative. Yikes. So that's so ugly, I think I'll go ahead and change it back. And now I'm feeling much better about our budget. So as you can see, due to the flexibility in how we set up our solution here, you're free to add or remove expenses and income sources as needed, or even change those values, and our model will still work. Okay, now it's time to dive back into more new Excel features, but we'll revisit our budget project soon enough. I'll see you next time.
Hell yeah, you made it all the way to the end of the course. So for that, congratulations. But don't get too comfortable because like I mentioned before, there's still lots to learn. Travis's Complete Excel Bootcamp course features 13 different module sections, and this crash course only included the first 4. So keep that ball rolling and take the rest of the course if you're serious about becoming an expert at Excel. You can click on the link in the description below or watch the video right there on your screen to see everything you'll learn in the rest of the course. And if you're lucky enough, you might find the limited time coupon code in the description below as well. Okay, one last thing. If you enjoyed this crash course and the 6 hours of completely free content, the least you could do is show Travis some love by dropping this video a like and let him know your thoughts in the comments below. That's it for today, and I look forward to seeing you inside the Zero to Mastery Academy.